Hey everyone, and welcome back to the channel. And today we've got a very exciting video because we're going to be starting a brand new series here on the channel. We're going to be looking at how you can become a Microsoft certified Fabric Analytics engineer. Bit of a mouthful. You might know it better as the DP-600 exam that you need to pass if you want to get this certification. Now, a lot of people have been asking me about DP-600. How do I get certified? What do I need to learn? And so in this course, what I'm going to be doing is bringing together everything that you need to know for this certification so that you can hopefully pass first time. So what are we going to be doing in this video? Well, this is a bit of an introduction. Okay, so we're going to be looking at what's in the exam. What are some of the details of the exam? So how long is it? How can you pass? Do you do it online or in person? That kind of thing. We're going to look at an overview of this course. So specifically, what are we going to learn in this course in YouTube and how are you going to learn as well? Then we're going to finish by looking at why you might want to take this course and why you might want to get Fabric Analytics Engineering certification in general. So what's in the exam? So the first section is around planning, implementing and managing solutions for data analytics. Now within that, we've got various kind of sub-modules, okay? So you'll need to understand the requirements. How do we identify requirements for solutions? How do we do things like security? How do you know the difference between different data gateways? How do you set up access control and workspaces and capacities? And how do you modify the settings of all these things as well? Another important section of the exam and being an analytics engineer in general is version control. You'll need to understand how to set up version control for Azure DevOps, understand some of the settings and the configuration options that entails, as well as some of the deployment pipeline functionality as well. Now, this is not a completely exhaustive list of what's in that section of the exam. We'll go through each of those in a bit more detail. It's just the high level kind of areas that are covered in that section. And this section is worth 10 to 15% of the exam. So it's a small section, but it's a very important section, I think, anyway, in terms of becoming an analytics engineer. These are really important topics that you need to understand. So up next, we've got 40 to 45% of the exam. So this is really the core of the exam that you should probably spend most of your time studying, okay? And it's around preparation and serving of data. So this is one of the core tasks that you'll be asked to carry out as an analytics engineer. And within that, we've got quite a lot of really important topics, okay? So you've got understanding the lakehouse. How do we set one up? How do we create tables, difference between tables and files? The warehouse, so the T-SQL experience. Creating shortcuts, ingesting data from external locations into our warehouse or our lakehouse. What are the different methods that we can choose here and when do we choose specific ones, okay? Then we've got data transformation. So once we've got our data within Fabric, we might want to do some transformations on it. Now you can do that with T-SQL, Spark, and you will need to know at least the basics of T-SQL and Spark and also DAX in the next section as well. So there's quite a lot of languages that you need to know to kind of an intermediate level, I would say, for this exam. Next, we've got performance. So how do we optimize performance, both in terms of the getting data into Fabric, but also in terms of the transformation piece. So if you've got Spark jobs that are running really long, or you've got some T-SQL scripts that are really not performing very well, they're taking a long time to kind of return your data, what can you do to monitor performance and then optimize it? And as I mentioned, you will need to know PySpark and T-SQL to a kind of intermediate level there. So that's something to bear in mind for this exam. So the next section of the exam is around implementing and managing semantic models. And this is worth 20 to 25% of the exam. And within this category, you've got the different storage modes. So direct query, import mode and direct lake mode, and kind of understanding how these things work, how to set up direct lake mode, when to use it, maybe when not to use it. You're going to need to have a good understanding of DAX here. There's quite a few questions around DAX and DAX Studio and Tabular Editor 2 as well. So these are kind of things that you need to be aware of, because you'll probably get some questions around that as well. Also within this section, you've got data modeling. So things like star schemas, bridge tables, how do we deal with many-to-many relationships? And also we've got things around security. How do we set up row-level security within your semantic model, object-level security, and how do we validate that that's actually working correctly? So in the final section of the exam, which is worth around 20 to 25% again, is explore and analyze data. So here we're really looking at the analysis part of being an analytics engineer, because most of your role might be around the engineering piece, but really you need to know the analytics side of thing as well, because that's going to make you a much better analytics engineer. So in this section, you're going to be asked questions about data analysis, specifically using T-SQL. Okay, so analyzing your lakehouse SQL endpoint, analyzing your data warehouse, coming up with insights from data using T-SQL. You'll also be asked about data profiling, so understanding the profile of different tables based on some of the profiling metrics that you get, and also analyzing data via the XML endpoint. So that's another part of this section of the exam. So these are the 4 sections. There's quite a lot to go through, and it covers quite a broad range of skills that you need to know, from PySpark, T-SQL, DAX, data modeling, getting data in, data modeling, serving data in semantic models as well. So quite a broad range end-to-end exam. So in the exam, there is between 40 and 60 questions, and the results are scaled, and you get given a result between 0 and 1000. So the pass mark here is 700 out of 1000, and that's a scaled score. So that's something to bear in mind. And the questions can be of different types. Okay, so some of them are multiple choice, some of them might be a case study, and the case studies normally take 2, 3, 4 questions. So you really need to understand what's going on, and you get multiple questions about the same case study. You also have things like drag and drop and ordering lists. And for a full list of the question types, I recommend you go to this resource here. It's on the Microsoft Learn, the exam question section of Microsoft Learn. And I'll leave a link to that in the description below. You can also use the exam sandbox that provides you with a sandbox experience of the exact question types that you can expect in the exam. You'll get given 100 minutes to actually carry out the exam. You should set aside at least 2 hours though, so 120 minutes for the exam, just so that you can kind of get in, get settled. As I mentioned, it's 700 out of 1000 to pass this exam, so 70%. You can take the exam either in person in Pearson VUE centres, or you can do it online. So my personal recommendation would be to take the exam in person if you can. It kind of eliminates a lot of the doubts and the problems around like Wi-Fi and worrying about your desk setup, and your room has to be a very specific layout. And so if you can visit a centre in person, I think it's a lot better, because you can just walk in, take the exam and walk out. Whereas online you have to think about lots of different things. For me, it's less stressful to do it in person if you can. So there is an exam fee, which is $165 for people in the USA. It varies for different countries, but if you look on the right hand side, we've got a free exam. So if you're very quick and you go to the link in the description and you complete the Fabric AI Skills Challenge training course before the 19th of April, so you've only got a few days, you can get a voucher to take the DP-600 exam for free. So you can do that skills challenge training very quickly, get your free voucher, and then watch all of this series on YouTube. And as long as you take that exam, I think it's before June the 22nd or something, so you've got 2 or 3 months to kind of go through the material at your own pace, and then you get to save yourself $165 or the equivalent in your currency in your country. So this is what this series is going to look like here on YouTube. We've got the first video, which is an introduction to the course. Then I'm going to be covering all 11 chapters of the exam, and the content is going to be delivered through various real-world scenarios, because I want to make this content interesting for you and also make it relevant for you if you could want to be an analytics engineer, or if you are an analytics engineer currently in your career. And to do this, I'm going to be combining theory. So I think there is some theory in some of these modules. You do have to understand how things work, but then practice as well, how to actually implement this stuff in Fabric at the same time. Throughout the course, I'm going to be reinforcing that knowledge as we go through and asking rhetorical questions as well as sample questions. And at the end, I do plan to go through a full video, kind of like a practice paper, let's say, designing lots of questions that you can expect within the exam. As with all of my courses, all of the resources and module notes and scripts and notebooks and all this kind of thing, I'll be posting that in the school community. So if you're not already a member there, I'll leave a link in the description below. It's completely for free, so make sure you sign up, and yeah, you'll get access to all of that. So there's a few reasons that I just want to cover quickly here around why you might want to take this course and then go on to become a certified analytics engineer. Well, the course gives structure to your learning. Microsoft have given us a study guide, and they've said these are what we think is important to learn for an analytics engineer. So it gives you a really good pathway to follow. It might also help you get a new job having that certification on your CV is definitely not going to hinder your chances. It would also be good to go into kind of promotion talks or pay rise talks with your boss and say, yeah, well, last year I did the certification. And this is especially true if you work in a consultancy, right? Because consultancy, they're kind of selling your skills and your experience. So if you have certification, then that can help them win work in the future. So in this lesson, we've looked at what's in the exam. We've looked at some of the exam details. We've also looked at the overview of this course. So what are the different chapters that we're going to be looking through and why I think you should take this course. Join us in the next lesson where we'll be starting the course properly and we'll be looking at how to plan and implement a data analytics solution. Hello and welcome to this first chapter in this DP-600 exam preparation course. We're going to be looking at how to plan a data analytics environment in Fabric. Now, this is the first chapter in 11 chapters that we're going to be going through, teaching you everything you need to know to hopefully pass the DP-600 exam. In this chapter, we're going to be covering exactly what you need to know. If you look at the study guide in Microsoft Learn, these are the elements that we're going to be covering. How do we identify requirements for a solution? So the various components, features, performance, capacity, SKUs, that kind of thing. How do we make decisions about that? We're also going to be looking at how to recommend settings in the Fabric admin portal. How do we choose data gateway types? And also creating custom Power BI report themes. Towards the end of the lesson, we'll be testing your knowledge with 5 sample questions. And just as a reminder, all of the lesson notes and key points and link to further learning resources, they're going to be published on the school community. So if you're not already a member, I'll leave a link in the description. Now you will play the main character in a scenario, and this scenario is going to walk you through everything you need to know for those 4 elements of the study guide. Are you ready? Let's begin. So you are a consultant and you're starting your first day on a new project, and this is Camilla. She is your client for the project. And on the phone before the meeting, Camilla had mentioned that she wants to implement Fabric, but she doesn't know really where to start. And that's where you come in. You're going to start with a requirements gathering workshop. So you organize a full-day workshop with Camilla, the client, to truly understand their business and their requirements. Now, your goals for this workshop are to extract a set of requirements from the client to help you build a plan for their new Fabric environment. And another goal is to do such a great job in planning their environment that the client is going to give you a new contract by the end of it to build the thing. Okay, so this requirements gathering workshop, what are you going to ask Camilla? What do you need to know when you're identifying the requirements? You should think about focusing on these 3 elements to begin with. The capacities, so how many do we need? What sizing do the capacities need to be in this new environment? Then we're going to look at data ingestion methods. So there's lots of different ways that we can ingest data into Fabric. You're going to ask a set of questions that's going to kind of deduce the best method for getting data into Fabric based on the requirements. Similarly, we've got data storage. So we've got 3 different options for storing data in Fabric. How do you ask the right questions and identify the requirements to choose the right one? So let's start off thinking about capacity requirements. Now, the requirements that we need here are really the number of capacities that are required and the sizing. So the SKU, the stock keeping units. You probably know by now that in Fabric, we have capacities of varying sizes. So what determines the number of capacities required? So from previous videos, you've probably understood that one of the things that impacts the number of capacities required is compliance with data residency regulations. So the capacity dictates where your data is stored. So if you have regulations that dictate that your data must reside in the EU, for example, for GDPR, that's going to be one capacity in your business. If you have other requirements that say these data sets need to be stored in the US, you're going to have a separate capacity for that as well. Another thing that can impact the number of capacities is the billing preference. So the capacity is how you get billed in Fabric. So some organizations might want to separate the billing between different departments in their organization. So they might have one capacity for the finance department, one capacity for your consulting division, one capacity for your marketing department, for example. Another thing that could determine the number of capacities that you need is segregating by workload type. So if you have a lot of heavy, intensive data engineering workloads, then you might want to put those in a separate capacity and give it enough resource to allow you to do that in a confined capacity. Then your serving of business intelligence, you might want to do that in a separate capacity so that the read performance on those kind of dashboards is not impacted by the heavy data engineering stuff and maybe machine learning stuff that's being done in other capacities. You might also want to segregate by department, just through business preference as well, aligned with that billing preference. So some companies like to have their capacity aligned to various departments within their business. So these are the things you need to extract in terms of requirements when you're talking with this client. And what about the sizing? Well, we've touched on that already, but some of the things that impact the sizing of a capacity are the intensity of the expected workloads. So are you going to be doing high volumes of data ingestion? Are you going to be getting gigabytes of fresh data into Fabric, or even terabytes of data into Fabric every day? These are going to use a lot of your resources, and to go through them quickly, it helps if you have a higher capacity. Similarly, heavy data transformations. So if you're doing a lot of heavy transformations in Spark, that's going to use a lot of resources. So if that's something you're going to be doing regularly in your business, you want to be choosing a high capacity for that. Again, machine learning training can be very resource intensive. It's going to take hours or sometimes even days to train a machine learning model. If that's something you're going to be doing regularly, you want to be having that on a high capacity. The budget of your client also dictates the capacity, the sizing of the capacity that you're going to choose. Obviously, the more resources, the higher that SKU that you decide, the more expensive it's going to be. And some clients might be very sensitive around the cost. And related to that is, can you afford to wait, or can the client afford to wait? Because if you procure a F2 SKU, it's probably going to go through your data, but it might take a very long time. And in some business, that might not be a problem. Maybe you're just doing data ingestion once per day. You ingest all of your fresh data, and it might take a lot longer on an F2 capacity, but that's not necessarily a problem. Maybe you can do it overnight, and by the time people come in the morning, all of that data has been ingested or transformed, and it's ready for consumption in the morning. So what's your propensity to wait? Now, some other companies might have regular data coming in every hour, like gigabytes of data every hour. And in that scenario, you really need a high capacity to be able to churn through all of that stuff and get it processed before the next hourly load, for example. Another thing that can determine the sizing of the capacity is, does the client want access to F64 features? So there's quite a lot actually of features that open up when you get to F64. So Copilot being a good example currently. And there's many, many more. I'll list them on the screen here. These are features that only really are available if you choose F64 capacity or above. So that's something to bear in mind. If you want to use any of these features, you need an F64 plus. So what about the data ingestion requirements? Well, here, what we really need to know is, what are the Fabric items and or features that you need to get data into Fabric? And how are you going to configure these items once you've built them? Now, some of the options here, and this is not an exhaustive list, there's lots of different options here. We've got the shortcut, database mirroring, ETL via a data flow, ETL via a data pipeline and a notebook, and the event stream. So these are some of the options that you might want to consider. So what are the questions that you need to ask of a client when you're identifying the requirements to help you make the decision here? Well, these are some of the deciding factors. The main one really is, where is the external data stored? If it's in ADLS Gen 2, Amazon S3, or an S3 compatible storage location like Cloudflare, for example, Google Cloud Storage or the Dataverse, well then these are the ones that are going to be available for you to shortcut into Fabric. So if you get any questions in the exam around, my data is stored in ADLS Gen 2, well, obviously the shortcut is a good option for that. Now, it's not necessarily the only option. You can still do ETL via any of these storage locations, but it does open up that shortcut possibility. Now, if you see Azure SQL, Azure Cosmos DB, or Snowflake mentioned, then immediately you should start thinking, okay, this could be database mirrored. So you can use database mirroring to create that kind of live link to the database, and it's going to maintain a mirror inside of Fabric. Is it on premises? Now, if your data is stored on premises, then you're going to probably want to be using the ETL via Dataflows or data pipelines, because these two activities, these two items, allow you to create that on-premise data gateway on your on-premise server and then connect to that via the data flow or the data pipeline. And if you've got real-time events, real-time streaming data, obviously you probably want to using the event stream to get that data into Fabric. Anything else, really you're going to be looking at ETL via either the data flow, the data pipeline, and the notebook. And when to choose which one, well, I've done a very long video. I'll leave a link in the description, or you can click here to make that decision about which of these is best for that particular organization. So related to that is also what skills exist in the team, because you don't want to build a solution that can't be maintained and managed by the company or your client's company. So if you're looking for a predominantly no and low code experience, then you're going to want to be focusing on the ETL via Dataflows and data pipelines. Both of these are fairly low and no code experiences, help you get data into Fabric. If you've got a lot of SQL experience in your team, then here you can be using the data pipeline. You can use the script activities to do transformations on your data as it's coming in. And if you have people that are familiar with Spark, Python, Scala, that kind of thing, then you can use the ETL notebook. If you're, perhaps you've got data coming from a REST API and you want to be using Python libraries to get that in, that's a good option for you there. So whilst we're on the topic of data ingestion, there's a few other features that you need to be aware of that might come up in the exam that can help you identify different requirements for getting data into Fabric. These are the on-premise data gateway, which we mentioned, the VNet, the virtual network data gateway, fast copy, and staging. So you might be asked some questions about these things in the exam as well. So when do we decide on these sorts of things? Well, you need to ask how the data in the external system is being secured, right? So if it's on-premise, if it's an on-premise SQL server, you have to be using the on-premise data gateway. If your data is living in Azure, behind some sort of virtual network or private endpoint, that kind of thing, then you want to be setting up the VNet data gateway to access that. And in terms of the volume of data, this is also going to have an impact on the items that you choose for doing your data ingestion and also some of the features available. So if you've got low or medium data per day, well, if it's low, then you probably don't need any of these specific features, like the out-of-the-box solutions will be good enough. But if you've got quite a lot of data, kind of gigabytes per day in that kind of range, you want to be using some of the features like fast copy and staging. Similarly, if you've got very high amounts of data, these are going to be one of using the fast copy and the staging. If you're using data flows, alternatively, you can use data pipelines. And if you can get data in via a Fabric notebook, then that's another option as well. So before we move on, I just want to mention a bit more detail around the data gateways. Now, as you probably know already, there are two types of data gateways that we can configure in Microsoft Fabric. Number one is the on-premise data gateway, and number two is the virtual network data gateway. And a data gateway, in essence, helps us access data that's otherwise secured. So if this data is on an on-premise SQL server, for example, it gives us a secure way to access that data and bring it into Fabric. Likewise, if you've got data behind a virtual network secured in Azure, in like blob storage or ADLS Gen 2, it provides us with a secure mechanism to access that data. So I'm not going to show you step by step how to set up a data gateway in this lesson, but what I have done is link to two other videos by other creators that show the process in detail. If you want to go and have a look, I'll leave that in the school community. But I do want to just cover kind of the high level process for each of them, just so you understand a bit more about what that looks like if you've never set one up before. So for the on-premise data gateway, there's a few high-level steps. Number one, we need to install the data gateway on the on-premise server. And if you've already got an on-premise data gateway set up on your on-premise server, perhaps you're using it in traditional Power BI data flows, for example, then you're going to need to update it to the latest version because that's going to be compatible with Microsoft Fabric. The next step is to, in Fabric, create a new on-premise data gateway connection. And then from that, you can connect to that data gateway from either a data flow and now also a data pipeline. So the data pipeline was recently added in the last few weeks. I think it's still in preview, that connection. So you might not get asked about it in the exam, but it's good to know that now it's actually possible via the data flow and the data pipeline. To set up the VNet data gateway, well, you're going to start in Azure. There's a few settings that you need to configure in your Azure environment before you can set up the VNet data gateway connection. So you're going to need to register a Power Platform resource provider within your Azure subscription. And then within the item that you want to share or you want to access, for example, in your Azure blob storage item in Azure, you need to create a private endpoint in the networking settings, and then create a subnet. And then we're going to use that in Fabric to create a new virtual network data gateway connection. And then again, from that, you can connect to it via your data flow to be able to access that data that is behind that virtual network in Azure. So next, let's look at the data storage requirements. And when we're talking to our client here, identifying requirements, really what we're trying to extract is, okay, what Fabric data stores are going to be best for these requirements, and what overall architectural pattern are we going to be aiming for with this solution. Now, the options here are obviously the lakehouse, the data warehouse, and the KQL database. And some of the deciding factors to choose between these are, well, what's the data type? Okay, so is it structured or semi-structured or even unstructured? So are you going to be getting raw files, CSV, JSON, maybe from a REST API? Is it unstructured? Is it image data, video? Is it audio data, for example? These are all going to be wanted to store in the lakehouse, because this is kind of the only place in Fabric where you can store a variety of different file formats. If your data is relational and structured, then obviously you can keep that in either the lakehouse or the data warehouse. And if it's real-time and streaming, you're going to be want to streaming that into your KQL database. Next up, another important consideration when choosing a data store is what skills exist in the team. So if you're predominantly T-SQL based, then you're going to want to be using the data warehouse experience. If you're predominantly Spark and Python, Scala, that kind of thing, then you're going to be wanting to storing your data predominantly in the lakehouse. And if you're predominantly using KQL in your organization, that's going to be wanting to using KQL database for your data storage. Congratulations, you've completed your first engagement for Camilla. You've convinced her to set up a proof of concept project in her organization. So she's already created the Fabric free trial. She's set up her environment, but immediately she's hit a bit of a hurdle. So this is your next mission. She rings you up and she says, hey, I need some help. I opened the Fabric admin portal and nearly had a heart attack. Please, can you help me understand all of these settings? So you set up a call with Camilla to help her understand the Fabric admin portal. How are you going to teach her, and what are you going to teach her about the admin portal? What are the most important settings that she needs to know about? Okay, just before we get into the Fabric admin portal and look at some of the settings available to us in there, it's important to note that to be able to access the admin portal, of course, first you need a Fabric license, but then you need to have one of the following roles. You need to be either a global administrator, a Power Platform administrator, or a Fabric administrator. So within the admin portal here in Fabric, you'll see this menu on the left-hand side. So these are some of the important settings in tenant settings. Here you can allow users to create Fabric items. So if you just set up Fabric in your organization, you need to allow people to actually create Fabric items. Without that, you can't really get very far. Enable preview features. So every time Microsoft release new features, normally they put them in the admin portal and you can allow or disallow users in your organization to use them. You can also allow users to create workspaces. There's a whole host of security related features that you can manage and get control over in your tenant. So for example, how do you manage guest users? Allowing single sign-on options for things like Snowflake, BigQuery, Redshift accounts, that kind of thing. How do you block public internet access? So that's really important to know. Enabling other features like Azure Private Link, for example, allowing the service principal access to the Fabric APIs. So if you're going to be doing some automation, you need to allow access to service principals to the API. There's also options in there for allowing Git integration. So if you're setting up version control, that needs to be enabled there. And there's also some features like allowing Copilot within the organization as well. Now, in general, some of the settings can be one of three things. It could be enabled for the entire organization. It can be enabled for specific security groups. So say you only want super users to be able to use this feature, or admins within your Fabric environment to use a specific feature, then you can enable it for specific security groups. Or you can enable it for all except certain security groups. So everyone in your organization gets access apart from these people. Perhaps guest users is a good example. Now, other settings in the Fabric tenant settings are kind of binary. You either enable them or you disable them for the entire organization. Another important point in the Fabric admin portal are the capacity settings. So this section here, and in here you can create new capacities, delete capacities, manage the capacity commission, and also change the size of a capacity. So these are some important capacity settings that you need to be aware of, understand how they work and how to manage them within your Fabric environment. So great, you've taught Camilla about the Fabric admin portal and she's very grateful. But before the meeting ends, she has one more thing she wants to ask you about. She says, one final thing before you go, and it might seem a bit random, but when we migrate to Fabric, I want our BI team to create more consistent reports. Have you got any ideas about how we can achieve that? And of course, the first thing you think of are custom Power BI report themes. Now, there are many ways to create a custom report theme in Power BI. You can either update the current theme if you're in Power BI Desktop, or you can write a kind of JSON template yourself using the documentation. If you're feeling a bit brave, you can do that yourself. Or you can also use a third-party online tool. There's quite a few report theme generator tools that exist online, but it's unlikely you're going to be tested on that in the exam. So your task is to show Camilla how to create a custom report theme. So let's have a look at how you can do that within Power BI Desktop. So here I've got a report, and what I'm going to do to access the report themes, you need to go to the View tab. Then you can see these themes here, and obviously these are the preset themes, so you can just click and update the current theme very simply like that. But to do most of the customization, you need to click on this button here, and you can access the current theme and all accessible themes that are currently installed on this machine. And then there's a few settings down here that are quite important to know. So browse for themes. If you click on that, it's going to allow you to import a Power BI report theme. So if you've already got a theme here, for example, this one here, then you can select that and install it into your environment like so. If you want to customize the current theme, you can do that like this, and it's going to bring you through to this UI environment just to, change some colors, change some text, change some visuals. What you have to think about for this section of the exam is what could they ask you? You have to think about how could you possibly be tested on this. So in terms of the Power BI report theme stuff, you're likely to be tested on these buttons here and what they do. Plus they could ask you about a JSON theme. So they could show you a JSON theme and maybe ask you about, okay, how can you edit this theme? What doesn't look right in this theme? That kind of thing. So it's good to have a bit of familiarity about the different sections in these JSON files. So the name of it, how you can store your data colors as a list, some of these different settings here. You're probably not expected to memorize all of the different settings in JSON format, but you might get shown a theme in JSON format and asked to modify it or asked to comment on it in some way. To export the current theme, you can also use this save current theme, and that's going to allow you to export a JSON file that you can share within your organization. And you've also got here access to the theme gallery. So this is going to bring you through to the theme gallery website where you can download other people's themes for your report. To finish up this video and this lesson, we're going to go through 5 practice questions just to kind of solidify that knowledge, make sure you're understanding some of the key concepts within a context of a scenario. So the first question is, you're running an F2 capacity and you regularly experience throttling with that capacity. Now there's a number of long-running Spark jobs that take on average 3 hours to complete, and you need these to complete in under 1 hour. So you plan to increase the SKU of the capacity. Where would you go to make this change? Would you go to the workspace settings and configure Spark settings? Would you go to the admin portal and the capacity settings section and then click through to Azure to update your capacity? Would you go to the monitoring hub and look at the run history? Or would you use the capacity metrics app? So pause the video here and have a bit of a think, and then I'll move on. So the answer is to B. So you can manage your capacity settings within admin portal and then capacity settings. And then you can actually click through to Azure. It gives you a link to the Azure portal. And that's where you're going to change the capacity within the Azure portal. Obviously, you can't be within the Spark settings. That's for managing the configuration of your Spark cluster within a workspace. And in the monitoring hub, we can't get anything there to do with capacity settings. That's just going to tell you how your jobs are running. And in the capacity metrics app, that's just a read-only app for having a look at how your capacity is being used. So that wouldn't also be suitable either. Question number 2, your data governance team would like to certify a semantic model to make it discoverable in your organization. Now, only the data governance team should be able to do this. In what order should you complete the following tasks to certify a semantic model? So have a look at the 5 actions here, and what you're going to have to do is put these in an order. So this is an ordered list, it should be. So one of the things you'll have to do first, second, third, fourth, and fifth. So once you've got these in order, we'll move on. So let's look at the answer now. So the correct order looks a bit like this. So we start by creating a security group for the data governance team. The clue in the question was that only the data governance team should be able to do this. So when you see that, you think, okay, well, they need to be within a security group to enable this. Number 2, and you could argue that 1 and 2 could be interchangeable, but these are the first 2 items anyway. But enable the make certified content discoverable. So within the admin portal, the tenant settings, there's a section for discovery. You're going to need to enable that for the organization. And then after that, you're going to have to make sure that that settings is applied only to the data governance security group that you set up. Then you're going to need to ask the data governance team to go into the semantic model settings and then endorsement and discovery and click certify for that semantic model. And then you want to validate that that has been set up correctly and your business user can see that certified semantic model within the OneLake Data Hub. 3, you join a new company and you're given a Power BI report theme as a JSON file to use for all new projects. How do you apply this JSON file theme to the report that you're currently developing? Is it A, in Power BI Desktop, go to View, Themes, and customize current theme? B, go to the Fabric admin portal, click on Custom Branding, and then set the default report theme. C, use Tabular Editor 2 to update the theme. Or D, in Power BI Desktop, go to the View, Themes, and then browse for themes. So the answer here is D. In Power BI Desktop, go to the View, Themes, and then browse for themes. So D and A are quite similar, but A is for customizing a current theme. So that's not going to be allowing you to import a JSON file. That's going to allow you to use the user interface to update the current theme. So that's not what we want to do. We want to import a JSON file as our report theme, which is possible using D. B, that functionality doesn't actually exist. Custom branding does exist, but that allows you just to update the colors and the icons within Fabric, not a default report theme. And Tabular Editor 2 is also the incorrect answer. Question 4, you have 1000 JSON files stored in Azure Data Lake Storage, ADLS Gen 2, that you want to bring into Fabric. The ADLS Gen 2 storage account is secured using a virtual network. Which of these actions would you need to perform first? Is it A, in Fabric, go to Manage Connections and Gateways, and then click on Create a new virtual network data gateway? B, create a shortcut to the ADLS Gen 2 storage account? C, in Azure, register a new resource provider and create a private endpoint and subnet? Or D, install an on-premise data gateway on an Azure virtual machine in the same virtual network? Or E, enable public access in the storage account network settings? So for this one, you'll remember that the answer is C. So the first step in setting up a virtual network data gateway is, well, we need to go into Azure. We need to perform some network configuration. Okay, so you need to register that new resource provider, that Microsoft Power Platform resource provider within your subscription. And then on the item, create a private endpoint and a subnet. All of the other options, some of them are steps in the process, but not the first step. So the question was, which of these actions would you need to perform first? So yes, we do need to do A, but it's not going to be the first thing that you're going to do. B is kind of a bit of a red herring here, because you might have seen ADLS Gen 2 and thought, shortcut, but actually you need to configure the virtual network data gateway before you can even think about kind of connecting to it. D, installing the on-premise data gateway. Well, you know that we're looking at a virtual network here, so you're going to be choosing the virtual network data gateway rather than an on-premise data gateway. And E, enable public access in the storage account network settings. Well, that's going to expose your data to the public internet, so not advisable. Question 5, you have data stored in tables in Snowflake. Which of the following cannot be used to bring the data into Fabric? A, use the data pipeline copy data activity. B, create a shortcut to the Snowflake tables from your lakehouse. C, use the Dataflow Gen 2 with the Snowflake connector. D, use database mirroring to create a mirrored Snowflake database in Fabric. So the answer here is B, to create a shortcut to the Snowflake tables from your lakehouse. As you'll know, you can only shortcut to ADLS Gen 2 or Amazon S3 or Google Cloud Storage. So the ability to shortcut is generally on files. When we're talking about tables in databases, well, there's all of the other 3 we can use. So you can do a copy data activity from a data pipeline to bring that data in, if you want to copy it in, or you can use a Dataflow Gen 2, or you can use database mirroring, because Snowflake is one of the databases where database mirroring is possible. Camilla says, thanks. She's seriously impressed with your knowledge. Well done. In this lesson, we've looked at how you can identify requirements for a Fabric solution. We've looked at the different types of data gateways that are available to us in Fabric. We've looked at the settings in the admin portal, and we've also looked at how to create custom Power BI report themes. And the good news is you've won an extension to the contract. Camilla would like you to implement and manage her data analytics environment. So you've got the next stage of the contract. In the next lesson, we'll look at how you can do that. How you can set up access control, sensitivity labeling, workspaces, capacities, all that kind of stuff. How do we set these things up inside Fabric? So make sure you click here for the next lesson. Hey everyone, welcome back to the channel. Today we're going to be continuing our DP-600 series, and we're going to be looking at implementing and managing a data analytics environment. This is the second part of the DP-600 syllabus, or the study guide that we're going through on the channel. And today we're going to be going through these particular elements, and these are coming straight from the study guide. So number one, we're going to be looking at implementing workspace and item level access control, implementing data sharing for workspaces, warehouses, and lakehouses, managing sensitivity labels, configuring Fabric enabled workspace settings, and managing Fabric capacity. We've got 5 sample questions. So at the end of the video, we'll be going through some sample questions to test your knowledge. And as with the last video, I'll be posting the key points and links to further resources in the school community available for free. I'll leave a link in the description for that. We'll continue the scenario that we were developing in the last lesson. You're the main character again. Are you ready? Let's begin. So just to recap, you are a consultant and you're working with your client, who is called Camilla. And in the last engagement, you successfully planned their data analytics environment. Now you've won the contract to support Camilla in implementing that solution. So Camilla is busy doing her resource planning. She's thinking about who she's going to need to support this environment in Fabric. She's asking for your assistance to help her structure her thoughts and also her team. So let's have a look at what that looks like in Fabric. So this is a high-level structure of a Fabric implementation. Now you'll notice that it's hierarchical. At the top, we have tenant level. So this is kind of the one tenant that you're going to have in your organization. Then below that, you might have one or many capacities. And we talked about capacities in the previous lesson. We're going to be doing a bit more on capacities in this lesson as well. And then in each capacity, you might have one or multiple workspaces. Then in each workspace, we go down to the item level. So you might have a data warehouse and a lakehouse in your workspace. Then we can actually go one level deeper than that, which is called the object level. So within the data warehouse, you have dbo.customer. That might be a table in your data warehouse or a view in your data warehouse. That's at the object level. Now, when we're administering Fabric, we need to be aware of these different levels, because at each of these different levels, administration happens in a different way. In the last lesson, we looked at the tenant level admin settings. So that's mostly things in the admin portal under the tenant settings section. Today, we will explore item level a little bit later on. But first, I just want to look at how we can administer each of these 3 top levels. So here we have a table. Now the table isn't complete yet. We're going to walk through it together. So we have the 3 top levels. We've got tenant level, the capacity level, and the workspace level. And then on the right-hand side, we're going to go through what the administrator, or who the administrator is, what role they require, and also where the admin happens, right? So where are they going to be working? Where are the settings that they need to administer at each level? So starting at the top level, we've got the tenant admin. Now, to get the rights to be able to be a tenant admin, we're actually going to go higher than Fabric. We need an Entra ID role of global administrator, Power Platform administrator, or Fabric administrator. And we looked at what that looks like in the last lesson. And they're going to be working predominantly in the Fabric admin portal. So if you have any of these 3 roles, that's going to be available to you, and you can configure your tenant settings in there. One level down at the capacity level, well, the capacity admin is assigned when you create a new Fabric capacity in Azure. Now, where the administration happens, so any sort of administration at that capacity level is going to be done either in the Azure portal, as we mentioned before, or in the Fabric admin portal. There's a section on capacity settings. We're going to have a look at both in a minute. At the workspace level, so we're going one level down now, you're going to have a workspace admin. They're going to be the person that is kind of in charge of that admin level. And the role required here is a workspace role. So it's going to be a person or a group with the workspace role of admin. And again, we'll have a look at what that means in more detail a bit later on. Now they're going to be doing most of their administration within the workspace settings and also within the manage access. So these are the two areas that they're going to be focusing most of their time on. Now we looked at the tenant level admin settings previously in the last video. In this lesson, we're going to focus on the capacity level settings and then the workspace level settings. So let's just focus in on the capacity administrator settings for a moment. And as I mentioned, there's two really places where capacity administration gets done. Number one is in Azure, because we need to use Azure Portal to purchase capacity, right? So that's going to be where you go to create a new capacity, delete existing capacities, changing the size of a capacity. So if you've got an F2 SKU, and you want to go up to an F4, that's going to be done in the admin portal. And also changing the capacity administrator. So you can do that within the Azure portal as well. As well as that, within Fabric, we can change some of the settings for a particular capacity. So we can do things like enabling disaster recovery, viewing the capacity usage report. So how much is our capacity being used? We can define who can create workspaces within that capacity. We can define who is a capacity administrator. We can update the Power BI connection settings. So who can connect to this capacity or items within this capacity from Power BI, and how does that look like? We can permit workspace admins to size their own custom Spark pools. So this is quite important, right? Because you might want to set some sort of limits on the sizing of the Spark pools that workspace owners underneath the capacity or in this capacity, you might want to limit how high they can go with their Spark pools, because that's going to have quite a big impact on the overall capacity usage. So if you're sitting at the capacity level, you might want to add some restrictions on, the custom Spark configurations that happen in your capacity. And we can assign workspaces to the capacity in this section as well. Okay, so here we are in the portal, and I just wanted to show you some of the capacity settings, how to administer a Fabric capacity. I'm going to start right from the beginning. So how do you actually set up and buy a capacity? Well, you go to Microsoft Fabric. If it's not already there, then you can just search for it here, Microsoft Fabric. This is going to bring you through to the resource creation tool. We're going to click on create. And we're going to walk through these steps to create a Fabric capacity. So you need a subscription and a resource group, and you can enter the capacity name. So give it a region, change the size. I'm just going to do an F2, select, and here is where you sign the capacity administrator. And again, we can change that afterwards, but you need at least one to set it up. So it's going to give you the estimated cost per month here, and then you press create, and it's going to deploy that capacity. Okay, so now my capacity has been created. We can click on go to resource. And this is where we're going to do some of the administration tasks within the Azure portal, right? So here we can have a look at, well, firstly, we can pause it. So if you want to pause the capacity, you can do that here, delete it as well. Down the left-hand side, we've got some useful things here. So capacity administrators, that's where you're going to change your capacity administrator. We've also got change size. So if you're finding that F2 is not enough for your workloads that you're running, you can change it to F4 or F256 if you've got a spare 40 grand a month to be using on Fabric. I'm going to keep it as an F2. That's just something to bear in mind there. Okay, now I just want to have a look at what that capacity setting looks like inside Fabric. So if we go to the admin portal and capacity settings, if we go over to the Fabric capacity tab here, we can see that Fabric capacity that we've just set up. So it's an F2, it's in UK South, and it's active. So we've got some actions here. We can change the name. We can have a look at the admin. You can't really do much there. There's a link through back into Azure. So if you want to make any changes to it from within Fabric, you need to click on this link here. But if you click on the actual capacity name, we go through to the capacity settings, right? So this is where you're going to be doing things like enabling disaster recovery, having a look at the usage report for that capacity, turning on notifications. So it's going to give you a notification when you've used X amount of percent of your capacity. Updating who is the administrator for that capacity can also be done here. Changing how we can access Power BI and how Power BI can access data in the capacity. We've also got data engineering settings. It's mainly Spark settings. And this is where we're going to have that permission to permit people to change the custom Spark pooling, right? So either on or off. And we can assign certain workspaces to this capacity. So if you just create a new capacity, it's going to be empty, and you can move existing workspaces onto that capacity. So as a workspace administrator, we've got a few different options. So here we're stepping down a level into the workspace level. And a workspace administrator, as we mentioned, deals primarily in the workspace settings. And here you can edit the license for the workspace. So change it from, like, for example, a trial capacity to a fabric capacity, or from Pro to PPU, premium per user. We can also configure connections to Azure as well as configuring Azure DevOps connections. So if you want to use Git version control for this workspace, that's going to be done in the workspace settings. Another thing we can do in the workspace settings is set up what's called a workspace identity. Now, this is basically having a managed service principal dedicated for your workspace. And it basically means you can connect to things like ADLS Gen 2 for things like shortcuts, and you can do that in a kind of trusted workspace access manner, basically. This is another pretty new security feature that they've added quite recently, and I'll be going through more of the security principles in more detail, probably in a separate video at the end of this series, because they're quite important. We can also edit some of the Power BI settings in the workspace settings, and also the Spark settings. So particular default environments that we might want to set up within this workspace, things like that. Just note here that managing access is done through the managing access section. So it's slightly separate, it's in the same kind of area, but it's not necessarily in workspace settings where we add users and add groups into our workspace. We'll have a look at that in a bit more detail. Okay, next I just wanted to walk through some of the workspace settings in a bit more detail. So here we are in a workspace, it's called Share Hub. What we're going to be doing is clicking on this dot, and you can see that we've got two here that are useful for workspace administrators. Number one is managing access. So this is how we're going to give people access to our workspace, either a person or a group. We can add people in here, and we can give them admin, member, contributor, or viewer. If we click on these dots again and then go through to the workspace settings, this is where we're going to be able to edit some of the settings for our workspace. General is where you just do the image and the description, and also domains if you're using domains. License info. So this is where you're going to change the potential capacity and the license that's being used in that workspace. So this one is a trial workspace. So maybe we want to actually change that to an F2. Maybe we've got some fabric capacity. We can select which one we want to use. I'm going to be using this fabric F2 learn capacity, and that's going to change the license for that workspace. We've also got connecting to Azure, connecting to Git, downloading things like the File Explorer as well, and enabling caching for shortcuts is another workspace setting we've got here. Managed identities. So if you're on an F64 capacity or higher, you can make use of workspace identities. And that's going to basically allow you to create kind of like a managed service principal just for this workspace. So give your workspace an identity and allow it to connect to ADLS Gen 2, create your shortcuts, things like that, in a secure manner. Kind of trusted workspace access is what it's called. And if you want to learn more about that, I'll leave a link to the workspace identity section in the school community. We can also do things like adding private endpoints and that kind of thing for connecting via Spark to things in Azure. You've got your Spark settings down here for configuring something about the pool that you're using, the Spark pool that is being used in this workspace. You can change the default environment. That's where you're going to be going to add libraries and things like that. So if you want to pre-install Python packages onto your Spark cluster so that every time you run a notebook or start a new notebook, you have those libraries there ready to go, that's where you do this. Change some settings for high concurrency and that kind of thing there. So Camilla says, okay, great. I now have some clarity on administering Fabric at the tenant capacity in the workspace level. What I'm not sure about is giving access to the people on my team. So that's important, right? We build all these things in Fabric, but how can we give people access, the right amount of access to these items? Let's have a look at that in a bit more detail. So if we go back to our structure of a Fabric implementation, generally when we're sharing items with people, that's really done at these bottom three levels of our Fabric architecture, right? So sharing things in Fabric is normally done at these three levels. Now, object level sharing is possible for the data warehouse and the SQL endpoint in the Lakehouse, but I don't think it's assessed as part of this exam. So it's not part of the study guide in any way. So we're not going to be covering that in this lesson. There's some documentation on the Microsoft Learn website, and I'll leave a link to that if you're interested in object level sharing, if you want to learn a bit more about that. We're going to be focusing on the workspace level sharing and item level sharing. So let's just start with workspace level sharing. People or groups can be given workspace level access. And when sharing, the personal group is assigned a workspace role. As you can see on the right hand side there, we've got admin, member, contributor, and viewer. Now this role applies to all items in the workspace. For example, a viewer in the workspace will be able to view all of the items in the workspace. Let's just take a bit of a moment because roles are really important, and the role that you assign someone dictates basically what they can do in your workspace. This image here comes from the Microsoft documentation. Again, I'll leave a link to this in the school community, and I definitely recommend you take some time to study it. This is what we're going to be doing here. So the first thing to note with this diagram is, let's just start with the admin. So if you give someone an admin permission, what can they do? The first thing is that they can update and delete the workspace. So this is really high level permissions that only maybe 1 or 2 people really should have, people that you trust in your organization. They can also add and remove people, including other admins. So it's the only role that allows you to add an admin, add another admin. Next, we move down to the member, and the member can do similar things to an admin, but they can't add an admin, okay? So a member cannot add an admin. They can only add people with lower permissions or other members, okay? The other permission that is unique at the member level is you can give other people the permission to share items. So being able to share items is a fairly high level thing to do, and you're giving people that permission to share, okay? So that's something to bear in mind as well. Then we move down to the contributor level. Now, contributors can do pretty much everything in the workspace other than, as we see here, deleting the workspace, adding other people into the workspace, and allowing other people to share. But they can do, when you're talking about contributing to Fabric items, anything around lakehouses or warehouses or data pipelines, they have read and write access to all of these things. So the viewer has a unique set of permissions, those 6 green ticks. And if we go kind of from top to bottom, they can view and read content in a data pipeline, a notebook, Spark job definition, machine learning model. So they can view kind of the outputs of these things. They can also view and read the content of KQL, databases, query sets, and real-time dashboards. They can connect to the SQL analytics endpoint of a lakehouse or a data warehouse. And they can read lakehouse and data warehouse data and shortcuts with T-SQL. So the viewer can basically use SQL to analyze data in either the lakehouse or the data warehouse. What they can't do is access any of the OneLake APIs or Spark. So they can't run Spark jobs or notebooks or anything like that. Now, one unique thing about the viewer permission is in the data pipelines. Now, they can't edit or update any of the activities in a data pipeline, but they can execute and cancel the execution of a data pipeline run. So that's an important kind of edge case to remember for the exam. And they can also finally view the output of data pipelines, notebooks, and machine learning models. So that's kind of a high level overview of all of these workspace roles and what they can do at each level. Again, this is really important to understand for the exam. So I definitely recommend going into the documentation, taking some time to understand these different things, because you'll probably be tested quite a lot on these. So let's just have a bit of a workspace level access example. This is John. He is a business analyst working in Camilla's team, and Camilla has asked you to give him contributor access to Workspace 1. This is Workspace 1. This is the architecture that they've got here. Now, this is what John's access currently looks like, where the red box is basically no access at all, and a green box if there's any access. And you can see everything's red, so currently he has no access to anything. You are an admin in the workspace. Now, what steps would you take to give John this access? Have a little think about that, and then we'll talk about it in a second. Okay, so what steps would you take? Well, personally, what I would be asking is, does John fit into an existing security group that has contributor access to the workspace? Because best practice here is to add people into groups rather than adding them individually. It just makes maintenance in the future a lot easier. Where possible, we always want to add people into groups before we add them individually. Now, if a security group doesn't exist, then you might want to create one for John. Maybe you want to create an analyst security group so that in the future, when another analyst wants to join the team or join the workspace, you can just add that person into the group rather than having this long list of individual contributors in that workspace. So you create an analyst security group, add John to the security group, and give the group contributor access to workspace 1. So in the picture, how does that update? Well, it looks a bit like this, right? So John now has access to workspace 1 and everything within it because we've given him access, or the security group access, at that workspace level. You'll notice that workspace 2, he still has no access to that. He can't even see that. So that's something to bear in mind when you're giving workspace level access. Camilla suddenly rings you. She realizes that John shouldn't have access to everything in the workspace. Instead, she wants you to give him access to the data warehouse only, not the semantic model, not the data pipeline. So how would you change what we've just done to reflect this? So this is what we're looking at here. We want to go from this, which is the arrangement that we've just done for John at the workspace level, to this at the item level. Now this might be important because it kind of reflects quite an important principle when it comes to giving people access, which is the principle of least privilege. Now, in general, in data systems, information security, we want to give people the amount of access that they need to perform their roles and nothing more, right? So if you don't technically need access to the semantic model or the data pipeline, then one way of kind of getting around that is to give people item level access, giving people access to only what they need. Okay, just to recap on some of the additional permissions. So when you share a data warehouse, you get these 3 additional permissions. We have read all data using SQL. And what that means is it allows people to read all objects within the warehouse using T-SQL. We also have the read all OneLake data. And with this, you're allowing that person to read the underlying OneLake files using Spark, pipelines, anything else basically. So in the top one, they can only use SQL. If you give them the second permission, it allows them to basically do anything with that data. And the third permission allows the user to build reports on the default semantic model. Not any custom models, just the default semantic model. When it comes to the lakehouse, these permissions are similar, but they're just worded a little bit differently. So again, if you give them the read all SQL endpoint data, it allows them to perform T-SQL on the T-SQL endpoint. If you give them read all Apache Spark, then again, it's going to allow them to run notebooks and Spark code on top of that data. And again, the build reports on the default semantic model does exactly what it says on the tin. Now, one point that I just did want to make here is around OneLake data access model. Now, this is a very newly announced feature, so it might not have made its way into the exam yet. But I do think it's going to have a very big impact on how we manage security in Fabric going forward. So I did want to at least mention it here. I'm not going to be going through it in detail, but I did just want to flag it. You might want to have a look at the documentation page just so that you can become aware of it. Now, this feature is not really something I've looked at yet much in detail, but from looking at the documentation, from how I understand it, is it's going to allow you to perform RBAC, so role-based access control, on things like folders. So now that they've implemented folders within a workspace, it's going to allow you to define a specific role or give a specific role access control over that folder. And then the permissions are going to be inherited for every item in that folder. But like I mentioned, it's a preview feature and it's relatively new. So I'd be surprised if they ask you about this in the exam, but it is very important. And I do think it will change quite a lot in Fabric. So I wanted to mention it. And if you look at the study guide, it does say for the DP-600 exam, it does say that most questions cover features that are generally available. The exam may contain questions on preview features if those features are commonly used. Well, I think at the moment this isn't commonly used because it's only been released a few weeks ago, so that's something to bear in mind. Camilla says, thank you. Now I understand workspace level and item level sharing in more detail. One last thing before you go, we've been working on this government project and I need to apply sensitivity labeling in a workspace. Can you walk me through it? So what even is a sensitivity label? Well, sensitivity labels are a data governance feature and they're created and managed in Microsoft Purview. So Fabric items, such as a semantic model, can be given a sensitivity label, such as confidential, right? And it's for information protection purposes. Now, in some industries, labeling data and information with a sensitivity label is necessary for compliance with information protection regulations. Now, to apply a sensitivity label in Fabric, really there's 2 main methods. If we go into that item, for example, this lake house here, what you have in the top toolbar, you've got the sensitivity label, and you can just click on that drop down, change the sensitivity label in there. The other option is to go into the settings of that particular fabric item, and you can see that in the left hand toolbar there, you've got sensitivity label, and you can change the sensitivity label in there. Now, one of the options that you can give it if you go through this settings method is to apply to downstream items. So again, we've got that notion or that concept of inheritance of the label that you give it here also applies to everything downstream. Okay, so now we are going to test some of your knowledge for everything that we've learned in this section of the study guide. And we're going to start with a case study style question. So we're going to be going through a bit of a case study and then going to be asked 3, maybe 4 questions on this particular case study. Let's begin. Toby creates a new workspace with some fabric items to be used by data analysts. Toby creates a new security group called data analysts. He includes himself as a member of this security group. Toby gives the data analyst security group a viewer role in the workspace. What workspace role does Toby have? Is it A, viewer, B, member, C, admin, or D, contributor? Pause the video here, have a think, and then we'll move forward to the answer. So the answer here is C. Now this combines 2 pretty important concepts to understand when we're looking at workspace level sharing. Number 1 is that the creator of a workspace is always given admin permissions in that workspace. Now we also have Toby with the viewer role in that workspace because he's in the security group with viewer role. And this is another concept. If you have more than one level of permission within the workspace, you're always given the higher level. So he's got admin role because he created the workspace, and he's got viewer role because he's in that security group. Well, the admin permissions is always going to be prioritized. He's always going to take that role over his viewer role. So let's continue this case study. Sarah is also a member of that data analyst security group. She has no other role in the workspace. Which of the following can Sarah not do in the workspace? A, execute a data pipeline, run SQL scripts in the data warehouse, run Spark notebook, or review the evaluation metrics of a machine learning model. Now the answer here is C, run the Spark notebook. Now when we're looking at the workspace level roles and the permissions for each role, we know that Sarah is a viewer in the workspace. That's the highest level of permission. And you'll remember that a viewer role can actually execute a data pipeline in a workspace. They can also run T-SQL scripts in data warehouse or a SQL endpoint of a lakehouse. What they can't do is run a Spark notebook. Okay, so anything in a notebook, they can have a look at the notebook, but they can't actually execute any code. So C is the right answer because what we're looking for is what can she not do in the workspace. And D is review the evaluation metrics of a machine learning model, which we know we can do because she's just reading the output of that model. To continue this case study again, Toby wants to delegate some of the management responsibility in the workspace. He wants to give this person the ability to share content within the workspace, invite new contributors to the workspace, but not add new admins to the workspace. What role should Toby give this person? A, admin, B, member, C, contributor, or D, viewer? So the answer here is B. Now the key point in the question was, but not add new admins to the workspace. So we know that to be able to add another admin into a workspace, you need to have admin permissions yourself. So Toby doesn't want to give that person this ability, basically. So we know it can't be admin. It's not going to be viewer. It's not going to be contributor. We know that the member is kind of one down from admin, and that's going to allow you to do all of these 3 things. They can share content, they can invite other contributors, because a member can add new people, either members or contributors or viewers, but they can't add other admins. So it'd be B, member. The next question is completely separate. You have admin role in a workspace. Sheila is a data engineer in your team. She currently has no access to this workspace at all. Now Sheila needs to update a data transformation script in a PySpark notebook, and the script gets data from a lakehouse table, cleans it, and then writes it to a table in the same lakehouse. Now you want to adhere to the principle of least privilege. What actions should you take to enable this? Is it A, you're going to give Sheila the contributor role in the workspace? B, share the lakehouse item with read all Spark data permission? C, give Sheila the admin role in the workspace? Or D, share the lakehouse item with read all Spark data permissions and share the notebook with edit permissions? So the answer here is D. So one of the clues in this question was the line where it says you want to adhere to the principle of least privilege. So immediately when you see that, giving people workspace level access is not really good enough. So A and C is giving a role in the workspace. So it's going to enable her to contribute and change and edit everything in the workspace, but it doesn't adhere to the principle of least privilege. So we can immediately rule out A and C. So another really important point in the question here was Sheila needs to update a data transformation script in a notebook. So she needs to edit the code in a notebook. She's not just executing an existing notebook. She needs to actually make changes to a notebook. And so for B, you wouldn't have that permission. You've got read all data for the Spark, so you can actually execute a notebook, but you can't edit a notebook. So to be able to make these changes, really need access to the notebook and the lakehouse that notebook is interfacing with, that notebook is reading from. Because we can't just share the notebook, because then you won't have access to the underlying data, and we can't just share the lakehouse because you won't have access to the notebook that she needs to edit. So the answer is D. Share the lakehouse item, we're giving Spark permissions, and we're also giving edit permissions on the notebook. Next question. You have admin role in a workspace. You want to pre-install some useful Python packages to be used across all notebooks in the workspace. How do you achieve this? A, in the Fabric admin portal, go to Spark settings and install the libraries. B, go to workspace settings, Spark settings, and then library management. C, create an environment, install the packages in the environment, go to the workspace settings, Spark settings, and set it as the default environment. Or D, go to capacity settings and then default libraries. So the answer here is C, creating an environment and then going into your workspace settings and setting it as the default environment for Spark. Now, this is a bit of a naughty question because B is the old way. So it used to be you go to workspace settings, Spark settings, and there was a section for library management, but that's actually not possible anymore. The way to do it, as I mentioned, is to create an environment and then in your Spark settings, make it the default environment. A and D don't actually exist, these capabilities. So these kind of red herrings. So the answer is C. Camilla says thanks. She's seriously impressed with your knowledge. Again, in this lesson, we covered all 5 of these elements of the DP-600 study guide, from workspace and item level sharing, data sharing for data warehouses and lakehouses, sensitivity labeling, and then workspace and capacity level settings. And the good news is, again, you've won an extension to the contract. Camilla would like you to implement control over the entire analytics development lifecycle in her organization. So for this, we're talking version control, deployment pipelines, Power BI projects, all that good stuff. That's what we're going to be looking at in the next lesson. So click here to continue that lesson. Hey everyone, welcome back to the channel. Today we're continuing the DP-600 series, looking at what it's going to take to hopefully pass that exam and become a Fabric certified analytics engineer. Today is video 4. We're going to be looking at managing the analytics development lifecycle. And in this section of the exam, we're going to be focusing on implementing version control, creating and managing Power BI projects, planning and implementing deployment solutions, performing impact analysis on downstream activities, deploying and managing semantic models through the XMLA endpoint, and creating reusable assets. So Power BI template files, Power BI data source files, all of these kind of things. So that's what we've got in store for you today. As ever, there's going to be some sample questions at the end. I'll also be posting all of the lesson notes and links for further resources in the school community. Go and grab them there. You will play the main character in the scenario again. We're going to be continuing this theme, this scenario that we've been developing throughout this course. You're the main character. Are you ready? Let's begin. So as you know already, we are a consultant working with the client called Camilla, and you've already helped Camilla plan and implement her Fabric implementation, her environment. Now the time has come to implement analytics development lifecycle. Now she wants to focus on version control, at least initially, but to be honest, she's not really familiar with Git, version control, never really used that in an analytics environment before. So what you're going to have to do is set up a call with Camilla and walk her through the basics of Git first and version control. What is it? Why does it even exist? Why is it now a part of Fabric? And what are some of the key terms and terminology that we need to understand when we're implementing version control? Just bear in mind that all of the Git integration features are currently in preview. And also some of the other features we're going to be looking at today, like the deployment pipeline functionality. A lot in this kind of analytics lifecycle stuff is still in the preview stages, so just bear that in mind when we're walking through these examples. I'll show you what's possible today, but if you're coming from using like GitHub or Git a lot in the past, then a lot of the features that you might be used to are currently not available. So let's move on. Okay, so I just wanted to start this video with a bit of a primer on Git and version control in general. And I think the best way to do that is to show you what this looks like, and along the way, we can explain some of the key concepts in Git and version control. I realize that probably a lot of people who have been coming from maybe a Power BI background don't have experience with version control and Git in general. So let's set up a project and start at a basic level, introduce more and more concepts as we go through this demo. So in Fabric, the way you're going to start is with Azure DevOps. Now, Azure DevOps is a service that's used primarily for software development and managing infrastructure and the DevOps lifecycle of that infrastructure and software development. But it's also where we're going to use to store our code and our artifacts and our Power BI project files, because they come with repositories. So you need to set up an account. Just go to this website here, and I'll leave a link in the description or in the school community. Now, once you've set up Azure DevOps for your organization, you'll come through to this page here. I've set up an organization called Fabric University, and then you have this concept of a project. So a project is going to be where you store your repositories, your code. It has lots of other features as well, but we won't be going into too many of the other features in this short video. So we're going to be creating a new project for this demo. Let's just call it DP-600 practice. We're going to make it private and then just click on create. Okay, so this is an Azure DevOps project. On the left-hand side, you can see here, make that a little bit bigger. On the left-hand side, we've got some useful things to know about, right? So this is just the overview, where you can see an overview of the project. Probably the most important ones to bear in mind are boards. So this is like a work management tool for doing development work. We're not going to be focusing much on that in this video. What we're interested in is this repositories, right? So repositories is kind of the core thing that we need to implement version control. Now, repositories are also available in GitHub, but currently that integration is not possible between Fabric and GitHub. You can only use Azure DevOps repos. So that's why we're using this currently. So a repository is just where we're going to store our code in the cloud. So when you're developing locally, like a Power BI report, for example, really what we want to do is store that report in the cloud, in our repository. And that's where we're going to be controlling, tracking changes, managing who can make changes to that project in the repository. So let's just do a bit of configuration here to set up this repository so that we can use it for version control. So the first thing that I'm going to do is right at the bottom here, initialize a main branch with a README. And a README file is just a markdown file. It's like a text file, just to initialize our branch. And we'll talk a bit more about branches in a bit more detail here. Currently, I have one branch, and it's the main branch here. Now, branching is kind of like a whole field in itself. There's lots of different strategies for how we can manage different branches when we're developing our code or developing our Fabric artifacts. But we'll get into that in a bit more detail a bit later on. For now, what we're interested in really is creating a copy of this repository on our local machine, right? So that's going to be the first sync. We want to get these two in sync, because the way that version control works in general is you develop locally on your local machine for Power BI, and then you sync those changes up to the repository in the cloud. And if you have a big team of people, maybe you have 10 people doing this, they're all syncing their changes into this main branch by default. So what we want to do is clone this repository, and we get this URL here for this Git repository. We can copy the URL, and what we want to do is clone that on our local machine. So there's various different ways to do that. You might see it in the documentation. Microsoft use a tool called VS Code. I personally prefer using GitHub Desktop. This is another tool. It's completely free. You can download it. Just Google GitHub Desktop download. It's built by obviously GitHub, but it's also possible to do Azure DevOps repos in here as well. And it just makes the whole process of version control and Git a lot simpler. It basically builds a UI on top of a lot of the Git functionality. So the first thing we want to do is click on File and clone repository because we're trying to drag things down from the internet. And if you click over to URL, we can just copy the URL that we've got here that we got from our Azure DevOps repository, and we can clone it. Now it's going to ask for a username and password. So if you go back to Azure DevOps, we've got generate this Git credentials, and we can just copy the username in there, copy the password in there, save and retry. So that's just going to authenticate with our Azure DevOps account. So we know that, okay, this is the actual person that owns that repository. It's creating that authentication between the two. Okay, so what has that actually done? Well, now what we've got is a copy of what we have in Azure DevOps in our local machine. You can see the file path there. It's C users learn documents Git. And what we can actually do is open this in Explorer. Okay, so now I have a copy of those files and folders from Azure DevOps on my local machine. So that is the first thing that we need to do really, is clone the repository, get that copy local. And what's going to happen now, we've got this all set up and synced so that GitHub desktop is now tracking this folder. So any changes you make locally to this folder, it's going to pick those up. Right? So for example, if I do a new text file, call it my file. Now, if we go back to GitHub desktop, you can see that it's picked up that change already. It's saying you've added a new file in there and it's called myfile.txt. And if I open that with Notepad, for example, just call it my amazing file and I'll save that. Here we can see again, it's tracked the changes. So Git works by tracking the changes in text-based documents. Okay, so traditionally it's used for code, so a Python file, a SQL script, or a JavaScript file, or C#. All these kind of things are textual based, right? So they work really well with Git. So now we've made some changes to our local repository, right? We've added this text file. But what you'll notice is that, here in Azure DevOps, nothing has changed yet, because what we need to do is push those changes into the cloud environment. Maybe you've got a team, you want other people to see the changes that you've made. And we'll start by using this text file, right? And then we'll slowly move up to more complicated stuff. We'll look at Power BI projects as well. But for now, let's just push these changes. So you see down here, we can do created a new file. So create a new file. And then what we're going to do is click this commit to main button. So this is going to commit our changes onto that main branch. And up here, we click on push to origin. So we're going to commit and then push the changes up into the cloud, right? Into Azure DevOps. And so now what's going to happen if we refresh our Azure DevOps, we can see that file there. We can see myfile.txt, my amazing file. That's in there in this repository in Azure DevOps now. Okay. Then if we want to make more changes, maybe we want to change this a bit more, even more amazing file, and we save that. Again, it's going to show you, well, your original file was this. Okay, this is what we've got stored in Azure DevOps. This is what the main branch is currently saying. Now you've changed that file, right? And we've noticed that, okay? So it's tracking the changes between every change you make in that file. So that's a really important thing to bear in mind. So let's just update this text file. Obviously in practice, in proper environments, you add a more meaningful commit message because these are really important. And we'll push that again to the origin using this button here. So again, if we just go back to the Azure DevOps, you can see that that has now updated in here as well. Great. So that is the very, very basic implementation of Git and version control and syncing our local repository with our Azure DevOps repository in the cloud. So at this stage, I think it's worthwhile just noting what we've done here, right? So at the top, we've created an Azure DevOps account. We've added that README file. We've copied the Git URL and cloned it locally. And then we've modified that local folder, created a new file, modified the file, committed those changes back, pushed the origin, and observed the changes in Azure DevOps. Now this is great, it's a good first step, right? We can track changes now between files. But one of the core benefits of Git and version control in general is that instead of just allowing anyone to update that main branch, what we can do is we can protect that main branch so that we can control who has access to and who has the ability to overwrite those changes. So let's make a few changes to the configuration of our repository in Azure DevOps. What we're going to do is we're going to protect that main branch so that nobody can just overwrite that file anymore. We want to add in a review and approval phase. And this is going to help a lot with our quality and control over who and how that code base is being changed. So let's have a look at that in a bit more detail. Okay, so in our Azure DevOps project here, we can go to project settings, and then we can go down to repositories. And then what we're going to do is add in a policy for branch policies, protect important branches, namespaces. So we're going to add something in here, protect the default branch, create automatically included reviewers. So I'm going to add myself in here as a reviewer, just because there's only one person in this project. In reality, you might have a team of maybe senior developers or lead developers that are responsible for reviewing code and approving changes to the code base. So now we've set that up, let's have a look at doing something a bit more. So we've got our file here. So if I save this, I've just added another line in here, new changes. And if we go back to our GitHub here, we can see that, oh, it's picked up that new changes again. But now what I'm going to do is update this. So added some new changes and I'm going to commit that. And when I try to push this to the origin, it's going to say error. Okay, because now pushes to this branch are not permitted. You must use a pull request to update this branch. So that's going to introduce a few new concepts that we need to get around this, really. Number one is the concept of branches, and number two is the concept of pull requests. Let's have a look at both of those now. So now that we've implemented some protection over that main branch, we have to change how we develop, okay? So now we have to use branching. So currently all of my files, that text file and the README file, is on this main branch. So if I now want to update what's in that text file, I'm gonna have to create a new branch because nobody can update and edit that main branch directly. So what we can do in GitHub desktop, it's very easy. So what we're going to do is click on branch, new branch. Now we can change the name to change text file, create this branch. And now if we publish this branch, and we can add in some changes here. So now if we go back to Azure DevOps, let's just go back to our project here and back to repos. And if we go down to this change text file, you can see that it has actually found this new branch. This is a branch. And if we go over to the pull requests section, we'll explain what that means in a minute. But you can see that it's registered the fact that we have now published a new branch. So we've made some changes, added that new changes line in the text file, and it's popped up saying, oh, do you want to create a pull request here? And so the pull request is when we want to make a change or merge some changes into the main branch, okay? And you can only do this through a review because that's the policy that I've set up on that main branch. So what we can do is create a pull request. You can say, oh, I've added some new changes in here. You can add in a reviewer, which is going to be me. And you can say, oh, please review this. And you can create a pull request. So what that's going to do is going to notify the reviewer and say, oh, this person wants you to review their changes to the code base on this change text file branch. And now as the reviewer, because I'm kind of playing both roles here, I can have a look at the file changes. I can review the changes like, oh, yep, added new changes. That looks good to me. I'm going to approve that change. And now what you can do is complete. So what complete is going to do is merge those changes into the main branch. So your protected branch. Because we've gone through the reviewer process, the text file has been reviewed. Now we can merge it safely into the main branch. There's a few options here that are quite important to bear in mind, and we'll look at those when we move into Fabric. We'll look at those in a bit more detail. But generally, kind of the default settings here, complete associated work items after merging is fine. We don't want to delete change to text file after merging, generally, in Fabric, and we'll get to why that is in a minute. We'll just do on complete merge. Okay, so we've now merged our pull request. Let's have a look at the repository. So now we have my text file in the main branch, and it's got new changes, okay? So we've merged our changes into this main branch. Great, that's the first section of this demo done. Okay, in the second half there, what we did was protect the main branch, okay? So we've added an approver in the repository. We've updated the repo approver policy. We tried committing a new change and it was rejected. We've added a new feature branch. We brought the changes onto that branch. We've committed that branch. And we've added a pull request. Then our approver has approved it and we've merged it into the main branch. And just to reiterate, the benefits of that is that now we're tracking the changes between files, and we're also controlling who can make changes. So we're protecting that main branch and saying, okay, if you want to update this, it has to go through an approval process. Now, up until this point, we've just been using one text file. But actually, Git can track the changes between any text-based file format, text-based. That's the problem that existed with PBIX files. PBIX files, kind of a bit of a black box, right? If you can't open a file in Notepad and understand what's going on, then it's going to struggle with source control, version control in Git. Now that is one of the core reasons why Microsoft developed the Power BI project file format, because it represents a Power BI project in text-based files, right? So let's just have a look at an example of a PBIP first, and then we'll look at how we can integrate that into version control systems. Okay, so here we are in Power BI Desktop, and I've just got one of the sample reports here from Microsoft, the Competitive Marketing Analysis report. Now, what we're going to do is, this is just a PBIX file at the moment. What we're going to do is save this as a PBIP, a Power BI project file. Then we're going to explore that and have a look at what that looks like. So it's fairly easy to save your Power BI file as a Power BI project file. So if we go to File and then Save As, and what we can do is we can find our Git repository. So that's in Document Git DP-600 Practice. That's the repository that we just cloned from Azure DevOps, and it's currently empty for this kind of thing. We can change the Save As type to a Power BI project, and we can just save it like that. Click on Save, and now we have our Power BI project saved in PBIP format. So let's just have a look at what that looks like. Okay, so this is our Git repository, DP-600 Practice, and we've saved our Power BI project as a PBIP file. It's actually a number of different files and folders, right? What we've got here is, well, we've got the README that was already in the repository, and my file is that text file that we've been working with. But now what we've got is two folders, a git ignore file and this PBIP file format. So what it's done is it's basically decomposed our Power BI project into a series of files and folders that describe what's going on in that report. Okay, so let's move back to GitHub Desktop here, and what you'll notice is, well, the first thing is I've created a new branch. Okay, so now that we're going to be updating this PBIP file, we'll notice that all of the files are now listed here because we created that PBIP. They're all text-based, they're all trackable using version control. First commit of the PBIP, again, we can commit that up into Azure DevOps, push that to the origin in Azure DevOps now. If we go through into Azure DevOps again, pull requests, we can see that here. We can create a new pull request, and then we can commit that in there. The reviewer will be myself again. Create that, approve it, complete, merge. So now what we've got is our Power BI report in our Azure DevOps environment, and it's been approved, and it's now trackable through version control. Now, imagine I'm a Power BI developer and I want to make some changes to that report. What is that going to look like? Well, we're going to create a new branch. So anytime you're making changes to your Power BI file, you're going to create a new branch, Power BI changes. Obviously, you'd make it a bit more descriptive than that, but that's good enough for this purpose here. Then we're going to go through, and actually this isn't a marketing report, it's sales and marketing. So we're going to update the title here, just as an example. We're going to save that file. And now this is the real power of version control for our Power BI assets, but also all of the stuff in Fabric that we'll have a look in a minute. Any changes that we make to that Power BI file are now being tracked in our version control system. Okay. And then when we're done, we can push those changes up into Azure DevOps, go through the review process, merge them into the main branch. Okay, so you're probably thinking, great, but up until this point, you haven't even mentioned Fabric. I thought this was a channel talking about Fabric. Well, we just built up the concepts of Git, version control. We've looked at the local case of Power BI report development, but everything else in Fabric happens in the Fabric cloud. So now let's look at where Fabric fits into all this. Okay, how do we set up a repository in our workspace? How do we link a repository to our workspace? Let's have a look at how Fabric fits into this picture now. Okay, so here we are in Microsoft Fabric. What I've done is I've set up a workspace. What we're going to do is link it to our Azure DevOps repository, our Azure DevOps project. So to do this, you'll need to be a workspace administrator, go to workspace settings. So the first time that you click on Git integration, you'll need to actually sync it with your account. I've already done that with mine, and it's going to allow you to select the organization, the project, the repository, DP-600 practice, and a specific branch that you might want to connect to. Now, one thing I would say is that the way that we've done that protecting of the branching in the last section of the video, what I found in practice is that this doesn't work particularly well currently with the way that Git integration is set up in Fabric, but we'll have a look at what it looks like. Just click on connect and sync. Okay, so now our first sync has started and it's been done successfully. What you'll notice is this source control section here. It's got 0 in it. So our source control, so our things in Azure DevOps repository and what's in Fabric is perfectly in sync currently. And we can see that as well with the green synced and green synced here. So now that we've got what's in our Azure DevOps repo synced with what's in Fabric, now we can add in Fabric items into this mix, right? So we can create a new data pipeline, for example, create a data pipeline. At the moment, I'll just keep it as an empty one, and we can just go back to our repository and we can see that it has been uncommitted, right? And we can see that the source control button up here is now saying 1. So if we click on that, we can see that we've got 1 change here. So compared to what's in our main branch in Azure DevOps, it's noticed that we've got a change. So it's similar to how we saw in GitHub Desktop, which tracks local changes. This is tracking changes in Fabric as well. So what we can do is commit this change, this data pipeline, into our source control in Azure DevOps. Now to do this, because we've got a protection on that main branch, let's just try committing and see what it says first. Commit data pipeline, but we know that we've got protections on that main branch. So when we commit, I don't think it's going to allow us to do that. No, forbidden due to the branch policy. And this is where it gets a bit more complicated within Fabric. What we're going to have to do is check out a new branch. So maybe we want to do adding data pipeline. That can be our new branch. And then that's going to allow us to commit, added a new data pipeline. We're going to click on the item that we want to merge, which is our data pipeline, or commit, not merge. And now that's going to go through into Azure DevOps. Okay, so if we open up our pull requests section, boom, we can see adding data pipeline. So now we've got these two things in sync between Fabric and Azure DevOps and our local repository for Power BI development and Azure DevOps. And again, if we want to merge that into the code base, into the main branch, we can go through a familiar process of choosing a reviewer, creating that pull request, and if you're the approver, you can then approve that pull request and complete and merge it into the main branch. So then if we go back to our repository, now we can see that in our main branch, we have this My Data Pipeline data pipeline. So that is now being tracked with version control in our repository. And if we go back to Fabric, we can say that we've now got 3 synced items here. So it's perfectly in sync with what's in our branch. Now the problem here, or the slight limitation that I've found, is changing back to the main branch, because currently we're on this adding data pipeline branch, okay? And that was just a feature branch. We want to move back onto the main branch normally so that we can maybe create another branch. But we don't want to be branching from this added data pipeline. We want to be branching from the main branch. Now that is possible. We can just go back to workspace settings, go through to the Git integration again, and we can change our branch back to the main. So we're going to switch and override, and now we're going back to the main branch. And all 3 items are synced because we know that we've merged into that main branch. But the problem here is that only the workspace administrator can change that branch back. So if you found any better ways of working with protected branches in Git and Fabric, please let me know. Okay, so we've covered quite a lot of ground there, from the basics of Git and version control in general, right through to syncing our changes or tracking changes in a Power BI project into Azure DevOps, and then the same from a Fabric environment. So tracking changes that we make within Fabric also to the same Azure DevOps repository. Let's just do a bit of a summary there and focus back on the exam, because obviously not all of that is going to be tested. Some of it was just for your background knowledge. So in general, version control with Git allows you to track changes made to Fabric items. We can also revert back to older versions of an item as well. I didn't show you how to do that, but that is also possible within Git item management, Git version control. Now, one of the benefits of this is that multiple users can collaborate on the same Fabric item or the same Power BI report, okay? So no longer are you sending around a PBIX file to your colleague. Everyone can work on the same PBIP file and changes are tracked using version control. And you can also update the same report at the same time, as long as there's no conflicts when you merge into your branch. Two different changes from two different people can both be merged into the same kind of central branch. As long as there's no conflicts, as I mentioned, that's absolutely fine. So it's a good way that enables collaboration on Power BI reports. We've also looked at how you can implement a check and approval process for approving changes made to Fabric items. So if you don't want your junior developer to be updating your Fabric notebooks and just pushing those into your Git version controlled repository without you approving them, you want to set up protections on that on your main branch or your equivalent of a main branch before they get pushed into production. Now, currently, the following items are supported. I would argue that not all of these are probably fully supported, like as fully supported as we would like, but it is possible to at least check them into a version control system. So data pipelines, lakehouse, notebooks, paginated reports apart from ones that are connected to Azure Analysis Services, and also semantic models, except for these exceptions here. So that is Git integration and version control. Now the next section of the exam is related to this, but it's around deployment solutions. So let's just look at what do we mean by deployment solutions? Well, actually, let's start with deployment. What do we mean by deployment? Because for many people coming from the world of analytics, deployment is probably a bit of a new concept, okay? So rather than having one copy of a Power BI report, for example, which is your production copy, instead, we're going to have multiple copies, typically 3, sometimes 4. We're going to have a development version, and that's the version that you're using when you're making changes to the reports. We're going to have a test version of that report. So that is the report that you send to your client or your colleagues to review, or maybe you've got automated testing in place that's done at that stage. And the test version is sometimes also called the staging version in databases. And we've also got the production report, right? So that is the public-facing report that gets given to your client or it gets shared within your organization. Now, Microsoft have released a feature called deployment pipelines to help manage these 3 environments or more in a bit more detail. So let's have a look at deployment pipelines in Microsoft Fabric in a bit more detail. Okay, so now let's look at how we can set up deployment pipelines in Microsoft Fabric. So what you're going to need here is 3 workspaces, and each workspace is going to represent a different environment, a different stage in our deployment pipeline. So if we click through to workspaces, you'll see that I've set up DP-600 dev, test, and production. So these are 3 separate workspaces, and currently they're completely empty. So what we're going to do is set up a deployment pipeline so that we can manage that deployment process from development, test, through to production. Because what we want to be doing is doing a lot of our development work, obviously in the development workspace, and then when it's ready, we want to push those changes into our test workspace so that we can do testing, share it with colleagues who might want to test a report or a notebook, run test scripts, so integration tests, unit tests, data validation checks, something like that in this test environment. And then the production is going to be where we're going to be sharing, making our public, our production reports or notebooks or things like that. So what we're going to do to set up a deployment pipeline is click on the workspaces and then deployment pipelines. And we're going to set up a new pipeline. I'm going to give it a name, so we can call it DP-600 pipeline. And it's going to ask you to customize your stages. Now you can add multiple stages, you can add as many as you like here. For our example, we're just going to do 3, the development, test, and production, and click create. And now we're going to get through to this kind of wizard, this UI interface. It's going to allow us to specify which workspace we want to connect to which stage in our deployment pipeline process. So we want to find our DP-600 dev workspace, assign that here. Then for the test stage, DP-600 test, assign that here. Then for the production, do that as well. So now we've synced our 3 workspaces with our 3 stages in the deployment pipeline. And currently we can see that it's completely empty. right? So we haven't got any items in any of these three workspaces. So let's go through to our DP-600 dev workspace, and we can see that it's here. We've synced it with this deployment pipeline. So it knows it's part of a deployment pipeline here. So if we create a new notebook, so this is our new ETL notebook. Let's just call it ETL notebook. Could be doing whatever you want in there. Doesn't really matter for the purposes of this demo. And we're going to go back into our workspace, and now we can see we've got this ETL notebook. Say we're happy with that. We've done our development work and we're happy with it. Now we want to push that into our test environment. So we'll go into our deployment pipeline. And here, what you can see is that now we can see this deploy, right? So we can select any items that we've got in our dev environment and we can deploy them. We can add a note in there if you want, and we can deploy that into our test environment. So it's going to move one stage to the right into our test environment. And what it's going to do is copy exactly the file that you've got there, and it's going to copy it and paste it into our test environment. So now we can see that we've got one notebook in this test environment. Okay, so let's just have a look at that there. So workspace is DP-600 test. So now we have ETL notebook in our test environment. Now, one thing to bear in mind is that we have a history of our deployments. So we've seen that we've deployed to test at this time of date by this person, me, and we can see the number of items that have changed. So we've got one new item in that deployment. Now, another thing that we need to look at is this button here. So this is quite important. It's called deployment rules. So if we click on that, we can look at a deployment rule, and deployment rules basically allow you to change different parameters and settings at different stages in the pipeline. And they differ depending on the Fabric item that you're looking to assign these deployment rules. So for the notebook, our deployment rule that we can set is changing the default lakehouse. Okay, so we can add a rule in there whereby we can change the default lakehouse. So maybe you have a development lakehouse and a test lakehouse. And when we push to the test environment, actually we want that notebook to be reading from the test lakehouse. So that's what we're going to be doing here in this deployment rules section. So that's something important to note there. Now, if we want to actually deploy this all the way into production, we can click on deployment at this test stage. And now it's going to copy that notebook into our production environment. Now, if we click on the settings of this stage, the production stage, we can see that we've got this make stage public, okay? And what that means is that people can actually access the output of this stage. So if they're in that workspace, they're going to be able to see the output. They're going to be able to see the items that are in there. With the other stages, like this test environment, by default, that is not a public stage. So that's something to bear in mind around public stages and non-public stages. So that's the very basics of deployment pipelines. Now, currently the functionality, I would say, is quite limited as to what you can do in deployment pipelines in Fabric. I think this is a feature that they're going to be adding a lot more to. Currently, it's a very manual process, right? And normally when we're deploying stuff in the real world, in software development world, a lot of this is automated. Okay, so we've looked at the basics of deployment pipelines, what that looks like in Fabric. Let's just do a bit of a summary of what we've just learned there. Again, focusing back on the exam. So the overall goal is to add layers of control when we're developing and deploying new Fabric items, okay, or making changes to existing items in Fabric. Ultimately, we're trying to ensure that new things that you develop are not going to break your existing analytics solutions, right? So you're adding in that test layer, so we're not just pushing straight into production and risking ruining any sort of analytics in your environment. Now, normally this includes 3 stages: development, test, staging, test or staging, and production. Sometimes you had a 4th one in there called like pre-prod. It just depends on your strategy. Now, deployment using deployment pipelines involves copying items from workspace to another. And by default in Fabric, that's a manual process. And deployment rules can be implemented to change things like the default lakehouse for a notebook, or the data sets and data sources that your semantic model reads from, for example. Now, as well as the deployment pipelines functionality, there's a number of other ways to manage deployment in Fabric. Now, that could be done through branching in Azure DevOps. You can also use an Azure DevOps functionality called pipelines, right? So you create a YAML template. We're not going to go through what that looks like, but just for the exam, know that it is possible. And you can also do deployment of semantic models via the XMLA endpoint, we're going to be looking at that in a bit more detail a bit later on in this lesson. Okay, so as I mentioned, there are a few other ways that we can deploy things in Fabric. Now, a really good resource here to check out is Kevin Chant's blog, and I'll leave a link to that in the school community. Specifically, there's 2 blog posts here around CI/CD for the data warehouse. Now, the data warehouse is not natively supported yet in Fabric, but you can set up a SQL project and then use things like YAML pipelines and Azure DevOps. So if you want to understand other ways that we can deploy items in Fabric, I recommend checking out these blogs here. Now, if we're looking specifically at the semantic model and how we can deploy these, we also have the option of the XMLA endpoint. So broadly speaking, there's 2 ways to create and manage semantic models. Number 1 is to create and manage your semantic model within your workspace. So create it from a lakehouse or a data warehouse within your workspace. But method 2 is to create your semantic model in a third-party tool, for example, Tabular Editor. And then you can deploy that via what's called the XMLA endpoint into your workspace. Now, to grab that XMLA endpoint, you need to go to your workspace settings, and then you get this Power BI URL kind of thing, and you can connect that to Tabular Editor or SSMS or DAX Studio as well to deploy your models into Fabric using this XMLA endpoint. Okay, so the next section of the study guide that we're going to look at is these 3 different file types or 3 different items that we can create in Power BI and Microsoft Fabric that you need to know for the exam. Number 1 is the Power BI template file. Then we've got the Power BI data source file, and then shared semantic models. So we're going to look at each of these in a bit more detail, starting with the Power BI template file. Okay, so the Power BI template file is a reusable asset that can improve the efficiency and the consistency when you're creating Power BI reports. Now, you can easily save a PBIX file as a Power BI template file, and then you can use that to generate new reports in a given style or with a given layout already specified in that template file. If you've got parameters in that Power BI file, then when you create a new project or a new file from the template, you'll be asked to set your parameters in there if there's any parameters in that report. Let's just have a quick look at how you can create a Power BI template file from a PBIX file. Okay, so here we are back in Power BI desktop, and here we've got a Power BI project that we're working on, our sales and marketing analysis report. Say we want to create multiple versions of this report, all with the same format, the same structure, and the same layout here, so the same pages in this report. What we can do simply is go to File, Save As, and then at the bottom here, rather than saving as a PBIX or a PBIP, we're going to save it as a PBIT, a Power BI template file. So if we just select a folder to save it to, and then click on Save. We can give it a description, sales template, okay. And that's going to save your report, and the next time you go to create a new report, we can then import that template, and that can be your starting point for your new report. So the Power BI data source file, or PBIDS, is another file type that basically represents a data source file. So it's a reusable asset, and it can help us quickly transfer all of the data connections that you create in one Power BI file, transfer them over to another report. Okay, in this section of the exam, we're going to be looking at impact analysis and the lineage tool in Microsoft Fabric. So here we have a workspace, and it's got quite a lot of different items. And if we click on this button here in the top right hand corner, we can change from this list view to a lineage view. And this is what this looks like here. We can see all of our Fabric items within that workspace, and we can have a look at how data is flowing from source through to different lake houses here. We've got some notebooks here, the semantic model that's being created from that lake house. Now, for each of the main items in our lineage view, we've got this button here, which is the impact analysis button. So for this bronze lake house, we can click on the impact analysis, and we can look at what the downstream items of that lake house are. So if you're going to be making some changes to that lake house that might break some of the notebooks or the semantic model, for example, the impact analysis basically allows us to see what the downstream items are. Now, in our example, we've only got 3 downstream items, but you could have 10s or 20s or hundreds of different downstream items. So it's really important to know if you make a change upstream, what the impact is going to be. Another piece of functionality that you have here is to notify people. So you can notify people that are listening for notifications on any of those downstream items, and you can let them know before you make a change. So we're going to add a new column to this table in the lakehouse, for example. We're going to add some new tables, FYI, just to make them aware of the changes that you're going to make before you make them. So that's basically all the lineage tool and the impact analysis tool in Fabric look like at the moment. Again, I think they're adding a lot more functionality to these features in the future. But that's basically all you can do with this at the moment. Just bearing that in mind for the exam, because you might get asked questions around notification, about how do you find downstream items of a particular Fabric item. So just have a quick look at some of your workspaces, perform some impact analysis just by looking at the downstream items for the exam. Okay, so we've covered a lot of ground there in that video. Let's just round the video up with some practice questions to test your knowledge of this section of the exam. Question 1. You are looking to improve the efficiency and consistency of your Power BI development team. You want each report created by the team to always consist of 3 pages, the intro, the context, and the analysis. The reports should always align to the company branding. Which of the following would help you achieve this? Number 1, would you create a PBIP file? 2, create a PBIX file. 3, create a PBIT file. 4, create a PBIDS file. Or number 5, using a JSON custom report theme. Pause the video here, have a think, and I'll reveal the answer shortly. So the answer here is the PBIT file, because that is the Power BI template file. Now, the important part of this question was you want each report created by the team to consist of the following pages, right? So you might have thought, oh, we're talking about branding, we're talking about following a style guide. E might be an answer there using the JSON report theme that we looked at in the first video in this series. But if we want to include pages, kind of template pages, then that's going to be the Power BI template file. PBIP, the project file, the PBIX, that's not going to do the job. And the PBIDS is just for data sources, not for giving us a template structure to follow for our report. Which of the following most accurately describes Git? A, to use Git, you must be using GitHub. B, Git is a Microsoft product for tracking changes made to Fabric items. C, Git is an open source version control system that tracks changes in any set of text-based files. D, Git allows us to add deployment rules to Fabric deployment pipelines. So the answer here is C. Git is an open source version control system that tracks changes in any set of text-based files, right? So Git, the underlying technology, is open source and it's used in a wide variety of version control systems, one of which is Azure DevOps, the repo's in there. GitHub is another example. Bitbucket is another example. There's lots of these different ones. So you don't have to be using GitHub to be using Git. Git is not a Microsoft product for using specifically in Fabric. It's kind of like a generic tool that's used right across software development industry. And it's nothing to do really with deployment rules in Fabric deployment pipelines. Although you can set up Git to be the version control system in different stages, different workspaces in your deployment pipelines, but it's not really best describing Git. Question 3. In an Azure DevOps repo, the main branch is protected, so it needs approval before any changes are merged into it. The repo contains one PBIP file. You have to update the title in the report, merging these changes to the main branch. In which order should you carry out the following tasks to achieve this? Now, this is an unordered list. Your job is to order this list. So the tasks here are commit and push the feature branch, wait for approval, then merge into the main branch, clone the repository to your local machine, make the required changes to the report, check out a new feature branch from the main branch, and then open a pull request in Azure Repos or Azure DevOps. So order this list, and then we'll show you the correct order shortly. So the correct ordering here starts with cloning the repository to your local machine. So if you want to make any changes to a report, you need that repository to be in your local environment first. Then you're going to check out a branch because the main branch is protected. So we can't edit that directly. We need to check out a new branch from the main branch. Then we're going to make the changes to the report. These are going to be tracked via our version control system. We're going to commit and push those changes that we made on that feature branch. We're going to open a pull request in Azure Repos or Azure DevOps, and we're going to wait for approval and then merge it into the main branch. So that is the correct order here. Question 4. You want to deploy a semantic model using the XMLA endpoint. Where can you find the XMLA endpoint to set up a connection with a third-party tool? Is it A, go to the workspace settings for the workspace you want to deploy your model to? B, go to the Fabric admin portal and then capacity settings? C, in your workspace, find your semantic model, then click on the settings to get the XMLA endpoint address. In the Azure portal, in your Fabric capacity, go to the XMLA endpoint connection string settings. So the answer here is A, go to the workspace settings for your workspace you want to deploy your model to. When we're creating that XMLA endpoint connection, that's going to link to our workspace in Fabric. That's where you're going to go to get the address, not in capacity settings, not in the Azure portal. And C, in your workspace, find your semantic model. Well, the semantic model doesn't actually exist in that workspace because we want to deploy it into there. And even if it did exist, it doesn't have the XMLA endpoint in the settings anyway. So congratulations, that is the first section of the exam study guide complete. Next up, we move into the biggest section of the exam, which is worth 40 to 45%. Camilla has been seriously impressed with your skills and knowledge so far. In the next lesson, we'll be looking at how to create objects in a lakehouse and a data warehouse. So click here for the next lesson in this series. Hey everyone, welcome back to the channel, and this is going to be video 5 in our DP-600 exam preparation course. And in this video, the focus is going to be on getting data into Fabric. Now, this is the first part of the second section in the exam, which is all around preparing and serving data. And it's worth 40 to 45% of the exam. So there's going to be a lot of questions in this. So let's get into it. In the video, we're going to be covering ingesting data using data pipeline, Dataflow, notebooks, copying data, which is basically the same thing, but they've included it twice in the study guide. Choosing an appropriate method for copying data. So not just understanding what the tools available to us, but making decisions about the best method given a particular problem or a particular scenario. And also creating and managing shortcuts. Now you'll notice that these are slightly deviation from the study guide. What I've done is I've had a look at the whole of section 2 and I've changed some of the order of things. Don't worry, we'll be going through all of the skills in the study guide, but we're just going to be going through them in a slightly different order. So these are the 4 that we're going to focus on today. Now I have released a video in the last month, this one here, data pipelines versus data flows, shortcuts, notebooks. And this is a more comprehensive video, so I would definitely recommend watching this either before or after this video. So as such, for this video, we won't be starting from zero, more revising what we went through in the last video, updating it a little bit because there have been some changes, revising some of the core concepts and the distinctions between these tools that you need to know for the exam. As ever, there'll be 5 sample questions at the end of this video, and we've got the school community with quite extensive notes and links to further resources if you want to go into a bit more detail about any of the topics that we cover in this lesson. So let's start with a bit of a framing of all the different options that we have available to us when we're talking about ingesting data and getting data into Fabric. So one group of tools is the data ingestion, the ELT or the ETL tools, right? So extract, transform, and load. These are going to be copying data from external systems, bringing them into Fabric and saving them in some sort of data store in Fabric. So we've got the data flow, the data pipeline, the notebook, and the event stream. Now the event stream I don't think is actually covered in the DP-600 exam, so we're not going to be talking about that much today. We also have shortcuts, so that's another method that we need to be aware of that we're going to go through in this video, and that involves bringing data in from Amazon S3, ADLS Gen 2, the Dataverse, and also Google Cloud Storage as well. We've also got internal shortcuts, so connecting our different data sets within Fabric, so creating references to other lakehouse tables from a lakehouse, for example. Then at the bottom, we've got a new feature that's in preview at the moment, which is database mirroring. So you can create a mirror of your database within Fabric from either Snowflake, Cosmos DB, or as a SQL at the moment. And again, I don't think this is actually part of the exam study guide currently, so we're not going to be talking about it in this section of the study guide. If you don't want to learn a bit more about database mirroring, I did mention it in that video that I mentioned previously. So in this video, we're just going to be going through the data flow, the data pipeline, the notebook, and shortcuts in a bit more detail because these are the things that you need to study for the exam. starting with the data flow. So as you know, the data flow comes with about 150 connectors to external systems, and you can bring that data in using Power Query, like that no low code interface, and you can do data transformation on that data before writing it to one of the Fabric data stores. So when should you use it, and maybe when should you not use it? Well, if you want to use any of those 150 connectors, then it's definitely good to use Dataflows. It's a no and low code solution, so it's quite maintainable. If you have people who perhaps don't have SQL or Python skills in your organization, this is a good method. And as I mentioned, we can do extract, transform, and loading all in one tool. Now, the data flow is one of the tools that we can use to access on-premise data via the on-premise data gateway. And it's also quite useful when you want to ingest more than one data set and maybe combine them in the same data flow. Although if you're following a kind of medallion architecture, maybe that's not what you want to do, but it's just an option that is possible with the data flow. It's also the only tool that we can use to upload raw local files. So maybe you have a CSV file, this file won't ever have to really be updated. You just want to get some data into Fabric. You can do that in the data flow. So maybe when you shouldn't be using this, well, traditionally, they've been struggling with large data sets, but there's been a number of features released to try and speed that up. So recently they released fast copy. So that's one feature that they released to try and speed up data flows. Now the data flow uses the same backend infrastructure that the data pipeline uses in the copy data activity. So the performance between these two should now be a lot more similar. Another aspect with Power Query is it's quite difficult to implement data validation, right? So because all of our logic is being locked up in those Power Query routines, it's difficult to kind of validate those steps as you're going through them. So that's maybe one reason why you might want to go for the ELT routine rather than the ETL, extract, load, transform, rather than extract, transform, load. Now, it's also the only tool out of the data flow, the data pipeline, and the notebook where you can't pass in external parameters. So it's difficult to build kind of metadata driven architectures with the data flow at the moment. Now, there is a kind of way around this where you can create another query within your Power Query engine of the data set or the metadata that you might want to use to parameterize a solution. So there is kind of a workaround, but there's no native functionality for passing parameters into a data flow from a data pipeline, for example. Next up, we're going to be talking about ingesting data with a data pipeline. And the data pipeline is primarily an orchestration tool, right? But it can also be used to get data into Fabric using the copy data activity and also some other activities as well you can use for this, but the copy data activity is the main one. Now, one of the main pros of a data pipeline is that it performs well on large data sets. And now, as I mentioned before, the data flow now has fast copy, so the performance should be comparable between the two. It has many connections to cloud data sources, especially in Azure. So it's good for using if you've got data in Azure, for example. We need some sort of control flow logic. So maybe looping through different tables, for example. There's a lot of functionality for building metadata driven or parameterized data ingestion methods. So that's something to bear in mind with the data pipeline. And as well as the copy data activity, you can also use it to trigger a wide variety of other actions in Fabric. For example, a stored procedure. And a stored procedure can also be used for ingesting data into Fabric. For example, the copy into statement in T-SQL can be used to ingest a CSV file into a data warehouse directly, for example. Now, some of the cons in the data pipeline, well, it can't do the transform piece natively. So there's no real data transformation activities. But what you can do is embed notebooks and data flows into a data pipeline if you want to do that transformation. It has no ability to upload local files, so that's not possible with a data pipeline. And at the moment, you do need to be careful with any sort of cross-workspace data pipeline usage. Now, we did submit an idea on ideas.fabric.microsoft.com, and it is actually going to be planned now, so that's good news. So they've planned this feature. We don't know when it's going to be released yet, but they are working on support for cross-workspace data pipelines. And what we mean by that is maybe you want to bring data in from a data source and you want to write it to a destination that's in a different workspace to the data pipeline. So that currently isn't possible, but they're working on that feature as we speak. Next up, we've got ingesting data with a notebook. And a notebook is just a general purpose coding notebook, which can be used to, well, for a wide variety of things, but one of the things is to bring data into Fabric. Now we can do this via either connecting to APIs, using something like the requests library in Python or something similar, or by using client Python libraries. So for example, if you have a third-party SaaS product like HubSpot, a lot of the big ones have Python libraries that you can use to bring data in, as well as a lot of the Azure tooling. So Azure Data Lakes, for example, have a Python client that you can use to bring data in. That's another option with the notebook. So some of the pros here is, again, it's really good for extraction from APIs, because if you know how to code with Python, you can do quite customized logic around things like authentication and pagination, and that becomes really simple in a notebook. If you want to be using any of those client libraries, so anything from Azure is also really good, or HubSpot, as we mentioned previously. Now it's good for code reuse. So a notebook can be parameterized and then used in lots of different situations. You can also embed data validation and data quality testing into the incoming data. So we've done quite a lot on this channel around data quality and validating incoming data. So that becomes a lot easier in a notebook. And in terms of the performance, well, a few people have been testing the different performance of these different methods, and the notebook always comes out on top really in terms of speed and therefore also capacity usage. So if you're really sensitive around the amount of capacity units that you're using, then notebook is going to be the most efficient. And I'll leave a link to a bit of an analysis done on the Lucid BI blog, and it goes through some of the investigation work that they've been doing there. It's a really good blog if you want to learn more about that. Now, some of the cons, well, when you don't have a Python capability in your organization, that might sound a bit of an obvious one. But if you don't have a team to write and then support these ETL notebooks, then it's not going to be a good choice for you. And secondly, one of the limitations with the notebook is you can't actually currently write into a data warehouse. So if that's your destination, then you're going to be wanting to using other tools for data ingestion, not the notebook. Okay, so the other method that we can use to bring data into Fabric, or at least make data accessible from within Fabric, is the shortcut. And we've talked quite a lot about shortcuts on this channel so far. So what we're going to be doing is just a bit of a review of what's possible with a shortcut and some of the things that you need to bear in mind for the exam. So the first thing is kind of a bit of an overview really. A shortcut enables you to create a live link to data stored in another part of Fabric, which is an internal shortcut, or in the following external storage locations. So ADLS Gen 2, Azure Data Lake Storage, Amazon S3, other services that use Amazon S3 for storage. For example, Cloudflare buckets also use Amazon S3, and that's quite a big section of the market. There's a lot of tools that use Amazon S3 for their storage, and that is now opened up for shortcuts. Google Cloud Storage is another one, and also tables in the Dataverse. Now, a shortcut can be set up for individual files, but also for a folder. So if you set up a shortcut to a folder, it's basically going to bring in all of the files that are in that folder and sync them. Now, one thing to be careful of is the cross-region egress fees. So if your Fabric capacity is in UK South region, for example, but your ADLS storage account is in West US, then you're going to be charged cross-region egress fees by Azure, basically. And that's 1 cent per gigabyte of data that's transferred. Now, you can also create shortcuts now via the Fabric REST API as well. So if you want to do some sort of programmatic creation of shortcuts, maybe you want to do hundreds of tables shortcutting in one go, then that's an option for you there. Now, something that might come up in the exam is around permissions for shortcuts. So what I've done is I've just copied the documentation piece here, and I'll link to this in the school community, as always. So what this table is showing is the shortcut related permissions for each workspace role. So starting at the top there, we've got creating a shortcut. Well, to be able to create a shortcut, the user needs write permission in the place that they're creating the shortcut, and also read permission of the file or the thing that they're shortcutting to. Okay, so these are the two permissions that you need side by side to create a new shortcut. Secondly, if you just want to read the file contents of a shortcut, well, you're going to need read permissions in both the place where the shortcut lives, but also where the reference file is living as well. So you need at least read permission in both of these locations. If you want to write new files or new data to a shortcut target location, you're going to need write permissions for both of those locations, both where you're writing the shortcut data to and where that shortcut data is being read into as well. So let's just talk now about deciding when to use which method, and we did touch on this in the first lesson in this series. We talked about some of the deciding factors when we're planning out our Fabric implementation, right? So talking about the storage, where is it stored, and also what skills exist in the team. And that's a really good start, but there's also some other factors that we need to bear in mind when we're thinking about choosing a data ingestion method. So if you have a requirement for real-time or near real-time data, you're going to be wanting to prefer the options like the shortcut if it's a file or folders, or database mirroring if it's in a table in any of the 3 database types that are supported by database mirroring, because these are live links to those locations. So when you query it, it's going to have near real-time data coming back. We talked about the skills in the team. So if you've got predominantly no and low code users, then the data flow and the data pipeline. If you've got predominantly SQL based, then you can use the data pipeline and the stored procedure activity or script activity, and we'll look at some of that in the next lesson. We'll be talking more about stored procedures and that kind of thing. But it is possible to use, for example, the copy into statement for ingesting data from files like Parquet files or from CSV files into a data warehouse. And if you've got Python or Scala skills, then you can be using notebooks. The next thing is around cross-workspace limitations. As we mentioned before, the data pipeline must be in the same workspace as your destination store when we're talking about data ingestion, right? So it needs to be in the same workspace. And the other 2 methods, the data flow and the notebook, they don't have those limitations, just to be clear on that. Next, talk about the scalability and the size of your data and cost and capacity usage, and all these things are pretty tightly linked, right? So in general, the notebook from quite a few people's analyses that I've seen is the most efficient method. I'm not sure if you'll be tested on this in the exam, but just something to bear in mind for when you're actually designing solutions. Okay, so now let's test some of our knowledge in this part of the exam when we're talking about getting data into Fabric. Question 1. You're trying to create a shortcut to a folder of CSV files in Azure Data Lake Storage Gen 2. Which of the following is a valid connection string you can connect to? A, B, C, or D? Now I'll pause the video here, have a bit of a think, and I'll reveal the answer to you shortly. So the answer here is D. So in Azure, there's a number of different endpoints that we can connect to it for a storage account. And the one that we need for a shortcut is the DFS, the distributed file system path, which is D, the database.windows.net. Well, it's not a database, so it's not going to be A. And B and C are both endpoints of a storage account, but it's not the ones that you need to create a shortcut. Question 2, you're implementing the first stage in a medallion architecture. Your goal is to retrieve data from a REST API using a GET request. And you're going to save the raw JSON response in the files area of a bronze lakehouse. Which of the following methods can you use to achieve this? Now there's 3 correct answers here. Is it A, the data pipeline copy data activity, B, the data flow with the web API connector, C, the event stream, B, the data pipeline web activity, or E, the Fabric notebook? So there's 3 methods here. A, the data pipeline copy data activity, D, the data pipeline web activity, and E, the Fabric notebook. Now, one of the important parts of this question is that we want to save the raw JSON response in the files area of a bronze lakehouse. So we're not going to be ingesting it directly into a table. We want to save the raw JSON. And these 3 are the only 3 where that's possible. The data flow, we have to output it into a data store, so into a lakehouse table or into a data warehouse table, for example. So we need to perform some sort of transformation on that JSON. We can't just write out the raw file. Same with the event stream. And the other 3 does allow us to do that. So the data pipeline, you can output in various different file formats. And with the Fabric notebook, you can do that as well. Question 3, your goal is to extract a CSV file in Azure Blob Storage and write it to a Fabric data warehouse table. Which of the following methods can you not use to achieve this? Data pipeline copy data activity, B, data flow with a blob storage connector, C, in a Fabric notebook, use the Azure Blob Storage client library for Python, get the file and write the data into the data warehouse table, D, use the copy into statement in T-SQL from within your Fabric data warehouse. So the answer here is C. Which of the following methods can you not use to achieve this? So you can't, as we mentioned in the lesson today, you can't use a notebook to write data directly into a Fabric data warehouse. So that was the clue in this question. All of the other 3 methods, so the data pipeline, the data flow, and the copy into statement in a T-SQL script, they can be used to ingest data into a Fabric data warehouse table. Question 4. Workspace A contains Lakehouse A. Workspace B contains Lakehouse B. You want to create an internal shortcut in Lakehouse A pointing to a table in Lakehouse B. What's the minimum level of workspace permissions you need to achieve this? A. Contributor in Workspace A and viewer in Workspace B. B. Contributor in Workspace A and contributor in Workspace B. C. Member in Workspace A and contributor in Workspace B. Or D. Viewer in Workspace A and viewer in Workspace B. So the answer here is contributor in Workspace A and viewer in Workspace B. So when we were talking about the workspace roles permission required to create a new shortcut, well, you need some sort of write permission in the workspace where you're creating the shortcut and read permissions in the lakehouse that you're actually referencing. So the important part of the question here is what's the minimum level of workspace permissions that you need to achieve this? So the others, or B and C at least, would allow you to do this, but it's not the minimum level of permissions that's required. And D, viewer in Workspace A. If we're a viewer in Workspace A, then you won't have the permissions to create the shortcut in Lakehouse A. Number 5. One of your team is a superstar using M code for data extraction. In which of the following data extraction tools can you write M code? Is it A, the Fabric Notebook, B, in a T-SQL script in the data warehouse, C, in a data flow, or D, in a data pipeline mapping data flow? So the answer here is C, the data flow Gen 2. That's the one with the Power Query interface, and you can write in the advanced editor, you can write M query, obviously not in the Fabric Notebook or a T-SQL script. And the data pipeline doesn't actually have a mapping data flow activity. So that's a bit of a red herring. That's coming from Azure Data Factory where that did exist, but not in Fabric. Congratulations, you've completed the first part in section 2 of the study guide, preparing and serving data. In the next lesson, we're going to be looking at the Fabric data warehouse in more detail. And we're going to be looking at how you can schedule all of your ETL workloads, whether that be a data flow, a notebook, or a data pipeline. So click here to continue your DP-600 learning journey. I'll see you there. Hey everyone, welcome back to the channel. Today we're continuing the DP-600 exam preparation course, and we're going to be looking at SQL, the data warehouse, and how we can schedule things to run in Microsoft Fabric. This is video 6 in our series, so we're nearly halfway. We've covered a lot of ground already, but there's some way to go still until we get to the end of the course. In this video, we're going to be covering creating views, functions, and stored procedures in that data warehouse experience, how we can add stored procedures, notebooks, data flows to a data pipeline, then how we can schedule data pipelines, and also schedule things like data flows and notebooks. And throughout this section of the course, obviously we're going to be focusing on what you need to know to prepare for this DP-600 exam. A lot of these topics can go really deep, but we're just going to go through what I think would be sensible to learn for the exam in case they come up. Now this lesson will be pretty much 100% practical, so we're going to be going into Fabric, having a look and creating all of these things ourselves. At the end of the lesson, we'll be doing 4 sample questions. And as ever, I've got some key points and links to further learning resources if you want to learn more about a particular topic and really brush up on your skills in a particular area for the exam. Okay, so let's start off by looking at creating functions and stored procedures and views in the data warehouse experience. What all these things are, when you should be using them, how you should be using them, and things you need to bear in mind for the exam. So we're starting off in a workspace here, and I've created some Fabric items, the most important one being this data warehouse, DP-600 data warehouse. And if we open that up and have a quick look around, just created some really simple tables. We're going to be using 1 or maybe 2 of these tables for this tutorial, specifically this dbo.employees table. It's only got 4 rows, but that's good enough just to show you the functionality of a function and a stored procedure and a view. So what we're going to be doing is we're not actually going to be working in the Fabric online experience. We're going to be using SQL Server Management Studio. So what we're going to be needing to do is go into the settings of the data warehouse, collect this SQL connection string, copy that, and then go over to SQL Server Management Studio. You can download that for free. I'll leave a link in the description or in the school community. And then we can connect to our Fabric data warehouse from within SQL Server Management Studio. Now I've already set up the connection here, but if it's your first time using SSMS and you haven't connected it before, just click on connect to a new database engine, add in your server name here, use the Microsoft Entra multi-factor authentication. It will ask you to authenticate with Fabric in the online experience, and then you should see your databases listed here. We've got this DP-600 data warehouse that we were looking at previously, and you can see that we've got some tables. We've got the employees table, the gold table, and some other tables in here as well. So let's start off just by exploring what we've got here, right? So let's just do a very simple select star from dbo.employees, and that's just going to return all of that data just so we can have a quick look at it, make sure it's all connected correctly. Yeah, so we've got our 4 rows there, 3 columns, employee ID, name, and age. Perfect. So say we've got this table here, dbo.employees, and for a Power BI report that we're wanting to create, we actually want to do a bit of transformation on this table. We don't want the raw table just as it looks like here. We want to do some sort of transformation. It doesn't really matter what that transformation is for this demo. Maybe we'll want to do a where statement. So where name is like Jack, for example. This is just going to bring us back all of the employees that are called Jack, and we're using this percentage wildcard operator here. And what that means is if the first 4 characters are JACK, anything after that is going to return in our results set here. As you can see, we've only got 1 Jack in the data set, so that's coming back correctly. Now in our Power BI, imagine we want to query just this results set. Well, what we can do is we can save this query as a view. Now, this is a bit of a toy example, but sometimes you have a view that might have really complex transformations, right? It's not stored in the database, but whenever we query it, we want the transformations to be done at query time. So all you can do to create a view of this is add in create view, give the view a name, dbo.employee, get Jack, and then use the keyword as, right? And then everything that follows that is going to be part of your view. And if we just execute that, we can see that that's been successfully completed, and then we can just do select star from dbo.view employee get Jack, and if we execute that, we get the same result as before. So now when you're creating your Power BI report, you can just query this view rather than the underlying table to get the transformed data back. Okay, so that's the basic syntax for creating a view. What I've done is I've just written down some key points to understand just in general, but also for the exam as well. So for a view, the transformed data is not stored, right? It's just the transformation logic and the code, the SQL code is stored. And then every time you query it, maybe in a Power BI report, it's going to perform that transformation at query time. Now you can create a view from another view. So you can query another view from, for example, this view employee get Jack. We can query that if we create another view. That's possible. But you do have to be careful with performance. Sometimes when you string multiple views together and they're doing lots of heavy processing, then it can have an impact on performance. And it also can be difficult to understand and maintain if you're constantly querying other views from other views. So that's something to bear in mind. Now with a view, we can't specify any sort of parameters, okay? It's just simply select statements. You're just going to be able to query it like so, and whatever the results is, you get those back. Now this is possible with functions and stored procedures, as we're going to see in a minute. And as we mentioned, reading a SQL view into semantic model will fall back to direct query mode. So direct lake mode is not possible. And that makes sense, right? Because direct lake works by reading the underlying delta tables. And in a view, those delta tables don't exist, right? So that's something to bear in mind with a view. So if that's a view, now let's look at a function. So say we want to parameterize that view that we had, right? We want to pass in a parameter, maybe first name, so that we're not just getting back Jacks, we can potentially use it to get a list of employees given any first name. Let's have a look at what that might look like. So this is a declaration of a function. Now you notice it's similar in some ways to the view, but there are some key differences. We're going to start by calling create function. We give the function a name. This one's function employee, first name search. Then we're going to open some brackets, and the brackets are really important in a function. It's a bit like a function in Python, for example. You're going to open those brackets and pass in a parameter. Now the parameters are optional. You don't have to pass in a parameter, but it is an option. We're defining our parameter with this at symbol, so at first name, and then we give it a data type, which is varchar 20, and this is a default value. This is saying we have one parameter, and the parameter name is first name, the parameter type is varchar 20, and the default value is an empty string. Now the next really important piece of syntax here is this returns table. So if you've used any sort of SQL functions in other flavors of SQL, you know there's a few different types of functions. Now in Fabric, we're talking about table functions, which means that it returns a table, right? We're not talking about scalar functions, because that's currently not possible in Microsoft Fabric version of T-SQL. We're going to be calling a function and it's always going to return a table. So in our syntax, we have to define that, right? We say returning a table as return, open brackets, and then we can pass in whatever we want to declare in our select statement. Now this is very similar to our view declaration, but here we're making it dynamic, right? We're parameterizing it and we're using our first name parameter. So let's just run this. Okay, so we've created our function. Let's just have a look at what that looks like. So if we go to programmability in SQL Server Management Studio and in our functions, you can see that in SQL Server Management Studio, they do actually make the differentiation between scalar valued functions and table valued functions. So as we know, R1 is going to be in this table valued functions. Here it is here, DBO, function, employee, first name search. And we can call it like this, select star from DBO, our function name, open brackets with the parameter. So if we call this, execute, and you see that it returns the same as what we had before, but it's parameterized. So now instead of just Jack, we've created a bit of a parameterized function here. So we can call Jack, we can also call Sarah, whatever that needs to be. We're just encapsulating all of that logic into a function and we've parameterized it so that you can use it in multiple different places in your T-SQL code base, and it just packages up that logic into a nice reusable function. So what are some of the key points with a function? As I mentioned, it's useful for packaging up logic that you might want to reuse in different places, and it can be parameterized. Now with a function, you can only do select statements, so you can't actually update any rows, you can't do any sort of insert statements, it's only DDL, flavors of SQL, only select statements. So to call a function, we can only really use a select statement like so, or we can call it from within a stored procedure or from within a view, which is kind of underneath this DDL as well. If you've got a DDL view, and by DDL, I just mean select statements, basically. It can't be orchestrated directly, right? So we can't use it in a data pipeline directly, although we can embed it in a stored procedure, as we mentioned previously. It allows one or more parameters, specifically input parameters, and the output type should always be a table, okay? So in Fabric, we're only going to be using table valued functions, and it's always going to return a table. Okay, so that's the function. Now let's move on to the stored procedure. So this is a very basic definition of a stored procedure. We've got create procedure, we give the procedure a name as, and here we're just doing a select statement, right? And all this is going to do, there's no parameters. You'll notice when we execute a stored procedure, we're just going to use this exec, which is execute. So that's one of the differences between a stored procedure and a function and a view, the way in which we call it, right? So at the moment, we're not really doing much with this stored procedure. It's just like the most basic stored procedure possible. We're just passing in a select statement and we're executing it and we're getting back the results set, the full results set. Now let's step it up a gear and add in a parameter. So we've got a very similar thing to what we were looking at before, create stored procedure. Now we've got DBO SP underscore employee underscore get by first name, and we're passing in, or we're declaring a parameter. The parameter is called first name. Again, it's going to be of type varchar 20. Underneath that, we're declaring what we actually want to do in this stored procedure. So we want to select all of the employees where the name is like first name, which is going to be passed in as the parameter. And we're adding this kind of wildcard operator onto the end so that as anything that goes after that, whatever their surname, we're going to return that as well. So let's just execute this to create the stored procedure. So let's just drop it. Drop procedure if exists dbo dot. Okay, so now we've dropped it. We can recreate it again just to show that it works. Completed successfully. And then if we want to execute that, again, we're going to use the exec command, pass in the name of our stored procedure and our parameter, which is Jack. If we execute that, we get this. So that's the basic definition of a stored procedure, what it looks like. Now let's think about some of the key points here. So with the stored procedure, we have the ability again to define input parameters, but also output parameters as well. Now, I didn't show you that in this lesson. Maybe that's one for another lesson, but we can actually define output parameters, which are useful in the data pipeline scenario. Maybe we'll look at that another time on the channel. Probably all you need to know for the exam is that it is possible. Now they're called using this exec command, right? It's not as part of a select statement. You can call other stored procedures from a stored procedure. So you can create 3 stored procedures and then create kind of like a master stored procedure that calls each of these other stored procedures in series. Now, one of the key use cases of a stored procedure is to give people access just to the stored procedure and not to the underlying data. So you can use it as a security mechanism just by giving people access to the stored procedure, and you know they're only getting access to the results of that stored procedure and not any of the underlying data. Now, one of the key points in Fabric to understand is that the stored procedure is it's one of the only things that we can embed into a data pipeline, and we can pass the parameters that we've seen here from other notebook activities. So that's something to really important to understand with stored procedures. They become a lot more useful because they can be orchestrated as part of a data pipeline. Then they become really useful for data transformation and all of these kinds of things in your data warehouse and in your architectures in general. Now, the one I'm missing here is the ability to do inserts, updates, deletes. Now, this is what's unique to the stored procedure, at least in this list here, is that here we're just using a select statement, but we can use stored procedures for updating and inserting the underlying data sets. So they can be really powerful tools that we can use for any sorts of data transformation, data loading, all these kind of things are possible with a stored procedure. Okay, so let's just focus now on the stored procedure. And we mentioned here it can be embedded in a data pipeline. So let's go back into Fabric now and have a look at what that looks like. Okay, so here we are in a data pipeline, and you'll notice if we go over to the Activities tab, there's a lot of different options for activities. Now, the three that they mention for the DP-600 study guide are the stored procedure activity, the notebook activity, and the data flow activity here. We're going to go through each one in a little bit of detail, have a look at some of the settings that we can apply when we're creating these activities in a data pipeline. And then we're going to go on to look at how we can schedule these things, starting with the stored procedure. So when we drop the stored procedure activity onto the data pipeline canvas, we can have a look at some of the settings that we get out of the box, right? So most of the configuration happens within the settings tab. You can navigate to your specific data warehouse that you want to connect to, obviously noting that the data warehouse you connect to currently has to be in the same workspace as your data pipeline. We've mentioned that quite a lot on the channel around some of the cross workspace limitations with the data pipeline. So just be wary of that. Then we connect to the warehouse, and then we can choose from a number of different stored procedures that are in that data warehouse. We can define any sort of parameters that we've got here. There is this option to automatically import parameters. So it's going to look into your stored procedure. It's going to pick out any parameters that you've got there. Here it's found one called first name. It's of type string, it knows that. And currently we're just hard coding in a value here called Jack. But one of the benefits of the stored procedure is that you can add dynamic content, right? So you're going to be able to parameterize that stored procedure activity and pass something into this value here using data pipeline parameters. On the general tab, we've got just the name of it, so you can update the name. You can make it active or deactive. We can add a timeout. So this might be quite useful for some data pipeline activities. Maybe you've got a really long-standing stored procedure. It might take half an hour to run. You might want to add a timeout here at 1 hour, because if it runs for 1 hour or longer than 1 hour, you know that probably something has gone wrong and you don't want it to lock up your database, your data warehouse. So that's something to bear in mind here, the timeout. Another one is the retry. So this retry setting is available on quite a few of the data pipeline activities. And as the name suggests, it's going to try it. And if it fails that activity, it will retry the number of times that you specify in this box here. We can give it a retry interval. So we're going to say, okay, we're going to try it once, then we're going to wait for 30 seconds and then try it again. Secure output and secure input as well. This is just going to specify whether you want to output into a log the results of that activity or in the input as well. So that's the stored procedure activity. Now let's look at this notebook activity. So we've got a notebook here. And again, if you go through to the settings, you can define your workspace and your notebook here. I've got notebook load to silver. Similarly with the stored procedure, we can declare any parameters. So if you've got a parameter cell in that notebook, you can pass parameters into the notebook from other activities in your data pipeline. And again, we've got very similar settings on the notebook as we had with the stored procedure activity. We've got a number of retries. So with the notebook, a retry is probably more important or more likely you're going to be using this, because with the notebook, you're obviously using the Spark cluster and also potentially querying REST APIs. So there's a lot more that can go wrong, I would say, in a notebook than in a stored procedure. So the retry functionality here, I think Microsoft recommends that you set the retry to 2 or 3, just so that if your Spark cluster is busy and you're doing lots of computation on it and the session times out or something goes wrong with your notebook execution, it's going to retry it. So always recommended to add in 1 or 2 retries into a notebook activity. Again, we can specify the retry interval down here and secure input output. So these are the same as the stored procedure activity. Now the final one we're going to look at is the data flow activity here. Similarly, you're going to go over to the settings table, find your workspace and your data flow, select a particular data flow that you want to run, and that's basically it. If we go back to the general tab, you'll see that the settings here are exactly the same. We give it a name, description, we can set the activity state to active or deactive, we can give it a timeout and a number of retries and the retry interval. So that's a little bit about the stored procedure activity, the data flow activity, and the notebook activity in data pipelines. Now let's look at scheduling a number of these different items in Fabric and the different options that are available to us there. So here we are back in our workspace, and let's look at how we can do scheduling of different items within Microsoft Fabric. Now, there's a few different ways that we can schedule things to work in Fabric, these ETL jobs mainly. We can schedule them to run maybe every hour or something like that, depending on your use case. We're going to be looking at scheduling data pipelines, data flows, and notebooks in a bit more detail here. So with the data flow, we can actually schedule from a workspace. So we can click on the settings of a particular data flow, just by clicking on these ellipsis 3 dots here, clicking on the settings of that workflow, go down to the refresh settings, configure a scheduled refresh, and we can turn that on, and we can change the update frequency to daily or weekly. Or if you want more fine-grained refreshes than that, we can add specific times, 1 AM, maybe 2 AM, 3 AM, that kind of thing here. Now with the data flow, the maximum number of refreshes per day that you can do is 48. So that's in line with what you could do previously in Power BI Premium. We can also send refresh failure notifications here to specific people or the owner or both. Let's just hop back to our workspace now and look at the notebook. So with the notebook, it's a similar story. We can click on either schedule here or settings. Both take you through to the same thing here. Opens up this sidebar menu where we can specify the schedule. And again, we can repeat it every hour, every day, weekly, or by the minute. So every 5 minutes, for example, we can specify a start time and an end time and the time zone that you want that schedule to be running on. So this is one of the key differentiations between the notebook and the data flow. Obviously, we can specify a frequency that's a lot more than 48 refreshes per hour if we're using this. But bear in mind, obviously, it's going to use a lot more capacity units. So if you don't need to refresh your data at this cadence, at this interval, then don't do it. So that's the scheduling of notebooks. Now the data pipeline is obviously a data orchestration tool. So another way that we can do it is by putting our notebook and our data flows within a data pipeline and then scheduling the data pipeline. So you'll see here within the data pipeline, we've got this schedule button. Again, it's going to open up a sidebar menu. We can click on here and specify by the minute, hourly, daily, weekly, again, like so. Start and end time and the time zone. So it's very similar to the notebook scheduling functionality. Now, if you're coming from ADF, Azure Data Factory, currently one thing to bear in mind is that the only way of triggering a data pipeline is with scheduling, right? To schedule it, to trigger a data pipeline using a schedule. We don't currently have event-based triggers or window triggering or HTTP request triggering, all those different really useful functionality for triggering a data pipeline that does exist in ADF as a data factory, currently doesn't exist in Fabric. The only way we can use is this schedule trigger. Now you might be thinking, okay, when should I use the inbuilt scheduling for a data flow, for example? And when should I use a data pipeline for scheduling? Well, it just gives you a bit more flexibility and functionality for handling different events if you use the data pipeline. Say, for example, you wanted to add some sort of activity on fail. Maybe you want custom notification or some sort of other activity or logging to be done. That's possible, obviously, if you schedule it using a data pipeline. But if you schedule a data flow to refresh within the actual data flow, you don't have access to all this other functionality that you get in a data pipeline. So that's why you might want to think about, embedding your data flows into a data pipeline and then triggering them from a data pipeline. Okay, so that rounds up the content for this lesson. Now let's go back to the slides and test some of the knowledge of the things that we've learned in this section of the study guide. Okay, so let's just round off this video with some practice questions. Number 1, The maximum number of scheduled refreshes allowed per day with the Dataflow Gen 2 is A, 12, B, 24, C, 48, D, 96, or E, unlimited refreshes per day. Pause the video here, have a think, and then I'll reveal the answer to you shortly. So the answer here is 48 refreshes per day. So you can get a Dataflow Gen 2 to refresh every half an hour if that's what you want to do. Now, if you're coming from the Power BI premium world, you'll be used to this. The other figures are just incorrect, really. Question 2. Which of the following can you use to update a row in a data warehouse table? Is it A, a stored procedure, B, a view, C, a create table statement, or D, a function? So the correct answer here is a stored procedure. That's the only one that allows you to actually update data in a data warehouse table. A view, as the name suggests, is just read-only. It creates a view on top of the data. It doesn't actually modify the underlying data. A create table statement is not going to be able to update a row, and a function also cannot actually update the underlying data. So the answer here is A, a stored procedure. In a stored procedure, we have a lot of flexibility to insert into, to update rows, to delete rows. All of that kind of DML is exposed in the stored procedure and available to us. And by DML, I mean data manipulation language. It's a subset of SQL as part of the SQL language. Question 3. Which of the following statements is false when talking about operations in a Fabric data warehouse? A, you can call a function from a stored procedure. B, you can call a function from a view. C, you can query a view from another view. D, you can call a stored procedure from a function. So the answer here is D. You can call a stored procedure from a function. This is the only one that you actually can't do. So you remember that with the stored procedure, we have to use that the execute command to execute the stored procedure. And you can't do that from within a function. Now you can call a stored procedure from another stored procedure, but that's pretty much the only time when we can call another stored procedure from another item. The others, you can call a function from a stored procedure. Well, we know we can do that. You can call a function from a view. Yes, you can do that. And you can query a view from another view. You can also do that. So the correct answer here is D. That statement is false. Question 4. You are orchestrating many Spark notebooks to perform data transformation activities at the same time. Now you notice that sometimes the notebook execution is failing because your cluster is busy. That's the error message that it's giving you. Now what modification can you make to the data pipeline notebook activity to give the pipeline more chances to run successfully? Is it A, deactivate and reactivate the activity? B, set the number of retries to 2 or 3? C, change the parameters you are passing into the notebook? Or D, add a failure activity to handle the execution failure? So the answer here is B, set the number of retries to 2 or 3. You'll remember that the retry option in a notebook activity, it allows the activity to retry if it fails a number of times. So if your Spark cluster is busy and it can't execute the first time, it's going to wait and then retry it 2, 3, or any amount of times that you specify in that retry parameter, in that retry setting. Deactivating and reactivating the activity, that's not going to make much difference. Changing the parameters, well, you probably don't want to do that because it's going to change the output. And adding a failure activity to handle the execution failure. So that might be a good idea, but it's not actually going to impact the result of your activity, right? It's not going to allow it to rerun and get a successful execution. So the answer here is B. Congratulations, you've completed the second part of section 2, preparing and serving data. In the next lesson, we're going to be deep diving into the exciting world of data transformations within Microsoft Fabric. Make sure you click this video here to join us in the next lesson. Hey everyone, welcome back, and this is the next video in our DP-600 exam preparation course. This is video 7. We're going to be looking at transforming data, and there's a lot to get through with these, and it's a little bit overwhelming when you look at the things that we're going to be covering. Don't worry, I'm going to break them down into a number of different sections, hopefully to make it a little bit more digestible. So we're going to be looking at first, data cleansing. How can we implement a data cleansing process? We're going to look at resolving some common issues that we get with data. So duplicates, missing data, null values, conversion of data types, and filtering data. And we're going to be looking at how we can do those things using the Dataflow, T-SQL, and Spark as well. Then we're going to move on to data enrichment. So under this category, we're going to be looking at merging and joining different data sets together, and also enriching the data that we've already got. So adding new columns, new tables based on our existing data. Finally, we're going to take a look at data modeling. We're going to look at the star schema, what that is. We're going to look at type 1 and type 2 slowly changing dimensions. We're going to look at the bridge table and what problem that solves and how we can implement the solution using T-SQL. We're going to look at data denormalization, aggregate and deaggregating data as well. As ever, we're going to be testing your knowledge at the end of this video. So we've got some sample questions and all of the key points for this section of the exam, plus links to any further learning resources if you want to dig into a bit more detail into any of these topics. They're going to be posted on the school community. I'll leave a link in the description below. So first, let's take a look at the data cleansing process. And to give a bit of structure as to what we're looking at here, I'm going to be talking through the lens of the medallion architecture, whereby we have bronze, silver, and gold areas in our data processing pipeline. Now, when we talk about data cleansing, normally this takes place anywhere really between the bronze and the silver, and maybe in the silver as well, this data cleaning, because we're going to get some raw data in bronze, but it's going to be messy. So we want to be doing all of our data cleaning steps normally between bronze and silver. So the way that I'm going to do this is to walk you through how we can do common data cleansing routines and operations within all three of the tools listed there. So starting with the data flow, then we're going to look at how we can do all these things with T-SQL in the data warehouse and also in a Spark notebook as well. So let's jump into Fabric and start with data cleansing in a data flow. Okay, so for this part of the lesson, we're going to be jumping into Fabric and we're going to be transforming a particular data set here, and it's that car dealership sales data set. Now, the data set itself comes from this blog here, Tableau Server Guru. So thanks very much to this person who has some sample data sets on their website. Don't worry, we're not going to be talking about Tableau servers or anything like that, but they do have this nice car sales data set that I downloaded that comes in a pretty good star schema. And when you download this, it comes actually in XLSX. Now, this dataset is actually quite a clean dataset, so I've actually made some modifications to make it a bit more dirty so that we can perform some data cleaning on this dataset. And I'll leave a link to the dirtified datasets, if you can call them that. I'll leave them in the school community. So go over to there to get the source data files that I used here. And to get us started, what I've done is I've just put them into a Lakehouse files area. So it's a number of these CSVs, and then I've just loaded them simply into a number of tables. So this is going to be our bronze Lakehouse tables that we're going to be using for this part of the tutorial. So here we are in the Dataflow Gen 2, and I'm just going to show you how I can do some data cleansing within the Dataflow itself. I just pulled in one of those tables from our Lakehouse area, which this is the source here. It's in our Lakehouse, and I pulled in this revenue table. So this is what it looks like, basically completely untransformed. Now, you notice I've introduced some null values here. I've introduced a few duplicate values as well. So what we're going to do is just step through the different transformation steps to clean this data set within the Power Query experience, within the data flow. So the first thing that we might want to do is remove any duplicate values that we've got. So I know, because I've introduced some duplicates into this data set, that there are duplicates in here. So to remove any duplicates in this Power Query engine, what we're going to do, we're just going to highlight all of these columns, clicking on the left-hand column, holding Shift, and then clicking on the right-hand column. That's going to select all of our columns. Then we can right-click on the top here and then remove any duplicate rows. So this is important because we want to check that the whole row is a duplicate. So we need to select all of the different columns here and then remove the duplicates like that. And you can see that it's been added into this applied steps here. So if we take a look at our revenue column here, you can see that we do actually have some null values in this data set. Now, obviously it depends on your use case for data cleansing, but if this revenue value is actually really important, and this is the only thing that you really care about in that data set, then you might want to remove these nulls altogether from the data model. Again, it depends very much on your use case. So to remove the null values in this revenue column, we just click on the column itself and then deselect this null value, press OK. That's going to remove those null values from the data set. Now, another thing we can do is to change the type. So if you want to change type in the data flow, simply click here on change type. Now, it might not make sense for this particular column because this already looks good. It looks like an integer value and it's got an integer type here, a whole number. But say, for example, this was a text value and you know that deep down it is actually an integer, then you can just right click on that, change type to any of these types here. Now, another thing we can do with the Dataflow Gen 2 is add in new columns. So you can see here, add column. And what we can do is add a custom column. And maybe we want to do some sort of revenue bin. Maybe we want to add in some logic here to kind of group these revenues into something a little bit different. I'm just going to do a simple one here. Revenue is greater than 1 million. I'm going to give it the data type as a true or false. And then if we click OK, that should give us this true value just to check. Some of them are false. So yeah, that's happening correctly. So now maybe we want to change the name of that to something a bit more descriptive. Revenue over 1 million. Maybe that's probably a better description for what that new column is. And, another way we can filter these data sets, maybe you don't actually want all of these units sold. Maybe perhaps you're just for this particular piece of analysis that you're doing or this data set, you want to actually remove the units sold over 1. Again, just showing the functionality here. Really it depends on what your use case is in your business as to which data cleansing steps are going to make sense. So that's a bit of an overview of Power Query and how we can do data cleansing in the Dataflow Gen 2. Now let's jump over to the data warehouse and look at how you can implement similar data cleansing process using T-SQL. Okay, so I've just jumped over to the SQL endpoint here in that same bronze lakehouse, because here we've got the same tables here, but now we're just in the SQL endpoint experience. So we can write some T-SQL. And to begin with, let's just have a look at our data set here. Just make sure that that is coming through okay. Yep, looks exactly the same as we had in the data flow. So that's good here. So the first step we're going to look at here is identifying duplicates in this table. Now there's many different ways that we can use to identify and remove duplicates from a table using T-SQL. Now this method here I'm using is group by. So what we're going to be doing is grouping by something that I know is unique or should be unique actually for every row in this fact table. And we're going to be using having where a count of more than 1. So what this is going to mean is that for each of these groups, there should be exactly 1 row. So if this returns a count of more than 1 for this group, then we'll see that that is in fact a duplicate row. So let's just have a look at these. So we can see that here for these 2 dealer IDs and these 2 dates, we can see that there's actually 3 rows here. So if we just give this bit of number of rows, just to make that a bit clearer, and then we rerun that. Yeah, so now we can see our number of rows is 3 and 4. So how do we go about removing those duplicates? Well, again, one way of doing that is by using the group by again. We can group by the same 2 columns here, the dealer ID and the date ID, and we can just bring back a aggregate function. This is an aggregate function, the max of the revenue. And it's worth checking before you do this that the revenue figures for each of these rows are actually the same, so that the max or the min doesn't actually make a difference. We're just going to bring through whatever that value is. And the result of that is going to be the same data set, but with the duplicates removed, which is this one here. And then you can save that into another table or whatever downstream activities you want to do with it. So next, let's look at missing data, nulls, removing nulls, filtering, that kind of thing here. So there are some null values in this revenue column. So we're just going to use where revenue is null to identify those first things first. So we can see here, we've got 6 rows here where the revenue is null. So again, you might want to remove those. And obviously to remove those, well, it's pretty simple. We can just use is not null, and that will return you all where the revenue is not null. So one way we can just quickly verify that that is actually the case is if we just bring this into a bit of a CTE with remove nulls as this. If we do a select count star, remove nulls, we'll also do a select count star from the original table. Let's just compare these 2 values. Oh yeah, I have to actually call it. So we have result 1 is 1855. Result 2 is 1861. So we can see that the row count has changed by 6. And those are those 6 null values that we saw when we did the where revenue is null. So that's worked correctly. So another thing that we need to bear in mind for the exam is T-SQL type conversion. So here you can see what we're using is the cast function. And here we're going to cast the values in the revenue column as a float. I think currently it's an integer. And so what we're doing here is we're casting it as a float. So basically a decimal number. So by doing that, you can see here that when we bring both of these columns, we've got the original revenue here in this column, and that's an integer. And here it's changed the data type into a float using this cast functionality. Another thing we've done here is to add another column. So when you're using T-SQL, you can just add in another row here into your SQL script, and you can do whatever you want here. This is just a bit of an example here. Divided the revenue by 2, and I've given it a name of half the revenue. So that's just an example of adding new columns that we can do in T-SQL. Okay, so just to round off this part of the tutorial, next we're going to look at transforming data using PySpark notebooks. And specifically, we're going to be looking at some of the data cleansing routines that we've been looking at in the Dataflow and the T-SQL engine. Now we're going to look at how we can implement them in a Spark notebook. Now I did do a 3.5-hour tutorial, which goes into a lot more depth about different data cleansing operations. You can have a look at that video here. I'll leave a link in the school community if you want to have a look at that in a bit more detail. But here we're just going to go on a bit of a quick deep dive into some of the most common operations. And I'll also leave this notebook on our school community. So if you want to play along at home, then you can do that as well. So we're using this same bronze lake house. We've got our tables here. I'm just going to be having a look at this revenue table, which is our fact table in a bit more detail. And I've begun by just reading it into a Spark data frame and displaying the results here, just to check that everything's loading okay and we've got everything logged in here. Now you notice that I haven't actually committed or haven't actually written any of those changes that we made in the Dataflow and the T-SQL engine. So this is still reading from the raw data here in that bronze layer. So let's start by looking at duplicate data. Again, to identify duplicates, we can use a similar kind of pattern that we used in T-SQL by looking at group by or by using group by and then looking at count of more than one. So here you can see we've identified the rows where we have some duplicates in that data set, and luckily it's the same as what we were seeing in our T-SQL engine. So we can see that these branch IDs and date IDs have a count of 4 and 3 respectively. How do we go about dropping those duplicate values from our data set? Well, in Spark, we have this drop duplicates method. So what I'm going to do here is just start by counting the rows in the original data set, performing this drop duplicates, saving it into deduped, which is a new data frame, and then counting the rows in that new deduped data frame. Okay, so I've just printed out the result here. We can see that the process has removed, if I could spell process correctly, it's removed 5 rows from the data set. So I've just taken the difference really between our original data set and that deduped data set. So that makes sense because we've got 7 count here originally, and obviously 2 of those we want to keep, right, because they are actually valid data. So we've removed 5 rows, so 5 of them are duplicates. So that looks like it's worked correctly. And if we're just going to verify again that that's worked, we can perform the same operation that we did before, grouping by these 2 fields, looking at where the count is more than 1, and we've got this empty data frame here. So that looks like it's worked correctly. Next, we're going to take a look at missing data and how we handle nulls and that kind of thing in Spark. So first off, we're going to look at identifying missing values. You might want to do a bit of like inspection of your data before you go ahead and drop things. It's always a good idea to interrogate your data a bit, have a look at what you might be deleting. So let's just run this and then we'll talk through it. So we've got our original data frame here and we're filtering on this specific column here. So we're passing in df.revenue.isNull. So this is a method that we get on a Spark column, and we can see that it's returning these 6 rows that we know are null. Now, another way we can do that is, well, I've changed 2 things in this second example here, but it's basically using df.where. So df.filter and df.where are basically synonymous in Spark. This time we've passed in col, which is one of the Spark SQL functions. It's just another way of writing and obtaining that column data, and again we're calling isNull on that column data, and we're saving it into this nulls2 variable, and we're displaying that. And so we can see that these 2 are exactly the same, so both methods have returned the same null values, which is good. So now let's look at dropping some of those null values using the dropNA method. So this method has a few different parameters. These are 2 of them: how, threshold, and also subset, as we're using in this example here. So if you pass in a value in the how parameter, it can be either any or all. So if it's any, it's going to drop the row if any of the values in any column is null. If you pass in a how value of all, it's going to drop the row only if all of the values are null. Now, threshold is going to give you a threshold for the number of columns that need to be null for that row to be dropped. And obviously, if you use this value, it's going to overwrite that how parameter. Now, the other one that we're going to be using is subset. So you can pass in subset, and it's going to limit the columns that it looks for your drop. So in our example, we only want to drop it if there's a null value in this revenue column. And you can pass this in either as a list or as a string as well. In our example, we've only got one column in that list. So we're going to save the result as no NAs. And then we're going to do the same thing. We're going to print out the result here just to check that we have actually removed some rows. So we've removed those 6 rows, the null values from a data set. So that looks like it's worked correctly. So next, let's look at type conversion and also adding new columns into a Spark data frame. So we can call df.printSchema, and it gives you a bit of a look at what our schema is initially for this data set, including the data types for each column. What we're going to do is get the column using df.unitSold. So that's one of our columns here. Currently it's an integer, and for the purposes of this demo, we want to use the .cast method, and we're going to give it the data type of string. Then what we've done is we've printed the schema again, just to check what that schema looks like. And we can see here, this unit sold converted. So we've passed in this unit sold converted, which is the new column name that we get with this with column function. And we can see that from the print schema, it's showing a data type of string. So we've successfully casted that value from an integer into a string value. So let's just take a quick look at filtering, and we've already had a look at some filtering previously in this lesson, but let's just go over it again. So in a filtered data frame, here we're getting the original data frame and we're calling df.where. We're passing in the column name, and the column here is revenue, and we want to filter only for data that is more than 10 million. So we can see that this has actually removed, it's filtered out 1,109 rows from this data set. As I mentioned previously, we can use df.where or df.filter if you want to do filtering. If I change this to df.filter, should work exactly the same. There you go. So now let's look at data enrichment. So adding new columns. So we've already seen this one as well. We're going to be using df.withColumn, and you can also use with columns if you want to do more than one of these at a time. But we're just going to be showing you one column. Here what we're doing, we're taking the original data frame, we're calling withColumn to add a new column. We're giving the column a name, half revenue, and we're giving the function to apply to that new column. And in our example, we're just going to be halving the revenue. So df.revenue divided by 2. And then we're displaying the results in our enriched data frame here. So if we just call that, that's going to look like this. So we've got our new column, which is half revenue here, which is the revenue divided by 2. Finally, we're just going to look at joining and merging data frames in Spark. So for this one, we're going to be using some different tables. I've just pulled in the dealers data frame. So the dealers table, which is this one here, and also the countries data frame. And you'll notice that these do actually have a joining key. So they both have country ID. So each dealer has a country ID. What we want to be doing is pulling through the country name. Maybe we've got a normalized data model and we want to be denormalizing it. And we're going to be looking at what that means in a bit more detail a bit later in this tutorial. But for now, let's just look at joining and merging these two data sets together. So the basic syntax for a join in Spark is, well, we're going to get one data set here, which is the dealers data set. We're going to call dealersdf.join. That's going to be the first part of our join. We're going to pass in the second data frame that we want to join it to, in our case, countries.df. Then we're going to specify on what column we're going to be joining on. So we're going to be joining on dealersdf.countryid is equal to countries.df.countryid. In this next row, we're just going to specify some select statements. So what we've done is we've used this brackets here because we're going to be chaining more than one command together. And in this second row, we're just selecting a few different columns to be returned in this joined data frame. We just want to specify that we want returned the dealer ID, the country ID, and the country name. This is all we care about in that resultant data frame. So dealersdf is not defined. That's because we haven't defined it. Let's just read that data into a Spark data frame first, and then we can run this one here. Okay, so now we've got dealer ID, and country name in the same data frame. Now, one thing you notice here is that the country name has actually pulled through a few interesting characters. So that's something you might want to change later on in your data processing workflow. It might be that I've saved the CSV file in an incorrect format. Maybe that's something we want to clean as well in our data cleansing process. But for now, we're just going to leave it like this. So finally, we're going to be taking a look at data modeling. And typically this takes place within that gold layer, because these are going to be the analytical models and the data models that we're going to be bringing into our semantic layer. So let's start off with the star schema. So this is an example of a star schema. What you can see is in the middle, we've got a fact table. And this fact table represents sales, so it's revenue for a particular company. Here, the example is using car sales, so the amount of cars sold from different dealerships. So we've also got a dealership dimension table, a dim date, dim model, so the type of car that's sold, and the branch that was actually sold at. So it's obviously called a star schema because we have our fact table in the middle and then multiple dimensions all linking to that fact table via some sort of primary key. Now, the reason we prefer star schemas is if you want to be doing BI, Power BI basically, because the Power BI engine is most efficient in this star schema. So a pretty common piece of data modeling that you might have to do as an analytics engineer is prepare this data model in your goal layer of a data warehouse, for example, so that your Power BI developers can just pick up this data model and write their measures on top of it. Now, normally when we're modeling in this star schema data model, the fact table is going to be append only. So we're not really going to be updating many values in that fact table. It's just going to be new sales added onto the end of that fact table. Normally it's going to be a very long list, your fact table, and you're going to create connections from that fact table into the other dimensions. So if you want to know more information about that particular sale in the fact table, then you're going to find those in the dimensions. And the dimensions tables can change over time, right? Take, for example, dim branch. In that dimension table, you'd expect to see details about the different branches that exist for this car manufacturer. And some of those things can change over time. Some of the details about a particular branch might change, right? They might change address, they might change name. Certain details about each dimension might change over time. And one way of dealing with that in data modeling, well, we need to introduce this concept of slowly changing dimensions, because with our fact table, as we mentioned, we're not really updating anything over time, we're just appending new rows. But with our dimensions, we need to be able to handle different changes to that dimension table over time. And it's what we call slowly changing dimensions, because these are not going to be big updates. It might happen once a month or every week, a lot of slower frequency than the data is going to be added into that fact table. And in data modeling, there's a lot of different ways that we can model these slowly changing dimensions. Here's an example here. Take a different example. We're looking at employee table. We've got employee ID on the left-hand side, employee name, and the department. Now, it's not uncommon for an employee to change departments. So on the right-hand side, you can see that this dimension has actually changed. So Danny Walker, who's employee ID number 2, he has moved from the marketing department into the sales department. And we can model this in a number of different ways. Now, the first way in which you need to really be aware of for the exam is the type 1 SCD, or slowly changing dimension. So in the type 1 SCD, we're going to be overwriting any new data. So we're going to get the employee data, and every time we query that data set, that source data again, we're just going to overwrite whatever's in that table. We're not going to store any sort of history. So we're going to be implementing it with the overwrite writing mode. And you can do that either in the data pipeline, the data flow, or in PySpark as well. Now, if you're using a lakehouse as your data store, it's important to bear in mind that the history can still actually be retrieved at a point in time using the Delta log. So in a lakehouse architecture, in the Fabric lakehouse, because you can access those Delta logs, just because you overwrite it doesn't necessarily mean that that data isn't stored. So the second way that we can deal with this sort of change in a dimension is the type 2 slowly changing dimension. So in this example, we're going to need a few extra columns. You can notice that at the top there, we've added valid from and valid to, and optionally an is current as well, which is also quite useful for BI purposes as well. So you notice that when we first write a record into this table, we're going to populate the valid from. That's when this row is valid in that data set. And when you first write it, the valid to is going to be sometime long into the future. Normally it's the year 9999. And we also set the is current flag to 1 or true. Now, when we get an update to that data set, so we get a brand new set of data, well, in the type 2 SCD, we add new rows based on any incoming data. So you see in this type 2 SCD, we're going to be adding a third row, and it's going to be Danny Walker, but this time the department is sales. We have to do a few things here with the valid to and the valid from dates. So when you write that third row into the dataset, you need to update row 2 to populate that valid 2 column and set the isCurrent to 0 or false. The new row, when we write that third row into the dataset, obviously we're going to have department is sales. We're going to add the valid from date as the day that you're making the change, the update, with a valid 2 of the year 9,999 and an isCurrent of true. Now you can see that by doing this, we're actually storing a bit of a history about how our dimension is evolving over time. And so you can, on the back of this, create some quite sophisticated queries about what the state of that dimension table is at any given point in time. Now, when we're implementing the type 2 slowly changing dimension, there's a few things that you need to bear in mind. So if you're using the Lakehouse and Spark engine, then bear in mind that, as we mentioned previously, the delta log actually stores a history of all the writes to a particular table. So this might be a simpler option, and depending on how you want to use the history downstream in your analysis, that might be good enough for some use cases. Now, if not, then you can use the merge into. So we can use that as part of the Spark SQL library, and we can use that to basically update the underlying delta tables. Now, if you're using the data warehouse and the T-SQL experience, then one method is to load your new data into a staging table and then use a stored procedure to perform the checks around the updates and the inserts and the valid to and valid from calculations. Now, unfortunately, the merge operation in T-SQL, the T-SQL surface area, is not currently supported. So you have to actually implement this manually if you want to do that in the data warehouse currently. Now, one kind of implementation trick is to use row hashing here. So say, for example, you want to check which rows have changed from one update to the other. And one method that you can use to do this in a bit more of an efficient manner is to implement row hashing. So you can hash the value of an entire row, both in your existing data set and in the new data set that you're checking, and then you can compare the two hashes. And obviously, if the hash values match, then you know that that record hasn't changed. But if the two hash values are different, then you can go ahead with the update logic that you need to update that table. Next, we're going to talk about bridge tables. So imagine a company has many different projects running and the employees are assigned to one or many projects. What does this look like if you want to do a bit of a data model and maybe build a Power BI report off that? Well, in the question here, or in the scenario, we can see that actually many employees can work for many different projects at the same time. So that is a many-to-many relationship which exists between our DIM projects and our DIM employees table. And this can cause quite a lot of issues when it comes to Power BI and efficiency in very large data models as well. So one thing that we can do to resolve this is to implement a bridge table. And what that looks like is basically a one-to-one mapping of all projects and all participants. Now, this is really useful because it turns our many-to-many relationship into two one-to-many relationships. Let's have a look at how you can implement that in a T-SQL data warehouse, just to kind of show you what that looks like in real life. Okay, let's explore bridge tables in a bit more detail. And here we're in the data warehouse experience, and I've just built a gold data warehouse. And we've got these two tables here. We've got a projects table and an employees table. Now, it's just a simple demo just to show you what a bridge table might look like and how you can implement it in SQL. Our tables here are the projects, and we've got the project ID and the project name, and we've also got these project participant. And if we have a look at the data here for our projects table, we've got a bit of a messy string separated values in this project participants column. So we can see that each project has multiple project participants and some of them are overlapping, right? So these are employee numbers that come from this employees table. So employee 101, who is John Smith, he's actually working on multiple projects, right? So in our data model here, we've actually got a many-to-many relationship, and we can't really implement it at the moment because of that string concatenation in this project participants column. So how do we get around this? Well, and I have actually got the T-SQL here, and I'll leave this in the school community as well if you want to have a play around with this yourself. I've just created the projects table, I've created the employees table, and I've inserted some values here. So one way that we can use to resolve that many-to-many relationship is to create a bridge table between those two tables, between the projects and the employees table. And in this example, I'm implementing that as a SQL view. And what I'm doing is I'm using the cross-apply function here in T-SQL along with string split. So string split is basically going to look in that project participants column within dbo.projects. So that's the comma separated value column, which is a bit messy, but we can use cross-apply and string split together, and it's basically going to separate all of those values based on this separator here, the comma separation. And what this is going to do is it's going to create a one-to-one mapping for every single project and every single project participant. So if we just run this here, let's just have a look at what that looks like here. So you can see, if we look at the original table, just to remind ourselves of what that projects table looks like. So initially it looked like this. It had 2 rows, and it had project 1 with 2 participants and project 2 with 3 participants. And what we've done in this view, if we just recalculate that, it's basically separated out all of these comma separated values, and it's made 1 row for each one. So now we have 5 rows because these are all the different combinations of projects and employees. And what we can do is we can create a view with this logic like so. I've just called it DBO view bridge project participants, and that's going to make that available in our data model now. So let's just have a look at this. So now we've got this view bridge table in our data model. And what we can do is we can now connect the project ID to the project ID. In this instance, it's actually going to be one to many because this is a dimension table. This is our bridge table. So it's going to be one to many. And we can do the same on this side here. So this time it is going to be many to one. So what we've done is we've transformed a many to many relationship into 2 one-to-many relationships. And this is going to make it a lot easier when you implement this stuff in Power BI. And that's one way that you can resolve a many-to-many relationships using a bridge table. Now, we've implemented this in a SQL view just because it's quite easy. In reality, if you wanted to use direct lake mode, obviously you can't use a view with direct lake mode. So if you want to use direct lake mode, then you might want to use a stored procedure to materialize out the data in this bridge table so that it doesn't fall back to direct query mode. But that's bridge tables in T-SQL. So the next thing we want to talk about here is normalized and denormalized data. So if we go back to our data model here where we were looking at car sales, so we have some sort of fact revenue in the middle and some dimensions that give us more information about that particular sale. So what branch it was at, what model of car was sold, the date that it was sold, and also the dealership. And what we've done is we've added in another dimension here onto that DIM dealers. So there's a relationship between the DIM dealer and the DIM cities. So it's basically telling us the city of that dealership. Now, this is what's called a snowflake architecture. Now, this can be a very efficient way of storing really large data models, because you notice in the DIM dealers table, we're only storing the city ID. We're not bringing through any other data into that DIM dealers. Now, this can be beneficial in some instances, for example, as we mentioned, for efficiency. But when we move this kind of model into the Power BI world, it can bring some limitations as well. So one way to get around this is with the denormalized data model. And this is what this looks like here. And it's effectively turning our snowflake model back into our star schema model, which we know can be a lot more efficient when we've got very large data sets. Now, this does introduce some redundancy into that DIM dealers dimension, because instead of just storing the city ID for every dealership, we're going to be repeating the city ID and the country ID and the region for all of the rows in our DIM dealerships. But by denormalizing our data model, we actually get a number of other benefits. So now we have everything in that DIM dealers table, which makes it a lot easier to build things like filters on top of that dimension table. We can also have hierarchical filters. So we can look at the dealerships by city, country, and region and build a bit of a hierarchy there, which isn't possible when you've got that split across 2 dimension tables. Finally, we're going to take a look at data aggregation. And the word aggregation can mean a few different things in data analysis and data modeling. And I'm not 100% sure what Microsoft expect for the data aggregation and deaggregation that they've mentioned in the study guide. But I'm going to talk through both examples so that you know both of them. And if you have any insight as to what Microsoft mean from the study guide when they talk about aggregation, then let us know in the comments. So the first possible meaning when we talk about data aggregation is when we have different slices of the same data set, but they're spread across different files. So this one we have one file with the UK data, one file with the USA data, and one file with the Canadian data. And in this context, data aggregation can mean basically combining these datasets into one long table of transactions, in this case showing you revenue, across all your different source datasets, right? And we can implement this in a number of different ways, really. In Fabric, in the data flow, we can use the append functionality, and in the T-SQL experience and also Spark SQL, we can use union and union all, and union is also a method in PySpark as well. Now the difference here between union and union all, with a union, it's actually going to remove any duplicate rows in the resultant data set, whereas union all is just going to basically append all of the different data sets on top of each other, and it's not going to check for duplicates. So also mentioned in the study guide is data deaggregation. And again, there can be many different meanings to the word deaggregation. So assuming we mean the first meaning of aggregation, then deaggregation is going to be the opposite, right? It's going to be splitting one large file into multiple different categories of data. So another possible definition of data aggregation is when we transform a data set from a more granular data set into a less granular data set. So on the left-hand side, for example, we have all of our transactions and the revenue for that transaction and the different country that that transaction was made in. Now, if we were to aggregate that data, perhaps by country, then we get some sort of aggregation metric for each country. So here we're showing the total revenue for each country. So the UK here has 600, which is 100 plus 500. The US has 200. And Canada is 800. Now, this is typically implemented using the group by statement and the group by functionality. And this can be done in the Dataflow, T-SQL, or in Spark. And when we build this kind of aggregate transformation, we also need an aggregation function. And it's normally one of count, sum, max, min, average. So it's how are you combining all of the values within that group by statement. So in our example in the top right-hand corner, we used a sum. So we just summed up all of the different revenue numbers for each country, but you could do average revenue, you could do the max revenue, it depends on your use case here. Okay, let's just round up everything that we've gone through in this lesson and test some of your knowledge. Question 1. When using df.join in PySpark Notebook, the default join type is A, full outer join, B, inner join, C, left join, D, right join, or E, anti-join. Pause the video here, take a moment to think about the answer, and I'll reveal the answer to you shortly. So the default join type in a PySpark or in any Spark notebook is the inner join. Not much to say about that one, that's just something you need to know. All the others are incorrect. Question 2, you're looking to migrate a data transformation workload that is currently done using a Dataflow Gen 2 and convert it into a T-SQL script. Now the data flow appends two datasets together and removes any duplicate rows. Which T-SQL command can you use to implement this transformation? A left join, B, union all, C, concat, D, append, or E, union. So the answer here is the union. Now we mentioned when we were talking about unions that the union removes duplicates, and in our question here, obviously the important sentence to pick out was that the source data flow, the thing that we're trying to convert into a T-SQL script, well, currently that appends two data sets together and removes any duplicate rows. So the T-SQL equivalent of that is the union. It's not going to be the union all, because that's not going to remove the duplicate rows. It's not going to be the left join, because that won't do what we want to do. Now, append is not a T-SQL function. Concat is how you could achieve this in Pandas, but not in T-SQL. So the answer here is union. Question 3. You have a Spark data frame called df. Your goal is to remove rows that contain a null value in the transaction date column. Which of the following will help you achieve this? A, df.drop duplicates. B, df.dropNA with how equal to all. df.filter for transaction date.is null. D, df.dropNA how equals any, or E, df.dropNA with subset equal to transaction date. So the correct answer here is E. We want to be using the drop NA and passing in subset equal to transaction date. Now the question here is asking us to remove rows that contain null values in a specific column. So that specific column is the important part of the question. So we want to be using drop NA because it's going to remove the rows. And by passing in subset equals transaction date, that's going to specify only to look in the transaction date column. So maybe that's a really important column in our data set. We want to be absolutely sure there's no NA values, because if there's any NA values, then maybe that's going to make our analysis completely redundant, or it's going to ruin all of our downstream analysis. So you might want to remove those rows entirely. It's not going to be B, because in B and D, we're not actually specifying that subset. Now, if you were to implement D, then it would drop the rows where there is a null value in the transaction date column, but it would also remove rows with null values in any other column. So that might be too much based on your requirements. That's probably not what you want to be doing. Filter, that's going to just filter the data set for null values, because that's going to return all of the rows which are null. So we want to be doing the opposite of that, basically. And A, drop duplicates, well, that's not what we're trying to achieve here. So that's not going to be the answer. Question 4. A classical star schema data model consists of the following. Is it A, one central fact table and multiple dimension tables? B, one dimension table and one or more fact tables? C, one fact table, multiple dimension tables, some with dimension to dimension relationships? Or D, one big fact table, fully denormalized without any dimension tables? So the answer here is one central fact table with multiple dimension tables. So B is obviously the wrong answer here because it's got one dimension table and many fact tables. That's not going to be the star schema. C is a snowflake, one fact table with multiple dimension tables, some with dimension to dimension relationships. So that's not going to be what we're looking for in a star schema. And one big fact table, fully denormalized without any dimension tables. Again, that's not really a classical star schema. So the answer here is A. You inherit a data project and you're inspecting the tables in the data warehouse. One of the tables is a dimension table, dim contacts, with the following columns: contact ID, contact name, contact address, effective date, and effective until. Make an assumption about the type of data modeling that is being implemented in this dimension table. Is it a type 0 SCD, slightly change dimension, a type 1 SCD, a type 2 SCD, or a type 3 SCD? So here the answer is type 2 SCD. So we can see from inspecting the columns here that they've got two date fields, or we can at least assume they're dates. So effective date is probably when that row, when that contact data point was entered into the system, and effective until is basically the same as that valid to. Now, we can't actually see the data here, but we can assume that that's what those two columns are doing. A type 0 SCD is a fixed dimension, so something that never changes. Type 1 is obviously you're not going to be tracking that effective date and effective until, those two dates. It's just going to be overwritten in a type 1. And a type 3 is another slowly changing dimension type that is not actually asked about in the exam, but it's basically going to store previous values for each of your columns, or at least the columns that you're interested in storing. So say, for example, you'd have contact name there. You might also have previous contact name. And then when your data gets updated, you're going to update the previous contact name and the new contact name as well. So that's a type 3 SCD. Don't think that's in the exam, but just something to bear in mind. So the answer here is C, a type 2 slowly changing dimension. Congratulations, you've now completed the third part of section 2, preparing and serving data. In the next lesson, we're going to be looking at performance monitoring and optimization of all of our data processing workloads in Fabric. So make sure you click here to join us in the next lesson. I'll see you there. Hey everyone, welcome back to the channel. Today we're continuing our DP-600 exam preparation course, and we're up to video 8. We're making very good progress here on the course plan. Today we're going to be looking at optimizing performance, and specifically we're going to be covering these bullet points in the DP-600 study guide. So we're going to be looking at mainly identifying and resolving performance issues, right? So when you're loading data, or when you're querying data or transforming data. And specifically, we're going to be looking within the Dataflow, the notebook, so the Spark engine, and also SQL queries as well. Then we're going to look at delta tables in a bit more detail, how we can identify and resolve issues within our delta tables. As you know, Fabric is built on top of the delta file formats. That's a really important topic to understand. And as part of that, we're going to be looking at file partitioning as well. So what that is, what that looks like, why you might want to implement file partitioning in your lakehouse. So as ever, at the end of the video, we'll be testing some of your knowledge from the topics that we cover in this lesson. And as ever, I've got some quite detailed notes that you can use to enhance your revision available in our school community. And I'll leave a link to that in the description box below. So most of this video, I'm going to be diving into Fabric and going through performance optimization in a number of different places in Fabric. But I just wanted to start by framing what we mean really by performance optimization in Fabric. Now, as you know, Fabric is a very diverse tool. So when we talk about performance, really we need to get a bit more specific about, well, what are we talking about? It could be data flow performance, could be a SQL script in your data warehouse, or we could talk about the Delta files and optimizing how they get written and read in our OneLake, in our lakehouses as well. And I would make the distinction here between identifying performance issues and then resolving them. It's kind of like a two-step process. First, we need to know how to identify performance issues in each of these tools. And then we need to think about how we can possibly resolve these issues after we identify them. And you'll notice for each of the Fabric items, how we identify performance issues is going to be a little bit different, right? So for the data flow, we're going to be looking at the refresh history and the monitoring hub and the capacity metrics app. And you notice that some of these actually repeat. So the monitoring hub and the capacity metrics app is kind of like a generic place where you can do lots of performance monitoring across Fabric. In the data warehouse, we have query insights and DMVs, dynamic management views. With the Spark engine, we have the Spark history server, and we also have access to quite detailed monitoring in the monitoring hub as well. And when we're identifying performance issues in Delta files, there's a number of places you can do that. One of them that we're going to be looking at is describe. Then when it comes to resolving some of these issues, well, that's where it gets a bit more difficult to define, right? Because it's normally going to involve some element of refactoring. So using different operations in your data flow, for example, or refactoring your SQL code or refactoring your Spark jobs as well. Now in the data flow, we have some specific performance optimization features that is worth going through. So we'll be talking a little bit about staging and fast copy as well. Then when it comes to Delta file optimization, we're going to go into a bit more detail about V-order optimization, file partitioning, and also the vacuum and optimize, which are two Delta table functions that we can implement to improve performance with Delta files. So that's a bit of an overview of what we're going to be discussing in this lesson. Now let's dive into Fabric, and we're going to begin by looking at some of the generic tools like the monitoring hub and the capacity metrics app before diving into the data flow, data warehouse, and the Spark notebook in more detail. So let's begin. Okay, so just before we jump into Fabric for this tutorial, I'm just going to start in the school community here and talk through some of the notes that we have for optimizing performance. So here is video 8, optimizing performance. We've got this framing performance optimization chart that we spoke about previously. But to get us started, I want to speak generally about performance monitoring. There's a few tools that are quite general. They apply across different workloads that are useful to know for the exam and also in Fabric generally. So we're going to be talking about the monitoring hub and the capacity metrics app. And these are two tools that can be used to monitor performance for a wide variety of operations in Fabric. So the monitoring hub is the first one. So let's start by looking at the monitoring hub. And if I just flick over to Power BI here, obviously to access the monitoring hub, you've probably seen it here. It's in the left-hand toolbar here. You've got this big button for monitoring hub. And within here, we can basically have a look at the runs of a lot of different item types, right? So you can see semantic model refreshes, notebooks. So this is going to be a Spark session. And for each item type, we have different logging that gets exposed in this monitoring hub. Now the notebook we're going to have a look at in a bit more detail because that's exposing Spark log information. You can also see like data flow Gen 2, you can have a look at whether those runs have succeeded or not. Table loading information in a lakehouse, for example. And we can obviously click through into specific items that we care about and we get more information, right? So this is showing a table load into the bronze lakehouse and it's showing you the different jobs because this is a lakehouse, these Spark jobs, right? So it's also going to tell us in the monitoring hub whether runs have been successful or failed. So this particular data flow run, we can see that it actually failed, right? So on the 1st of May at 12:46, I tried to refresh this data flow and actually failed. So you can click on view detail and you can get a few more details about what happened here. You can't really diagnose what went wrong with that particular data flow. To actually get the details of the data flow, you have to actually go into the data flow itself, which is this one here, And then we can click on these three dots here, click on the refresh history. So for Dataflows, if you want to actually debug what went wrong, this is obviously pretty poor data flow this, but you can click on the individual runs and get more detailed information about what's going wrong here. So here we can see, oh, well, it's actually this activity here that's failed. We can click on that and then get more information about why specifically that column or that data set can't be refreshed. So the next general tool that we can use to monitor performance and resource consumption within our Fabric capacities is the Capacity Metrics app. And the Capacity Metrics app, and I'll leave a link, you can obviously get the install instructions here if you have never installed this before. This is a Power BI app that you install within your Fabric environment. You give it your capacity ID, and again, the capacity settings is where you'll find that capacity ID. And then it's going to bring you through to this kind of Capacity Metrics app. Now, the Capacity Metrics app is split into two sections. We have compute and storage, and this obviously lines up with how Fabric is built, right? You're built partly on storage, so the amount of storage you have in Fabric, plus the resources that you consume during compute. So if you've already installed the Capacity Metrics app, you can find it in the Power BI experience, go to apps, and then you should see it there, the Microsoft Fabric Capacity Metrics app. Now, as I mentioned, there's two tabs to this report. It's compute and storage. On the compute page, so starting at the top left, we can see the capacity unit spend for particular item types in Fabric. And we can also break it down by duration, different operations, and by user as well. We also get this time series of capacity usage over time as a percentage of the total capacity that you have available based on your SKU. So currently I'm on this trial capacity. So this is going to be an F64. And as you can see, I'm not really using barely any of this capacity. We've also got these other interesting graphs around throttling. So if you're using more than 100% of your capacity usage on that particular capacity, this is going to show you where you're throttling. And it's also going to show you rejections. So if you've got workloads that are being rejected on your capacity because you're, again, over 100% and it's currently rejecting workloads, then that's going to be exposed here. We've also got a graph on overages. So again, if your capacity is throttled, an overage is basically you repaying that capacity usage from your future spend, right? And for each of these, obviously I haven't actually been throttled or there's no overage on my actual capacity, but there is this explore button that you can drill through to specific events that you want to explore in more detail, if that is something that's happening on your capacity. Down below, you've got a table of all of the different items in your Fabric capacity and the capacity unit seconds that are being used by that specific resource. So this is a Synapse notebook, and we can see that that is the most resource intensive. It's used up the most of our capacity unit seconds. And it's also got this tooltip where you can look at specific activities and runs of that notebook to dig into a bit more detail there. On the storage tab, obviously this focuses on the amount of gigabytes of storage in this Fabric capacity. We can see how it's changing over time. We can look at the specific storage by date. And we can also look at the top 10 workspaces by billable storage. Once that's loaded, that's what that brings you there. Here we go. Okay, so next I just wanted to talk about data flows. And just to summarize what we looked at previously, well, if we want to monitor the performance of a data flow, well, at a high level, we can do that within the monitoring hub. But if you want a bit of a lower level data and to understand what's happening within a particular data flow, you're going to be wanting to look at the refresh history as I showed you previously for a particular data flow. Here you can inspect the error messages, you get a breakdown of the different sub-activities in that load for a data flow. So that's going to be really important for you to diagnose what's going wrong in a particular data flow. If it's not refreshing correctly, that's where you're going to go to have a look there. Now there's a couple of features that you need to be aware about in terms of optimizing the performance, specifically when we're talking about data flows, right? So the main one is staging. Now, staging is probably best described using this diagram here. So this diagram actually comes from this link here. It's the Spotlight blog on data flows, and it's got some top tips for improving the performance in your data flows. So I think to understand what's going on with staging, this diagram gives you a pretty good idea. So let's start by talking about when staging is disabled. So this bottom diagram here. Right? So if staging is disabled, all of your transformation in a data flow is going to be done by the data flow engine. It's otherwise known as the mashup engine. right? And if you've got a really big data set or you're doing lots of transformation, that might not be the most efficient way of doing it. So a feature we have available to us to try and improve the speed of doing all these transformations within a data flow is staging. So at the top here, when staging is enabled, what it's going to do is it's going to read in the data from the data source, and then it's going to immediately write that data into a lakehouse staging table. Then it's going to use that lakehouse to perform the transformation, right? So leveraging the Spark engine rather than the mashup engine to do your transformation. Then it's going to read the data back into the mashup engine and write it into the destination, wherever that might be. So a few things to bear in mind here. If you've got a lot of data transformations or you've got very large amounts of data, staging is probably going to be a lot more efficient. Now, if you've got small data sets, it's probably going to be less efficient, right? Because you're going to have to write the data into a lakehouse, transform it into the lakehouse, and then write it. Then the mashup engine picks it up again and writes it to your output destination. So there's lots of kind of reading and writing here. So on small data sets, you probably want to disable staging or not enable staging. It's only really when the data set becomes large or you're doing lots of transformation on that data set, then we want to enable staging. That's what I've kind of summarized with this sentence here. There's a bit of an overhead when you're performing staging, and so it doesn't work in all cases, only really when your data set is large or you're doing lots of transformations, or both. Now, another feature that they recently announced, and therefore might not actually be in the exam yet, but it's good to kind of understand and know that it exists, is fast copy. And the way that I think fast copy works is that under the hood, it uses the same technology as the data pipeline copy data activity, rather than the data flow technology, basically. As I mentioned, it's still a preview feature and it's relatively recent, so it might not actually be in the exam yet. But if you're using data flows in the real world and you're struggling with performance, it's worthwhile enabling fast copy. Just to give it a go, see how it impacts the performance in your data flows. Okay, so next up, we're going to move on from data flows, and now we're going to focus on SQL. So we have the SQL engine within the data warehouse and also the SQL endpoint of the lakehouse as well. And we're going to have a look at how we can diagnose and then optimize the performance of SQL scripts. And as I mentioned before, the Capacity Metrics app can give you a good kind of high-level overview of the resource consumption of specific operations that you're doing within your data warehouse. But we have a lot more functionality within the data warehouse to actually explore and identify things like long-running queries, frequently used queries. Next, we're going to talk about dynamic management views, or DMVs. And if you take a look in the data warehouse under the sys schema, there's obviously a lot of different views in there that we can use for database management in general. And there's three main ones really for understanding the live SQL query lifecycle. Okay, so things that are currently going on in your data warehouse that you need to be aware of and getting some insights about what's happening there. And these are exec connections, exec sessions, and exec requests. And these are related in this way here. So we've got a bit of a data model here. So whenever you start a query execution in the data warehouse, it's going to start up a session. The session is going to have a one-to-one relationship normally with the connections, right? So it's going to create a connection between your data warehouse and the underlying SQL engine. So that's what a connection is going to show you. And then you're going to have many requests normally for each of these connections, right? So using these three commands, these three DMVs, we can begin to build a bit of a picture about who and how your data warehouse is being queried. And these DMVs are going to help you answer questions like, who is the user running the current session? When was the session started by the user? What's the ID of the connection to the data warehouse that is running a particular request? How many queries are actually currently active? And which queries are long running? So you begin to build a bit of a picture about how your data warehouse is being queried, who's querying it, what they're doing, and the performance of those queries. Now the DMV is quite a low level view, right? We can do lots of information here. We can merge these tables in different ways to get more and more information. So alongside the DMVs, Microsoft also expose query insights. So query insights is in a different schema. So if we have a look here at this particular example of a data warehouse, we've got the sys, which is our DMVs, where it contains our DMVs, as well as other database management system generated views. We've also got query insights. So in here, we've got these 4 views that give us basically more user-friendly abstractions over the DMVs, right? So it's going to expose things like frequently run queries, long running queries, and you don't have to actually perform those joins of the underlying DMVs to get this information. It just exposes them right here. And so we're just going to focus on 3 of these query insights views. So exec requests history is going to return information about each completed SQL request on that particular data warehouse. Frequently run queries is obviously going to give you information about the most frequently run queries, and long running queries is basically going to return you information about queries by execution time. So this long running queries is going to be really useful to, as the name suggests, identify queries that are running for a long time, and it might be causing performance issues in your data warehouse. Now, one thing to note here is that if you're coming from a SQL Server background, when we're talking about performance optimization, a really important tool there is the query plan, right? So currently, I don't think it's possible to expose the query plan for a particular SQL query, but I do think they are planning to support that in the future. Next up, I want to talk about identifying performance issues with the Spark engine. And you'll notice that we're back in the monitoring hub. And I just want to look at one of the item details here for this specific notebook. So I've been running this notebook, it's called Delta Optimization. And when we click through on this item, we get a really detailed analysis of the different jobs that have been run in this notebook. And we can see that all of these have succeeded. You can see the duration of a particular job, the data that's been read and written for that particular job. So this is a really good place to go if you want to understand what's actually happening when you click run in a Spark notebook, what's happening under the hood, and the success or failure of each of the individual Spark jobs. Now within the monitoring hub, we've also got this link through to the Spark history server. And as you can see from the UI here, we've actually switched from a Fabric tool to a generic Spark tool, right? So here you're going to get a lot more detailed information about specific Spark jobs that you're running. You can look at graph. So if you do want a bit of a query plan, look at the different stages in execution of a particular Spark job. You can have a look at that here. So if you're looking for really fine-grained control and analysis of what's going on your Spark engine, you're going to come to the Spark history server. Now, to actually interpret and understand what's going on here would be a whole series in itself. And I don't think you need to know the nitty-gritty details of actually what's going on in the Spark history server for the DP-600 exam. Just understand, what's possible in the Spark history server. What does it log? What can you monitor there? I think that's good enough for the DP-600 exam. So finally in this tutorial, I just want to focus on delta table optimization. Now, as you probably know, Fabric is built on top of delta tables. So this is a really important topic to understand. And the delta file format is great, but it can lead to poor performance and bloated storage sizes if we're not managing those delta files correctly. Now, this is a topic that can run very deep, like a lot of the topics that I mentioned today. We're just going to go through some of the basics of what you need to know for the exam. And to do that, we're going to be going through a Spark notebook. So this is the Spark notebook that we're going to talk through. Now I'm going to start by just exploring the problem in a little bit of detail. And I think a really good way of understanding what the problem or a problem that can arise with Delta files is this visual here. And this visual comes from this blog post here by Sally Dubber, and it's around efficient data partitioning with Microsoft Fabric, best practices and implementation guide. And I've left a link to that in this notebook. The notebook is obviously available in the community here as well. And I've also left a link to it here, efficient data partitioning here as well. So if you have one big file that's 10 gigabytes, one Parquet file, then the Spark engine is going to struggle to process that, right? Because as you know, Spark is a distributed processing engine, which means it works best when it splits your file, your Parquet files, into smaller chunks and then processes these chunks in parallel. But to make that possible, we need to partition our data. And partitioning is basically the process of converting one really big or several really big files into more manageable chunks so that our data can be transformed in parallel, basically, by the Spark engine. So in this notebook, we're going to start by looking at file partitioning and then look at some other methods for optimizing delta tables. In doing so, this can help improve the read and retrieval performance. So by doing so, there's no need to scan through millions and millions of rows in your really big Parquet file. If you've got a good partitioning system in place, it's going to speed up the read performance of your queries. And it's also going to improve your transformation performance, right? As we mentioned before, because partitions can be transformed in parallel. So file partitioning. I'm going to walk through a bit of a demo here, and I've used a demo file and it's available on this website here, but it's just a Parquet file. What I've done is I've just put it in the files location. It's this one here. It's called flights1m Parquet. And before we get started, it's just bearing in mind the best practices on Delta Lake partitioning, right? And I've left a link here. This is on the Delta Lake website where they give some general best practices about managing Delta files, okay? And one of them is around choosing the right partition column. Now, most commonly it's done by date. So if you've got time series data, you've got some dates in your data set, then it's common to use your date for partitioning. But there's two kind of rules of thumb to bear in mind when we're talking about partitioning and deciding what columns you want to partition on. So in general, we don't want to choose our partitioning column to be something of really high cardinality. So say, for example, you have a column of user ID. Well, that's going to be really high cardinality, right? Every row is basically going to be unique. So if you've got 1 million rows, that's going to be a really bad partitioning strategy, right? Because you're going to get 1 million different partitions and they're all going to be really small. And as a general rule of thumb, the amount of data that should be in each partition should be around 1 gigabyte. That's kind of like the good balance of what you should be aiming for with each partition. So let's take a look at file partitioning and how to actually implement it in Fabric in a Spark notebook. So I'm going to begin by just reading in that Parquet file, our flights1m Parquet file. I'm just reading it into a data frame. I'm just displaying it here. And you notice we've got this date column here that's going to be useful for our partitioning strategy. We're going to be partitioning on date, and it's got some other items here that we don't really care about for this tutorial. So before we do some partitioning and we write this file into our lakehouse using partitions, we're going to do a bit of preparation. And specifically, we're going to add some columns into our data frame. We're going to use df with columns to add more than one column at a time. And we're going to pass in this dictionary object here. And each part of that dictionary, each key is going to be the new column name. And the value is going to be how we're actually computing that value. So here, I'm just reading in some PySpark SQL functions to extract the year, the month, and the day of month of that date field, right, that we looked at previously. So if we just run that, and if we just display the results here. Okay, so now we've got this transformed data frame object, right? And so you can see here that it's added in this year, month, and day column. And we can use these in our partitioning strategy now. So you can see here from our code cell that we've actually written 3 different write modes here. So the first one is going to write without partitions. So this is just the normal saving of the table into a lakehouse table from our Parquet file. We're going to put it in tables and we're going to call the table flights not partitioned. The second one we're going to do is we're going to call .partition by, and we're going to partition by the year and the month. And we're going to save this one into another table called flights partitioned. And then as a third example, we're going to write with some more partitions. So we're going to be partitioning our data into smaller partitions here. And again, we're calling partition by, but this time we're passing in the year, the month, and the day. So these are going to be more fine-grained. I'm going to save that into a table called flights partitioned daily. Let's just run those. Okay, so now our cell has been executed. All of our Spark jobs have concluded. Let's just have a look at this. So yeah, now you can see in our lakehouse tables, we've got flights not partitioned, flights partitioned, and flights partitioned daily. So we've got 3 different tables here, all with different partitioning strategies. So let's inspect those and see what's going on. Okay, so I've got 3 different cells here, and you'll notice we're using the SQL. So we're using Spark SQL here, and we're calling describe detail on that particular table. It's going to inspect this table. It's going to describe what's going on there. And some of the results give us a bit of a picture as to how this table has been written into OneLake. So if we inspect the results here, and this is our flights partitioned, we can see that the partition columns here are year and month, which makes sense because this is the year and month one in flights partitioned. And we can see the number of files it's created. So the number of Parquet files we've got here is 2. Next, if we compare that to what we get when we look at flights not partitioned, we can see that we've got 0 partition columns and we've got 1 file. So everything's just been written into 1 file in that instance here. And for the daily one, again, if we inspect what's going on here, we can see that we've got year, month, and day partition columns. And here we've got 59 files. So here it's been partitioned. We've broken up that data into 59 smaller chunks of data. Now that might be too fine-grained, because if we scroll back up to the top here, one thing that I did mention is that it's a bit of a balancing act, this. Because if your files are too big, the Spark engine's going to have performance issues. But there's also the small file problem. If your file sizes are under that gigabyte, then that's also going to cause a lot of issues because it's going to have to work harder. You're going to have to go through the operation 59 times rather than 2. So again, it's a bit of a balancing act trying to get a good partitioning strategy for your delta tables. But for the purposes of the exam, I think it's worthwhile understanding the syntax for creating partitions like so, and then analyzing different partitions using this describe method, Spark SQL method. Okay, so next I just want to talk about V-order optimization. Now, V-ordering is a Microsoft proprietary algorithm, and it basically changes the structure of your Parquet file. And what I've put here is kind of providing a bit of special sauce. So it does some special sorting, compaction, compression of that Parquet files, right? Ultimately to improve the read performance of these Parquet files across all of the different engines in Fabric. Now, whilst the actual algorithm is proprietary, it's only used by Microsoft, the output of like the Parquet file is fully kind of open source. It aligns to the traditional Parquet standards, so you can actually read V-ordered Parquet files wherever you can read normal Parquet files. That's not a problem at all. Now, by default, V-ordering, so this algorithm that you use to write Parquet files, is enabled by default in the Fabric Spark runtime. And you can check that by running this spark conf get. So we're looking at the configuration and you can see that here is actually returning true. Now it can actually be manually disabled if you want it to. So we can set the Spark configuration by passing in this specific property here, Spark SQL Parquet V-order enabled to false. And then we can re-enable it by doing the opposite, right? Putting it to true again. So for the exam, you might be asked about how do you know whether a particular notebook or a particular Spark environment has V-order enabled? Well, that's this one. Well, how do you enable it or disable it in a Spark notebook as well? That could be a common question that you might get asked. Okay, just finally, I just wanted to mention a few more delta table maintenance and optimization techniques. So there's a few that come from the actual delta format itself. So we have this function called optimize, which is a delta lake method that performs bin compaction. It can basically improve the speed of your read queries. So if you've got multiple small files, it's basically going to coalesce, basically mean joining small files into larger files. Vacuum is another function that we can run, and it basically involves removing files that are no longer referenced by a delta table. And then on the Spark side, there's two that you might at least want to be familiar with is coalesce. So as we mentioned, when we're talking about optimize is basically what that's doing under the hood is calling coalesce. And coalesce is a Spark method for basically reducing the amount of partitions in your delta table. So if you've got 100 partitions for a particular file, you can coalesce that delta table into 10 partitions. So coalesce is a pretty efficient way of grouping partitions into a smaller number of partitions, right? And I say it's quite efficient because it doesn't require a shuffle of the data. It's just grouping partitions together. It doesn't actually reorganize within particular partitions your data. Now, repartition is similar to coalesce, but it's actually less efficient because it involves breaking up your existing partitions and then creating new partitions. And because of this, you can create either more or less partitions. So it's basically just restructuring how your partitions are created. And it does involve some shuffling, it involves breaking up of your existing partitions and repartitioning them. Now you might be thinking, what's the difference between the Spark functions and the delta optimize? Well, the delta optimize has a few kind of things working under the hood that makes it more efficient. For number one, it's idempotent. So if you run it repeatedly, it's not going to re-optimize files that have already been optimized, whereas repartition is going to always repartition your files. Like you can keep on running this again and again, and it's never going to get more efficient. It's always going to repartition the files. So that's one difference between repartition and optimize. And you can also run optimize on specific partitions in your data set, whereas repartition, that's kind of all or nothing approach. You have to repartition your whole table in one go. So if you're looking for a bit more fine-grained optimization, you're going to be wanting using the delta optimize. Okay, so let's just round off the video here by testing some of your knowledge of the things and the topics that we've covered in this lesson. Question 1. A client you're working with wants to reduce the SKU of their Fabric capacity from an F16 to an F8 to save some money. They want to find the most resource-intensive workloads and optimize them to use less capacity uniseconds. Where should they look to find this information? Is it A, the monitoring hub, B, capacity metrics app, C, query insights, D, Spark history server, or E, the OneLake hub? Pause the video here, have a little think, and I'll reveal the answer to you shortly. Okay, so the answer here is B, the capacity metrics app. We're talking about resource intensive workloads, and our capacity is where we're going to get those resources. And specifically, it's going to tell you which workloads are the most resource intensive, i.e. the workloads that are going to use more of your capacity units seconds, right? So the answer is going to be your capacity metrics app. We can look at all of our Spark jobs, our data warehouse operations, and our data flows, and we can come to conclusions about which of these are good candidates for refactoring or optimization. Now, all of the others, they might be useful for understanding performance of specific workloads within Fabric, but the capacity metrics app is the only one here that converts that into capacity units, right? And that's the important part of the question to understand. Question 2. You notice one of your Dataflow Gen 2 runs failed to refresh last night. Where would you go to find out why a particular data flow might have failed a particular run? Is it A, the capacity metrics app, B, the monitoring hub, C, Power Query error hub, D, Dataflow refresh history, or E, the data pipeline run history? So the answer here is D. The Dataflow refresh history is where you're going to go to analyze error messages and debug particular runs of a data flow. Now, the Power Query error hub, that doesn't actually exist. I made that up. The data pipeline run history, well, we're not talking about a data pipeline here, so it's not going to be that. The monitoring hub will give you some information. So it will tell you whether a particular run has failed or succeeded, but it doesn't give you more detailed information about error messages and things like that. And the capacity metrics app is not going to tell you that answer either. So the answer here is D, Dataflow refresh history. Question 3. When talking about delta table optimization, which of the following operation removes old files no longer referenced by a delta table log? Is it A, V order optimization, B, Z ordering, C, vacuum, D, optimize, or E, bin compaction? So the correct answer here is C, vacuum. So as we mentioned previously, the vacuum command does exactly as it's mentioned there. It basically removes old files that no longer referenced by a delta table log. So the correct answer here is C. Question 4. Which of the following statements about V-order optimization is false? A, V-order optimization is enabled by default in the Fabric Spark runtime. B, V-order can be enabled during table creation using table properties. C, a table can be both V-ordered and Z-ordered. D, V-order improves the read performance for Parquet files. E, V-order speeds up the write time of a Parquet file. So the correct answer here is E. So the question asked which of the following statements is false. And so E is actually false. V-order does not speed up the write time. It actually increases the write time of a Parquet file. The benefit of V-ordering comes in the read performance, right? That's why we do it. It takes a bit longer to write these files, but it massively improves the read performance across any of the engines that you might want to use it in Fabric. All of the other options are true. So it is enabled by default. B, if it's not already enabled in your Spark environment, it can be enabled for specific tables during table creation using table properties. You can actually optimize both V-ordering and Z-ordering for a particular table or Parquet file within that table at the same time. And D is also true because we mentioned that V-ordering does improve the read performance for Parquet files. That's why we do it. Question 5. You want to analyze long-running queries in a Fabric data warehouse. What's the minimum workspace role you need to run the following query? Select start from queryinsights.longrunning queries. Is it A, admin, B, member, C, contributor, or D, viewer? So the answer here is C, contributor. To be able to run a query insights query, those auto-generated views that give us information about long-running queries in this example, you need to have a workspace role of contributor. Obviously, the question asks for the minimum workspace role. You can also run these queries with admin or member, but the minimum workspace role would be contributor. So if you have a viewer role, you can't run these queries in a data warehouse. Congratulations, you've completed the biggest section of the exam. We're well over halfway now. So in the next lesson, we're going to be starting the third section of the exam, which is all about building semantic models. Well done, and I'll see you in the next video. Hello and welcome back to the channel. Today we're continuing our DP-600 exam preparation course, and we're up to video 9, designing and building semantic models. Now, as you can see from the course plan, we're making really good progress. We've just got a few more important sections to look at. And today we're going to be starting Power BI and semantic modeling part of the exam. Specifically, we're going to be looking at the different storage modes import mode, direct query, direct lake. We're also going to be looking at composite models and what we mean by that, including aggregations as well. We're going to be looking at the large format data set, and then we're going to be digging into a bit of a practical example in Power BI desktop, defining different DAX measures. We're going to be looking at functions, iterators, table filtering, windowing, information functions, and some of the other more advanced or more recent features as well, including calculation groups, dynamic strings, field parameters, that kind of thing as well. As ever, we're going to have 5 sample questions at the end of this video to test your knowledge. Now, bear in mind that I wouldn't classify myself as a Power BI developer. I used Power BI quite a lot about 6-7 years ago. Recently, I've been more focused around data engineering, data science. So I'll try and explain these concepts as best possible, but I definitely recommend doing your own research. And I'll leave a link to a lot of really good resources for this kind of thing in the school community so that you can go in a bit more detail there. So first up, we're going to be looking at storage modes. Now, I've mentioned this fair amount on the channel, and lots of people talk about storage modes within Power BI and Fabric. So we're going to do a bit of a revision on what we mean by different storage modes, some of the advantages and disadvantages, and how you can choose between them. So this is the diagram that exists in the documentation. I think it does a pretty good job at framing out 3 different storage modes, connection modes, you might also hear it called as well. Now, if you've worked in Power BI for a while, you're definitely going to be familiar with both the import mode, this one in the middle, plus the direct query mode. Potentially, you might have used that as well at the top there. So for those not coming from the Power BI background, the import mode is basically going to take a copy of your data from source and load it into Power BI. So it's storing a copy of all your data in the actual Power BI data model itself. Now that makes it really fast when you're building reports because your data is right there. Now it does have some limitations in that because you're copying your data into Power BI, there are some limitations around the size, right? That's one of the main limitations on import mode. And also because you're having to do this lift and shift import on a schedule normally, your data in your Power BI data model is not going to be always up to date because you're going to have to do it every hour potentially. There is the chance that your data will become a little bit stale. On the other hand, we have direct query. So moving up to this top one here, in direct query, whenever the user views a particular visual, particular report page, Power BI actually sends a query back to your source. It's going to perform a query of that source and then get back fresh data. So in doing so, it's near real time. So that's one of the benefits of direct query. Some of the downsides of that mean that we can't actually perform much transformation on that data. It has to be transformed in the source, right? You have to create views and tables that already are transformed. In practice, direct query can be really slow because you've got to do that query every time you go back to the original data source. And for the user, they're sitting and waiting for their visuals to update. Every time you click a filter or you change the page, it's going to take time. It's going to be a pretty bad user experience. So the final one we've got here is the new one that came with Power BI. It's called Direct Lake. And Direct Lake creates a connection between what you create in your Power BI report and the underlying Parquet files. So it's going to read the Parquet files in your OneLake environment directly. So let's just have a look at potential reasons why you might want to choose import mode or direct lake mode or direct query mode. So some of the key considerations. Well, as we mentioned, for import mode, it's going to be really good when your data is small enough to fit within a Power BI data model, including large format semantic models, which we're going to talk about in a short while. Another good use case for import mode is when you want really good read performance in your dashboards, like interactivity and a good user experience for your dashboard users. When you don't have requirements for near real-time updates, and if you want to use calculated columns or calculated tables, if you want to be doing that kind of stuff, then you're going to be wanting to using import mode. And if you want to combine data from multiple different data sources, that's another good use case for import mode, which leads me nicely into when you would choose direct lake mode. Well, the first limitation really is that your data has to be stored in one Fabric data store. So in a lakehouse or a data warehouse, for example, you can't use direct lake mode to access data across lots of different data stores. So that's one limitation. The prime use case is when your data set is really, really big. We're talking tens or hundreds of gigabytes here. Now, obviously that would be too big for most import mode models, but that use case is really, really good in direct lake mode. Now with direct lake mode, it will require a little bit of a different skill set within your team because you're going to have to do a lot of the data modeling more upstream in your lakehouse, in your data warehouse, right? Because you need to materialize Parquet files that can be read by the direct lake mode connection. And typically what that means is your data transformation, your data modeling is going to have to be done in your lakehouse. So either using Spark or T-SQL. And that might be a slightly different skill set to what you might have in an import mode Power BI team, for example. Okay, so finally, let's just talk about when you might want to choose direct query mode for your semantic models. Well, again, if you need near real-time updates, that's going to be a really important one. Again, you're going to be needing to do your data transformations more upstream, so in your data source, wherever that might be. And direct query is also an important part of what we call composite models, which we're going to look at in more detail shortly. So let's look at composite models then. So a composite model combines one or more of these different connection modes that we just discussed previously. Now, commonly, this is a direct query fact table and import mode dimension tables. Because if we think about the common characteristics of a fact table versus a dimension table, well, in our fact table, we're going to have a lot of rows, normally a lot of data, could be millions or even billions of rows. And it's likely to be updated very often, maybe every minute or every second, even in some OLTP transaction processing type fact tables. They could be hundreds and hundreds of records every second. Now, because of those characteristics, direct query can be a good match for that type of data set, right? Because you get near real-time updates. So on data sets that are changing very often and very fast, direct query gives you that near real-time access to fresh data, right? Now with the dimensions, they might be changing a lot slower. So it makes sense to use import mode for those dimensions. You know, your product table might be updated once per day, for example. So a direct query connection mode in that example wouldn't really make too much sense because you're going to lead to user experience issues on the front end for that table, and you're not going to be getting much benefit because the underlying data isn't really changing very often. Now, another benefit of composite models is that they provide a way to model many-to-many relationships without the need for bridge tables as well. So next up, we're going to look at aggregations. Now, in this context, we're talking about a specific Power BI feature for managing aggregation. And specifically what this feature does in Power BI is it takes a really large data set. It creates a aggregation, either automatically or user generated. You can assign the aggregation that you want to build, and then it caches the actual aggregation. So when you have really large data models, it can improve the performance because you're caching the aggregation rather than loading in, a really long fact table, for example. And because of that, they are often used in conjunction with composite models. Now, either you can create the actual aggregation itself in your data source and then just pull it into your Power BI data model, or you can bring it into Power BI and then use the Power Query engine to create an aggregation, which then gets loaded into your Power BI engine. Now, as I mentioned, there's two really types of aggregation. We have user-defined aggregations, and that's using the Manage Aggregations dialog in Power BI Desktop to define these aggregations for a specific aggregation column. And then you choose how you want to summarize. Do you want a min, a max, that kind of thing, plus the detailed table and detailed column properties. Now, if you have access to a premium subscription Power BI, then you also get automatic aggregations. And these are basically going to use machine learning to try and optimize direct query semantic models. And they're going to look for the best aggregation to improve performance. Another thing we need to be aware of for this part of the exam is the large format semantic model. Now, large format semantic models provide a highly compressed in-memory cache for optimized query performance, enabling fast user interactivity. So if you've got a semantic model that's perhaps bigger than 10, 20, 30 gigabytes, what you can do is you can convert that small format semantic model into a large format semantic model. It's going to apply this compression, this in-memory caching, that's going to improve the performance of those models. Now, it's not just models that are over 10 gigabytes in size where you might want to think about converting to a large format semantic model. In many cases, even below that kind of 10 gigabyte threshold, there's some benefits in converting to a large format semantic model. Firstly, you're going to get the performance benefits anyway. Secondly, it's commonly used when connecting to third-party tools via the XML endpoint. Now, another feature of large semantic models is on-demand loading. Now, if you've watched some of my previous videos, you know that direct lake connection mode also uses this on-demand loading. And what that means is that when a user is viewing a particular page in a report, they don't need the full data set to be loaded into memory. On-demand loading has a look at the underlying Parquet files and only loads the required data that is needed to visualize the data that's being requested at that specific time. Now that can really improve performance again, but it's a feature that's shared between large format semantic models and the direct lake connection mode as well. Okay, so for the next part of this video, we're going to switch over to Power BI Desktop, and we're going to be using this to explain some of the key things that we need to know for this module in the exam. So we're going to be looking specifically at variables, iterators, table filtering, window functions, information functions, calculation groups, dynamic strings, and field parameters. And each of these different features and DAX expressions, I've got a little bit of an example just to talk you through the implementation, what that looks like. So let's start off with variables. Now, variables are very common in pretty much every programming language that exists. And DAX variables can help us avoid code repetition and also potentially improve the performance of your DAX code too. So here what we've done is we've created two variables, one called total revenue and one called total days. You notice the syntax here is to use VAR to declare it as a variable, and then it stores that result locally, and then you can use it later on in your DAX expression. Typically, you'll need to use a return statement as well when we specify these variables. And so in this example, we're declaring total revenue and total days as variables, and then we're using that in this return statement to give us the overall average revenue per day. Next, we're going to look at iterator functions, and iterator functions in Power BI basically enumerate through all of the rows in a table, and they perform some calculation depending on the specific iterator function that you choose, and then it's going to aggregate the result. Now, examples include SumX, CountX, AverageX. Most of them have this X afterwards. And here we've got a bit of an example here to showcase iterator functions, and we're using it in this cumulative measure. So we've got this cumulative revenue and we're doing SumX, okay? And we're using it on this filter. So what we're basically saying is for each of the rows in our date table, we're going to go one by one. And for each of them, we're going to increase the number of rows that are being filtered, right? So the first row, here we're basically comparing the current date or the date in the row that we're interested in with the max date, which on the first pass, when we're enumerating through this table, there's only going to be one row, the top row, right? And then we're calculating the sum of the revenue on that particular date. Now on the second row, obviously this is going to increase to two rows. So then we're going to do a cumulative revenue for the revenue on the first and the second row. Then we're going to go down to the third row in that table, and it's going to give us the sum of the revenue on the first, second, and third rows. So when we do this through the whole table, the result is this cumulative chart of revenue, basically from the first date here all the way through to the last date, which is about 19 billion in revenue on the last date in our data set, which is 31st of May 2020. Next up, we have table filtering. Now, table filtering uses the function filter, and it basically returns a table that represents a subset of another table or expression that you're using. So in this measure, we're calculating total revenue by category. And so we're using the calculate function, and we're passing in the sum of the revenue, and then we're filtering it by specific product names. So what this is going to do is create us this chart, right? So we get revenue figures for each particular category because we're doing this filtering of particular product names. So like Audi, Tata, Hyundai, these are all product names. And our filter expression here is basically filtering out the product name where is equal to the selected value of product name. Next up, we're going to look at window functions, and there's actually three functions in DAX that are classed as window functions. You have the window function called window, index, and offset. We're going to be focusing on the window function in this example, and some of the use cases where you might want to use a window function. Well, if you've used window functions maybe in SQL, the result is quite similar. The way that you implement it is quite a bit different actually. So a use case might be for things like rolling averages. So if you want to create a 3-month moving average of revenue, for example, you might want to use window functions. Obviously, there's lots of ways to do moving averages in Power BI. In DAX, window function is one of them. Or our window can actually be a category variable. So say, for example, the average revenue for each department in a company. So if we take a look at the documentation for the window function at a really high level, basically what it's going to do is return multiple rows which are positioned within a given interval. For example, we're going to give it a from and a 2 window, basically, and it's going to return the rows that meet that criteria, right, between the from and the to date. Now there's a few other parameters maybe to be aware of here, including from type and to type. So here we can specify either absolute or relative values. So absolute is just going to take the whole table from top to bottom and pick the absolute value in your from parameter here. Or do you want it to be relative, right? So relative. So if you pick a from type of relative, rather than looking at all the values in this table and picking the first or the second or 90th value from top to bottom, the relative is going to look at the current date and then look at maybe -10 might be a relative from parameter. Now, on its own, the window function is not particularly useful. Normally, how it's used, if we scroll down to an example here, it's going to be used in combination with some other sort of measure. Typically, as you can see here, it's used in this iterator function. So we're using the window function to get a window of data, and then we're applying average X on through that window. And that's to return the 3-day average price. So that's a bit of an example of how you can use the window function in practice. So information functions are another class of functions that exist within the DAX language. And there's a lot of examples of information function. You've probably used them if you've used DAX before, like contains or contains string or has one value, or is blank, is error, selected measure, user principal name as well. It's basically going to check a particular value in your table and return depending on the information function that you use. Normally it's a Boolean value, but sometimes it's something else like user principal name. It's not actually looking in a table in that point, it's looking at your actual Power BI file and looking at the logged in user. So in this example here, we've got a table, very simple table of simple transactions, and we've got transaction IDs and some revenues, and we're using this function here is blank, which is an information function, and we're basically using it in an if statement. So if this is blank returns true, then obviously we're going to use no revenue recorded. If it returns false, so i.e. there is some value in that column, then we're just going to write out revenue recorded, and then we get this sort of table here. Next up, we have calculation groups, and it provides a simple way to reduce the number of measures in a model, or at least the maintenance of those measures in a model. So say you want to create daily average, monthly average, and then yearly average measures. And you might want to do this for revenue, and you might want to do this for cost, and you might want to do this for salaries. There's a lot of repetition that you're going to have to do in this DAX code. So what we can do in calculation groups is basically parameterize those DAX measures so that the actual maintainable code that you're writing is a lot less. Now you can create these now in Power BI Desktop as of a few months ago, and also in Tabular Editor as well. I've got an example here where I've created this calculation group, and it's called averages. Now to have a look at our calculation group, let's just go over to the modeling tab, and then you can see here we've got calculation groups, averages, and then we've got some different calculation items. So obviously to create a new one, you can create a new calculation group here. Now in this calculation group, I've actually got 3 calculation items. The first one is just the total, which is just selected measure. That's kind of like your baseline measure. And then we're going to reuse that, or we're going to call that within other measures. So like the daily average is going to call selected measure here. The monthly measure is also going to call selected measure, but this time on the month. Next up, we're going to look at dynamic string formatting. And this is a pretty cool one. It basically allows you to apply string formatting on numerical measures without updating the underlying data type underneath. So it can remain as a numeric measure. In this example here, we've created this measure called dynamic format measure. We're using this sum revenue just as an example here. In our example, what we're doing is giving a few different options in our switch statement. So if it's less than 1,000, we're not going to do any formatting at all. If it's between 1,000 and a million, we're going to add in this K, so 1,000. We're going to add in an M if it's in the million ranges, and billion if it's in the billion ranges, basically. Now, the benefit of this is that, well, in our tables and this is just a card, it's going to show a much nicer presentation of that number, 524.6 million, rather than lots and lots of numbers. And the big benefit is that the difference between this and the modeling tab format string. So if we were to click on a specific revenue number here, for example, so we can maintain our format as whole number, but we're also formatting the presentation, right? And this is important, maintaining this format as whole number, because we might want to do something like visualize this data within a chart. So the final feature we are going to look at today in Power BI is these field parameters. And field parameters allow the report user, so the end user here who's going to be coming into your report, to select different categoric variables and also measures as well, kind of dynamically. So depending on the way in which they want to slice the data, you can set up field parameters to give them this flexibility. So in this example here, we've got a number of different parameters and we're looking at the revenue by different parameters. So currently we're looking at by location, but you might also want to look at by dealer or by country or by model or by product. And you're giving the end user the flexibility here to decide. Now to set up field parameters, you can go to the modeling tab, new parameters fields. And in that way you can set up a new field parameter, just give it a name and then pass in the different parameters that you want. You also rename them if you want here as well. And that's going to set up your field parameters. And then in the actual visuals, it's going to create this parameter. Maybe I could improve the naming here, but it's basically going to look like this. So it's just going to have this object here and it's going to say location is name of this. It's going to give it an index here, 0, 1, 2, 3, so that when you click on the filter, it's going to update the visual. And on the visual side, again, we've got on the y-axis just this parameter that we created and our measure that we want to visualize, so sum of revenue. Now in this instance, we've got a field parameter in the y-axis, but we could also have a field parameter for the revenue as well. Maybe you wanted to do sum of the revenue, average revenue, median revenue, whatever you would want, and you want to give the user flexibility to change these dynamically. So that's how you would do that there. Okay, so we've been through a lot in this video. Now let's test your knowledge of what we've been through and some of the questions that you might face in this section of the exam. Question 1. The DAX expression average x is an example of A, an information function, B, a calculation group, C, table filtering, D, a window function, or E, an iterator function. Pause the video here, have a little think, and then I'll reveal the answer to you shortly. So the answer here is obviously an iterator function. Now the big clue here is the x at the end of average x, which generally denotes an iterator function. Of course, an iterator function is those ones where we're going to be enumerating through every row in a particular table and performing some calculation before combining the results in some way, depending on how you set up your iterator function. It's not going to be information functions. It's not going to be a calculation group, table filtering here, where you might actually do some table filtering within your iterator function, but average x itself is not table filtering function. Similarly with window functioning. Again, you might use an iterator function average x within a window function, but average x itself is not actually a windowing function. Question 2. On-demand loading, i.e. loading only the data is needed for a particular query, is a feature of which two are the following. A, import mode, B, direct lake mode, C, direct query mode, D, large format semantic models, or E, the XMLA endpoint. The answer here is B, direct lake mode, and D, large format semantic models. So we mentioned this when we were going through the slides. This feature on-demand loading is actually shared by two of these modes here. So direct lake mode, and also it's a feature included in large format semantic models as well. On-demand loading doesn't really make sense in import mode, because in import mode, we've got the full data set there for us to query anyway. Now you could argue that direct query mode, what it's actually doing is very similar to on-demand loading. Whenever you get a request for a query, you're actually going back to the data source and you're querying that data source directly and then loading in only the data that's needed, whatever comes back from that database query. But I do think there is a distinction between what direct query mode is doing and a specific feature called on-demand loading. And I do think these two are slightly separate. So although direct query does a similar job, it's not actually leveraging on-demand loading. And the XMLA endpoint, E, is just not the correct answer. Question 3. Dynamic format strings overcome which significant limitation that comes from using the DAX format function? Is it A, the format function is slow on large data sets? B, the format function returns a string value, so the values can't be used in chart visuals? Is it C, the format function can't handle date locale conversion whilst formatting? Or is it D, the format function can't be used with field parameters? So the answer here is B. The format function returns a string value, so the values can't be used in chart visuals. One of the major benefits of dynamic format strings is that you actually retain the original data type for that particular column. So if you've got a numeric data type, maybe you want to format some millions or billions in that numeric data type. You can create a dynamic format string that's going to visually format the string, but the underlying data type still remains numeric. So you can use that field within charts, right? Maybe you want a time series chart. That wouldn't be possible if you use the format string, because that's going to return a string value and you can't visualize a string value in a chart like that. So the answer here is B. Question 4. The DAX expression selected measure is most likely found in the construction of which of the following? Is it A, a calculation item in a calculation group, B, field parameters, C, an iterator function, D, large format semantic models, or E, a window function? Now the answer here is A, a calculation item as part of calculation groups. So as you remember, you need to have that selected measure. That's what makes it dynamic and parameterizable, let's say, is that selected measure expression. It's not part of field parameters or iterator functions or window functions. Large format semantic models, well, of course, you could have a calculation group within your large format semantic model, but the most likely place that you're going to find this, because it's pretty much necessary, is in that calculation item when you're creating calculation groups. Question 5. Which of the following is an irreversible operation, which means it can't be changed afterwards, right? You can't go backwards. Is it A, changing the cross-filtering of a relationship to bidirectional? B, changing the storage mode of a table to import? C, naming a calculation group? D, converting a semantic model into a large format semantic model? C, creating a window function? So the answer here is B, changing the storage mode of a table to import mode. Now this assumes that the original storage mode of that table was direct query. And if we're moving it back to import mode, that is an irreversible operation. I'll leave a link to the documentation there that kind of specifies where that's the case. Obviously with A, the cross-filtering of a relationship to bidirectional, we can change the cross-filtering, that's not a problem, of a particular relationship. We can also rename calculation groups. Creating a window function doesn't particularly make sense because of course you can just delete the window function or delete the measure. Now, converting a semantic model into a large format semantic model is an interesting one. Now, I was under the impression that this also was an irreversible operation, but then when I was actually going to research it and test it out, I could actually convert a large format semantic model back into a small semantic model. So for that reason, I've included it as false, but let me know if you think that D is also a correct answer for this question. Congratulations, that's the first part of the semantic modeling section of this exam complete. In the next lesson, we're going to be looking at model optimization and security. So make sure you click here to join us for the next lesson. I'll see you there. Hi, welcome to video 10 out of 12 in this DP-600 exam preparation course. Today, we're going to be looking at securing and optimizing semantic models. So this is the second part in our semantic modeling section of the study guide. And as you can see here, we're very close to the end of the course. So we've got 2 more modules after this one. But today, let's focus on semantic modeling again. Specifically, we're going to be looking at implementing dynamic row-level security and object-level security, implementing incremental refresh, implementing performance improvements in queries and report visuals. And to do that, we're going to dive into the use cases for external tools like DAX Studio, Tabular Editor 2, and then we're going to go into a bit more detail about, okay, what can we actually do in terms of improving DAX performance in DAX Studio and also optimizing semantic models using Tabular Editor. As ever, at the end of this video, I'll be asking you 5 sample questions to test your knowledge of the things that we go over in this part of the study guide. Now, as with the last video, I've left links to really good further learning resources from people that are much more experienced in Power BI development and semantic modeling. So I will caveat this lesson by saying, definitely go and check out the further learning resources by MVPs, Microsoft MVPs for the Power BI side. A lot of this content is Power BI and also third-party tools that connect to Power BI as well. So let's start by looking at dynamic row-level security. So in general, when we talk about row-level security, we're talking about restricting who can see what data at the row level in specific tables in a Power BI report. Now, dynamic row-level security is kind of an extension to row-level security by applying row-level security using the usable principal name. Now, there are other information functions that we can use, but user principal name basically gives us the email address of the logged in user. So when the user logs into the Power BI service, then behind the scenes, we're going to get access to their email address, and we can use that to apply filters to the data in our Power BI report so that that user only sees the information that you have configured that they should be seeing. Now you can configure row level security in the semantic model, the data warehouse, and the T-SQL endpoint of the Lakehouse in Fabric. But if you're using direct lake mode, then you want to be configuring row level security in the semantic model. Otherwise, you're going to be falling back to direct query mode. And in general, the whole one security model in Fabric is still kind of under construction. So I definitely recommend, where we are currently, I would recommend just using the conventional semantic model row level security. Now, one thing to bear in mind is that row level security only really works when the users that you're trying to give row level security to have viewer permissions in a particular workspace. So if they have more than viewer, so admin or member or contributor, technically this row level security is not going to be enforced because they'll have lots of other ways to access that data. So that's one thing to bear in mind. They need to be viewers in the workspace, your users or your viewers of reports. So at a high level, these are the steps that are required to implement row level security. So the steps for implementing row level security in Power BI Desktop, well, first we're going to have to create a role. Now, after you've created a role, you want to select the table that you want to apply row level security to. You're going to enter a table filter DAX expression to configure when and who the row level security is applied to. And we're going to validate that row level security has been applied correctly. Now, as well as row level security, we can also apply object level security to our semantic models. But the way that we're going to be doing that is different, because object level security can only be configured via third-party tools such as Tabular Editor. And when we talk about object level security, what we're talking about is restricting access to a particular table in a semantic model or a specific column. So you might have a sensitive column within your Power BI report and you want to restrict who can see that particular column of data in your semantic model. As I mentioned, to configure object level security, you need to use an external tool such as Tabular Editor. And similarly to row level security, object level security only restricts data access for users with viewer permissions. So we can't give them admin, member, or contributor roles in a workspace. Now, the high-level steps to implement object-level security in Tabular Editor, well, again, we're going to need to start by creating a role in Power BI Desktop, or you can also create it in Tabular Editor as well. Then within Tabular Editor, you're going to want to find the role that you've created, click on the table properties for that role, set the permissions for the particular table that you want to apply object-level security on, set that permission to either none or read. Okay, so obviously none will be if you don't want to give them access to that table, and read will be if you do want to give them access to that table. Similarly, we can do the same for a particular column as well. Then we're going to be wanting to publish the report to the service and add the people and groups to the particular role in the service. Next, we're going to talk about incremental refresh in Power BI. Now, one thing to bear in mind here is that incremental refresh is a developing field in the world of Fabric. But for the purposes of this exam, I think what they are looking for is incremental refresh, which is a feature in Power BI, not talking about incremental refresh in Dataflow Gen 2s or data pipelines or anything like that. So I think we're focused here on the specific feature within Power BI called incremental refresh. And typically, this is used on large fact tables because incremental refresh allows you to pull in only the data that is changed within a given range, right? So perhaps in the last 24 hours or the last hour, you might only want to bring in the new data that's changed within that period, rather than, loading in all the data that's in that source database. And obviously that's going to have many different benefits if we can do this incrementally rather than all in one. For starters, we're going to need fewer refreshes. The refreshes are going to be a lot quicker because you're only pulling in what's new. Your resource consumption could be lower as well, because again, you're only bringing in what's changed, you're not bringing in everything every time. Now, the refreshes can be more reliable because rather than pulling in hundreds of thousands or millions of rows every time you refresh the data set, this could create open connections that are going to run really long on your database and have the potential to be timed out as well. Obviously, when you move to an incremental refresh, that problem is likely to go away because your refresh is going to be a lot quicker. As I mentioned, currently incremental refresh is only possible within the Power BI side. So they are working on incremental refresh features 4 ETL items, like data factory items, like the Dataflow Gen 2 and the data pipeline. But for the purposes of this exam, currently, when we talk about incremental refresh, we're talking about Power BI. And incremental refresh in Power BI is available for Power BI premium licenses only, so PPU or premium capacity subscriptions. And the incremental refresh policies are defined within Power BI Desktop. So just have a look at how we can implement incremental refresh. So it starts by creating 2 parameters called range start and range end. And they must be called range start and range end. These are reserved keywords for these parameters. And then in your Power Query, you're going to be wanting to apply some custom date filters to filter the data based on that table's date column to keep only the range between the range start and the range end. Then you're going to want to find your incremental refresh policy. And this is what this looks like. You're going to select the table. You're going to set your import and refresh ranges. And there's a few optional settings there, like only refreshing on complete days and detecting data changes as well. And then you're going to review and apply your policy. And then when you publish your report into the service, that's when your incremental refresh is going to kick in based on the policy that you've set and the range that you've set. So next, we're going to switch our attention and we're going to talk about semantic model performance. And whenever we talk about performance of anything really, it's useful to think of it in 2 steps. Number 1 is around monitoring and observation and gathering data about what's happening in our semantic model in this case. And then we want to talk about optimization. So once we understand what's going wrong, how can we optimize it to improve performance ultimately? So within Power BI and the external tools that you can connect to Power BI, there's quite a few different ways that you can monitor semantic model performance. On this slide, we'll just do a high level summary of all of them before digging into each of them in a bit more detail. So when we're talking about Power Query performance, there's a tool called the Query Analyzer tool. When we're talking about analyzing the visual and query performance, well, we can use the Performance Analyzer in Power BI Desktop. We can also export that data into other tools like DAX Studio as well for a bit more fine-grained analysis. We'll take a look at that shortly. So when we're talking about DAX performance, we can again use DAX Studio. We can bring in data from Performance Analyzer. We can also use things like traces to monitor all of the different events, both on the client side and on the server side as well. And for semantic model performance, we can use things like the Best Practice Analyzer, which is a tool within Tabular Editor. So for the purposes of the exam, you're going to need a bit of a knowledge about what you can do in Power BI Desktop, the limits of performance analysis in Power BI Desktop, and then knowing when to switch to tools like DAX Studio and Tabular Editor as well when you want a bit more advanced analysis or deeper diving into the things that are going wrong in your DAX and your semantic models. Let's take a look at these 3 in a bit more detail. So first, let's look at DAX Studio. So one of the core use cases that we can use DAX Studio for is loading the Power BI Performance Analyzer data in DAX Studio for further analysis. So within Power BI, we can record different actions when we're using the report, like clicking on different filters, refreshing different pages, and it's going to log the query time and the visual load time for every visual on a specific page. But the UI in Power BI for analyzing this Performance Analyzer data is a little bit limited. So what we can actually do is export that data and we can import it into DAX Studio for a bit of a deeper dive analysis on that. We get better filtering and sorting than in Power BI Desktop. And you can also view the queries behind each visual load. Now, since Power BI has introduced the DAX query view, this has become a bit of a less of an advantage for DAX Studio, because now you can also run the underlying DAX query for a specific visual within the DAX query view in Power BI Desktop, but something to bear in mind. Another really core use case of DAX Studio is using the view metrics to look at the Vertipack analyzer. So the Vertipack is the engine, the analysis services engine that basically Power BI runs on. And so we can analyze what's going on in there using this view metrics. We can take a look at table and column sizes, and obviously the size of your table and your column has a really big impact on performance, right? And then we can start to look a bit deeper into reasons why things might be slow, like the cardinality of a column, the different data types that you're using for a specific column, and much, much more. We can also use the Vertipack analyzer to look for referential integrity violations. And what we mean by that is a mismatch in the unique keys on 2 sides of a relationship. There's lots more information in the Vertipack analyzer. For the purposes of the exam, I think it's good just just to have a look at the VertiPack Analyzer, understand what you can do there, and the insights that you can gather from that. Another really useful feature in DAX Studio is the trace analysis. So for trace analysis, there's 3 traces we need to be aware of. The all queries trace is going to capture different query events from client-side tools such as Power BI Desktop. So this is the only one of these traces that's going to be able to capture both on the client side and on the server side your queries as well. The query plan trace there is only really going to capture the query plan trace events from the analysis services tabular server, right? So if you're using the DAX editor within DAX Studio and you're using that to run queries and kind of analyze their performance, that's where you're going to be using the query plan, because it's going to give you the plan of that specific query on the analysis services engine. And the server timing trace is going to give us the query timing from a server perspective. So next, let's switch over to Tabular Editor and look at some of the use cases that we might want to be using Tabular Editor for. And the main one when it comes to optimizing semantic model performance is the best practice analyzer. And this is a tool that basically performs a scan of your semantic model and it checks it for common issues. Now there's a list of rules that can be downloaded from GitHub, and you can also create your own custom rules as well, but there's a predefined list of rules that you can download from GitHub, and they're organized into these categories. We have ones that talk about performance, ones that talk about your actual DAX expressions that you're using, error prevention, formatting, and maintenance. So these are different categories of those rules in the best practice analyzer rule set. Now these checks can also be run from the Tabular Editor CLI as part of a CI/CD process. So when you deploy a semantic model from a development environment to a testing environment, you might want to run the best practice analyzer rule sets against your semantic model to give you an automated way of analyzing the quality of that model, to surface any particular errors that you might get with that model, and things you need to be aware of from a quality and maintenance perspective in that model. So I've left this use cases for DAX Studio and Tabular Editor at the end here, just to kind of review everything we've talked about when it comes to DAX Studio and Tabular Editor. So on the DAX Studio side, we're going to be wanting to use DAX Studio when we want to write and execute and debug DAX queries. But they do actually need to be manually copied over to Power BI Desktop, as DAX Studio is read-only. Now, since, as I mentioned previously, Power BI Desktop now has the DAX query view, you can actually write and execute DAX queries and view the results, similarly to how you can do in DAX Studio, but that's a relatively new feature that didn't used to exist in Power BI. We can use the VertiPack Analyzer to understand the size of your semantic model, as well as individual tables and columns within the model. We can bring Power BI Desktop Performance Analyzer data into DAX Studio to analyze it further, and we can use those trace analysis functionalities to analyze query events, both on the client side and the server side, depending on the trace that you select. And when we're talking about the use cases for Tabular Editor, we're going to be able to quickly edit data models. So we can create measures, perspectives, calculation groups from the DAX editor within Tabular Editor, and we can publish them directly into the semantic model. So that's a bit of a distinction between the functionalities of Tabular Editor and DAX Studio. In Tabular Editor, we can actually update our semantic models in the tool itself. There's also functionality for automating repetitive tasks using scripting. And as we've mentioned, we can incorporate DevOps into the kind of tabular model lifecycle using that CI/CD functionality in the Tabular Editor CLI. And we can use the best practice analyzer to identify common issues in your Power BI semantic model. Finally, a good use case for Tabular Editor is if you want to implement object level security. As we mentioned before, that's not possible currently within Power BI Desktop. So if you want to be defining object level security, that's going to be done in Tabular Editor. Okay, we've covered a lot of ground again there. So let's just wrap up this video with some practice questions to test your knowledge of this section of the exam. Question 1. Your goal is to analyze performance analyzer data in DAX Studio to find the visual in your report with the longest total load time. Put the following steps in the correct order to achieve this. So what you've got here is 5 steps in a process. Your goal is to reorder this list so that it makes sense for this particular goal that we're trying to do, analyzing performance analyzer data in DAX Studio. So take a moment here, get a bit of paper, maybe write these down in the correct order, and I'll show you the answer shortly. So the answer here is like this. So first, we're going to be starting a recording in Power BI Performance Analyzer. We need to actually record it in Power BI to begin with. Then you're going to be wanting to click refresh visuals just to update the visuals on the page, or you can interact with the report as well if that's what you want to be analyzing. Then clicking stop recording. Then we can export that performance data JSON and then import it into DAX Studio. Then we can go over to the Power BI Performance tab and sort by the total milliseconds descending to find the longest refresh time for a particular visual on the page. Question 2. You want to use the best practice analyzer tool within Tabular Editor to assess your DAX performance. Which of the following severity codes for best practice analyzer rule violations indicates an error? Is it A, level 0, B, level 1, C, level 2 and above, D, level 2, E, level 3 and above? So the answer here is level 3 and above. So in the best practice analyzer within Tabular Editor, we have many different levels of severity of the different rule violations. Level 1 is just for information only. A level 2 is a warning, and level 3 and above is an error. So level 3 and above, E, is the correct answer to this question. Question 3, when implementing dynamic row level security, which information function should you use to filter the data in a specific table based on the logged in user's email address? Is it A, user, B, user object ID, C, user email, D, user principal name, or E, username? So the answer here is D, user principal name. So as you recall, when we were talking about dynamic row level security, and specifically in the question is talking about using the logged in user's email address, and the information function to give us that is the user principal name. Now the user function doesn't exist. The user object ID and the username does exist as information functions in DAX, but these are not the correct answer. They won't give us the email address. The username will just give you the domain and the user's name rather than the actual email address. And user email C is also incorrect. That one is made up. So that's not what the function is called. It's user principal name D. Question 4. In DAX Studio, which of the following records queries that are generated by a client tool like Power BI Desktop? A, query plan trace, B, SQL profiler, C, all queries trace, D, server timings trace, or E, the Vertipack analyzer. So the answer here is C, the all queries trace. So the clue in the question here was talking about the client tool and recording queries that are generated specifically within the client tool itself, within Power BI Desktop. So the all queries trace is the only one that's going to give you that information. The Vertipack analyzer, well, that's just going to analyze things like referential integrity and the sizing of different tables and columns within your semantic model, not necessarily the load time directly within the client tool Power BI. And the SQL profiler, the server timings, and the query plan, these are all kind of server-side back-end tools. They're not going to give you information about queries generated in Power BI. So the answer here is C, the all queries trace. Question 5. The first step in implementing incremental refresh in Power BI is to A, add a range start and a range end column to your dataset. B, add refresh start and refresh end parameters to your Power BI Desktop project. C, add a refresh start and a refresh end column to your dataset. Or add range start and range end parameters to your Power BI Desktop project. So the answer here is D, adding range start and range end parameters to your Power BI Desktop project. Now, as we mentioned previously, range start and range end, they're reserved keywords when we're talking about parameters. So you do need to specify when you're adding in these parameters, should be range start and range end. Answers A and C talk about adding columns to your data set. That's not going to do anything, or at least anything useful when it comes to incremental refresh. We need those as parameters because we're going to use those to filter date column in the table that you're interested in. So we're going to use those parameters to filter that table. And as I mentioned previously, B is wrong because we're using refresh start and refresh end rather than range start and range end. We need to be specific when we're using incremental refresh to be using range start and range end. Congratulations, you've now completed the first 3 sections of the exam study guide. We only have 2 quite short sections to go. So make sure you click here to join me in the next video where we'll be looking at exploratory analytics in a bit more detail. See you there. Hello and welcome back to the channel. Today we're going to be continuing our DP-600 exam preparation course, and we've made it to video 11 of 12 in this series, and today we're going to be looking at performing exploratory data analytics. Now there's this video and then one more video to go, so we're very close to the end. So keep going, we're almost there. And within this video, we're going to be looking at descriptive, diagnostic, predictive, and prescriptive analytics. And specifically, we're looking at how to implement those things within Power BI. We'll also be taking a look at the data profiling tool, which is part of the Power Query experience. So you'll see that within the Dataflow Gen 2 and also within the Power Query engine in Power BI as well. Towards the end of the lesson, we'll be finishing with 5 sample questions just to test your knowledge of this section of the study guide. And as ever, I'll be leaving links to further learning resources if you want to go into more detail about anything that I mention in this video. And I'll leave a link to the school community in the description below if you want to grab those learning notes. Okay, so just to kick us off, I think it's worthwhile just going through those 4 types of analytics and looking at what they mean in Microsoft's own words. So we'll start by looking at descriptive analytics. So when we talk about descriptive analytics, we're talking about analytics that interpret past data and KPI to look for trends and patterns. So we're looking at what happened in the past. We're describing what happened in the past when we talk about descriptive analytics. And we'll be going into some examples of descriptive analytics and some visuals you can use to perform descriptive analytics. But for now, let's just look at these definitions. The second one to know is diagnostic analytics. So diagnostic analytics varies from descriptive analytics because we're not just worried about what happened in the past, but we're looking at analytics that describe which data element will influence specific trends and the possibility of future events. So when we talk about diagnostic analytics, we're not just talking about what happened, but we're inferring why something happened. So we don't just care about, okay, what happened in the last 12 months, but we're looking for more detail around particularly why certain events or certain trends might have occurred. Now, typically this uses techniques like correlation analysis and data mining, at least in the words of Microsoft. And there's various techniques that we can use to kind of infuse our visual reports in Power BI's to try and expose some of this diagnostic information. Number 3 is predictive analytics. So with predictive analytics, we're going to be using statistics or machine learning as well to forecast future outcomes with statistical models and machine learning techniques, as I mentioned. Now, these analytics provide context and clarity for future decisions. So in predictive analytics, we're not just worried about what's happened in the past, but we're using that data, our historic data, to think about what might happen in the future with some amount of certainty. And finally, the next level of analytics is prescriptive analytics. So in prescriptive analytics, we're not just predicting what's going to happen in the future, but we're providing recommendations and we're recommending actions that might be the best course of action to either prevent a particular scenario or to increase the chances of a particular scenario, particular outcome for your business. Now, with all of these 4, the clue really is in the name. So if you're struggling to remember what each of these types of analytics is, then it helps just to go back to the first word in each of them and really understand what each of them means. So in the first one, we're describing. So it's descriptive analytics. We're describing what happened in the past. With diagnostic analytics, we're diagnosing. So we're not just describing what happens, but there's some sort of causality there. We're thinking why something happened in the past. So we're diagnosing a particular trend. Obviously, with predictive analytics, we're going to be predicting what happens in the future. And with prescriptive analytics, obviously the key word there is prescribe. We're not just predicting what's going to happen in the future, we're also prescribing a suitable course of action that you should follow to optimize a particular outcome in the future. Now, one thing I'll say before we start here is that most of the content for this section of the exam comes from, or at least is inspired by, the PL300 exam for the Power BI data analyst. So that is what we'll focus on for this section of the study guide. For me, it's a bit less about descriptive, diagnostic, predictive, and prescriptive analytics, although you could argue that the visuals that we're talking about here align to one of these 4 categories. Really, it's more about Power BI and the visuals in Power BI, when you should use which visual, and when you should use specific Power BI features. So that's what we're going to be focusing on in this lesson. And when it comes to visuals and choosing which ones you should use when, well, visual selection is somewhat subjective, I would argue. For the exam, I recommend that don't try to be too clever when you're thinking about visual selection. So they might ask you, when should you use this particular visual? Or given this scenario, which visual would you choose? So instead of trying to be too clever, instead I would recommend thinking about what Microsoft see as the main use case for a particular visual. Get inside the heads of the examiner and of Microsoft and think about how they want you to use the tools. Keep that in mind as we go through the following examples. Okay, so let's go through some of the commonly used visuals in Power BI and when you might consider choosing them or maybe not choosing them as well. So let's start with the table and the matrix visualization. So these are really good for visualizing fine-grained details in your data, allowing your user, the report user, to explore the data themselves, right? And these are commonly used in drill through functionality. So when you want to provide the user the option to drill through to find more detail about a particular metric, you might allow them to drill through, and we'll be talking through that functionality in more detail a little bit later on. They can also be used to display aggregate information. So for example, the revenue broken down by month, for example. One of the drawbacks of the table and matrix visualizations that obviously it's difficult to spot long-term trends, at least visually. Next, we have the bar and the column chart. So when you have one categoric variable and one numeric variable, for example, you might be looking at the revenue by region. These are particularly useful. They can also be stacked if you want to add in another categoric variable into your analysis. So maybe revenue by region, but then also by product type as well, just to give an extra layer into your analysis. Again, bar and column charts, they can be used to visualize time series information, but it does get a bit messy if you've got lots and lots of time periods along your x-axis. Generally, it's better to present time series information on a line chart, which brings us nicely into the next one, which is the line and the area chart. As I mentioned, these are really good for visualizing time series information. You can fit a lot of information into one chart over large time ranges. We can also use the legend to kind of break up a single line into multiple lines to compare how that metric is changing within each category over time. Now, another variation of this is the area chart on the right hand side there. My personal opinion is I don't really like the area chart. It's difficult to interpret all these different areas because the color of each area is kind of impacted by the color underneath it. So it can be difficult to interpret, in my opinion, from a user perspective. But again, this is not about my personal opinion. It's about what Microsoft sees as the core use cases for each of these charts. Next, we have the card visualization. Now, these are obviously really good for KPI metrics, and you can also include percentage change metrics. You can add a bit more context about what's happened. Is that sales amount an increase or a decrease since the last sales amount as well? Now, out of the box, by default, it doesn't really give you that longer term trend, but it can be coupled with things like a spark line. So if you want to show the momentum of a particular metric over time, adding that spark line can be really useful to give your users a bit of context about how that's changing over time. And the card visual is something that has been developed quite a lot by Microsoft over the last few months and years, and it's actually quite feature rich now, so you can really add a lot of information into these card visuals. The pie chart, donut chart, and tree maps are a little bit controversial, but their main goal is to show ratios between different categories. Now, the reason why pie charts and donut charts, these kind of ratio charts, can be somewhat controversial is that they're more difficult for the human brain to interpret the difference between an area, which is what we're showing in a pie chart or a tree map, for example, and a more linear comparison that you get with like a bar chart. Another potential downside of this type of visual is that by presenting ratios, it does somewhat obscure the overall numbers. So you might be comparing the sales in USA to the sales in the UK as a ratio, but you don't really by default get a view of the overall sales in each category. Now you can add that to the labeling and also potentially a tooltip to add that information in, but I would argue if you're going to do that, there's better visualizations to choose. Another downside is that we can't really see the trends over time. So similarly with the card visual, we're only getting the point in time metric for that particular metric, right? We're not seeing how that metric has changed over time, which is normally more useful for the user. Next, we come to combo charts. Now, these are typically used to visualize more than one metric on the y-axis. So you can see here we've got the bar chart showing one particular metric, and then we've got a line chart showing another metric on top of the same visual, right? Now this can be useful in some scenarios, but you do have to be careful because sometimes this allows the user to come to a certain conclusion about correlation between these two metrics, which you might not actually be correct, that correlation. And it can also be difficult for a user to interpret which axis is showing which metric. Often you need a really good legend to explain the differences between these two axes, these two metrics as well. Next, we come to the funnel visualization. Now, these are really good for showing some sort of movement through a linear process. An example here would be tracking website conversion. So at the top of your funnel, you might have a website viewer visiting your website. Then the next stage in that linear process might be, okay, they're going to a product page. Then the next stage might be, okay, they've clicked on buy, they've added something to their cart, for example. And then the next stage in the process might be they've actually bought the product, and so on and so on. So when you've got linear processes and you're trying to visualize some sort of movement through that process, funnel visualizations are really useful. Now, if I was to be picky, I think you could argue that it is difficult for some users to grasp the scale of the difference between each of the levels in this funnel. But again, that's probably not something for the exam, that's just personal preference. Next is the gauge chart. Now, the gauge chart is useful when we want to show progress of a particular metric towards a goal. So say you have an annual revenue target and you want to show halfway through the year that, we're actually at 53% of our target, so we're on track, for example. Next up is the waterfall visualization. So the waterfall visualization is useful for showing a running total over either a time period or within specific categories, right? So the goal here is really we want to understand which periods or categories contribute most to that change, to that overall figure, right? And again, from personal experience, the waterfall chart I think should be used carefully because it can be, in my opinion, somewhat difficult for users to interpret, but that's just based on my experience. Next, we have the scatter chart, which are generally used when you want to visualize two numeric or continuous variables. Now, again, you can add more information to the legend of these types of visuals if you want to, add a further layer of analysis. So you might be visualizing someone's age versus their height, and then your third variable that you want to add into that analysis might be the country that they grew up in or the country that they live. That might be an extra variable that you want to add into this analysis, and you can do that by color coding the dots, also changing the shape of those dots as well. Now, obviously, you need to be careful when you do that, adding in a third variable, because having a scatter chart with lots and lots of different categories of different colors can be quite difficult to interpret from a user perspective. Another kind of warning with these types of charts is that it can sometimes lead the user to come to conclusions about correlation between these two variables. And as we know, correlation doesn't always equal causation. So that's something to bear in mind. As a report author, you might want to compare these two variables when in reality, they might not actually have a causative relationship. Next, we've got custom visuals. So custom visuals help you go beyond the out-the-box visuals that come with Power BI. And there are lots and lots of custom visuals that you can explore, the app source. Now, these can be really useful if you want to use slightly more niche visual types that maybe haven't made their way into the core Power BI visuals set yet. And of course, bear in mind that if you use a custom visual, these are normally built by third parties, and sometimes they involve licensing and things like paywalls. You might be able to use it for a short period and then you have to pay, but that's something just to bear in mind around custom visuals. Now, the final visual type we're going to look at is the Q&A visual in Power BI, which allows users to ask natural language questions about the data in your underlying data models. Now, this sounds good, but in practice, I think it's difficult to implement well. Obviously, the questions currently need to be carefully articulated to kind of match your data model. So it requires the user to understand the columns and the tables in your data set to craft good questions that can give good results, basically. Currently, it's only available in English and Spanish as well if you enable it in the admin settings. So that's a summary of some commonly used visuals. Now let's look at some Power BI features that can help us as report developers to go kind of an extra layer in our analysis to help with maybe some of the diagnostic elements or the predictive elements that we're looking for in this part of the study guide. Starting off with the drill down functionality. So drill down basically allows your user to explore your data through layers of a hierarchy. And that hierarchy can either be explicit, so as a Power BI hierarchy, or it can be implicit. So maybe you haven't actually defined it as a hierarchy, but there is some implicit hierarchical relationship between these variables. Now, a classic example of a drill down might be to visualize at the top level of your drill down revenue in a particular country. And then you might want to drill down and look at revenue by specific state. And then within that state, you might want to look at revenue by store in a specific state, for example. Now, alongside drill down and drill up functionality, you also have drill through. And drill through is a Power BI feature that allows users to drill through from one report page into another report page, and it carries through that information that they click on. So an example here, you might want to drill through this SharePoint category and take them through a different page in the analysis, pre-filtered based on whatever you drill through on. Now, obviously with this drill through, you need to think carefully about the user journey in your report and the navigation journey that they're going through. You might want to add in things like back buttons to make sure that they don't get lost in your report. Now, with both of these features, again, this is just from personal experience, it requires your end user to have knowledge of drill down and drill through. So I would argue this is a bit of a downside for these features, but something to bear in mind when you're authoring these reports. Next up, grouping. So grouping allows report authors to group two or more categories within a visual. We can create groups of months in this example, or anything really that makes sense for the particular visual that you're creating. Now, when your data is continuous, so it's numeric, you might want to use binning. And binning basically allows you to create different bins for these continuous variables. Now, an example of this might be to create a salary bin. So rather than just have salary as a number, you might want to create salary ranges. So from 0 to 30K, 30K to 60K, for example. And obviously that opens up different visual types that you might want to explore and use for this type of data. Some other features to be aware of are reference lines. So this allows report authors to provide a static reference line across the X or the Y axis to give the user some more context. So it might be the average sales amount for salespeople. So maybe you're visualizing how all the different salespeople have performed, and you can see all of the data. Well, it might be useful to show report users what the average is so that they can make a comparison, give them some context for that comparison. Another feature here is around visualizing errors. So if your data set contains some sort of errors in them, normally it's around prediction uncertainty or measurement uncertainty, then we can use error bars to show that uncertainty to the user. Now, these can either be markers, or they can be lines, or they can be shaded areas. Maybe if you're doing like a time series forecast, that kind of thing, you can have a shaded area for the uncertainty of a particular prediction. Now, obviously this requires data on errors or prediction uncertainty. Next, we have what if parameters. So we can use what if parameters to perform some, what I would say is kind of rudimentary scenario analysis. So giving your report users the option to change a particular variable, particular parameter. In this case, we've got discount percentage, and they can see what impact that has on a particular metric in the chart below. Now, to actually get what if parameters to work, you need to do quite a lot of data engineering and potentially prediction algorithms as well. So it can be quite difficult to set up a good what if analysis. Finally, we've got time series forecasting, and this can be accessed in that analytics pane. So the third icon when you're setting up a visual is the analytics pane. And here, if you have a time series data set, you've got revenue numbers for the last 24 months. For example, Power BI gives you the functionality to create a time series analysis. Obviously, this is quite limited, and I would argue you should be careful here. If you want to be doing any sort of serious time series analysis, I would argue that it shouldn't be done solely within Power BI, but the functionality is there and you might get asked about it. Great, so let's finish off this lesson with a look at the Power Query data profiling tool. Okay, so let's just explore the data profiling tool, which comes with the Power Query engine. So we can use this in a Dataflow Gen 2, or also in the Power Query engine in Power BI Desktop, if you're using that as well. Now, what I've got here is just a query on this revenue data set, and I want to explore some potential data quality issues in this data set. Now to do this, we can go to the View tab and have a look at the data view, enable column profile, and then we've got a few different options here. So show column quality details. If we just do that one to begin with, and let's just explore what that gives us. So we can see we've got these three kind of categories. So it goes through each column and it gives us a percentage of how many values in that column are valid, how many are errors, and how many are empty. So it gives you a really quick indication of column quality. Now by default, you can see down here that the column profiling is based on the top 1,000 rows. So currently it's looking at the top 1,000 rows. And for this dealer ID column, saying that none of them are empty, there's no errors, and 100% are valid. Now, if we change this to the entire data set, obviously it's going to take a bit longer to calculate, but then it's going to look at your entire data set, every value in this column, and it's going to perform that same categorization. As you can see, this data set looks pretty good. We've got 100% valid for all columns, no empty and no errors. So that's good. If we go back to the data view, now we click on the column value distribution. Let's have a look at what that gives us. So now we've got this quite high level view on the distribution of values within this column. And if we make that a bit bigger here, we can begin to see how many of these values are distinct. Now, to explain the difference between distinct and unique, I think it helps to look at this column here. So we've got true and false values in every row in this column. Now it's showing as a distinct count of 2, which is obviously referring to true and false. So it's kind of like a distinct count of the values in that column. Unique means values for which there is only one row. So here, there's no unique values because there's true in more than one row. You know, these are not unique. It's included in multiple rows. And false, there are actually multiple falses. So if in our sample size here, we only had one false value, then it would be, in fact, unique. So we'd get that 1 in the unique column. But currently, because we have more than one false value in this column, it's not unique. So there's 0 unique values in this column. So next up, to explore, we have the details pane. So if we enable the details pane here, and then we click on a specific kind of distribution we've got here, and make this a bit smaller. So we get a bit more information about the distribution in a particular column. So we can see the counts, the error counts, the null counts. We can also see the distinct count, unique count, empty string counts, and the minimum and the maximum values. Now, obviously this is a minimum maximum of a string value, but it would also work with numeric numbers as well. I think this column only has units sold 1. Yeah, so the min and the max is also 1, so it's not a particularly good example here. And we've also got things like the average, standard deviation, number of odds, number of evens, so it gives you a bit more detail about what there is in that column. Now, once you've got a pretty good idea about the kind of distribution of a column, you might be able to spot things like duplicate values in here. What we can do is we can right click on it and we can remove duplicates, or you might want to remove errors as well. You can do that from just right clicking on this top section here, and it gives you a quick way to remove or replace these errors or duplicates as well. Okay, let's just round off this video by going through some practice questions to test the knowledge of what you've learned during this section of the exam of the study guide. Question 1. A company annual report shows a net profit of $34 million. Now the company has 12 business units, each with their own net profit or loss amount. Which of the following visual types could best be used to visually show how each business unit contributed to the overall net profit metric? Is it A, a line chart, B, a scatter chart, C, a matrix chart, D, a waterfall chart, or E, a question and answer visual? Pause the video here, have a think, and I'll reveal the answer to you shortly. So the answer here was the waterfall chart. As you remember when we were going through the waterfall chart, one of the core use cases of that waterfall chart is to break down one top level metric into its constituent parts to allow the user to explore how each, in this case, business unit contributes to the overall net profit metric. Now, the other visuals that we've listed here, you might be able to glean some of that information, but as I mentioned previously, what we're after here is what would be the best visual to visualize this information. And for me, that's the waterfall chart. Question 2, you want to add measurement error bars on a time series line chart to show the potential error in each measurement. Where would you go to add this information to your visual? Is it A, the analytics pane, B, the format visual pane, C, view tab and show error bars, D, the build visual pane, or E, in the model view? So the answer here is the analytics pane. When you're configuring the settings for a particular visual, there's obviously 3 panes or 3 different windows that we can use to declare different settings, and the error bars functionality is included in the analytics pane. It's not going to be the build visual pane. That's where you add your different variables, your different columns to a particular visual. Format visual, that's where you change things like the text and the border and all that kind of thing. It's not going to be the model view, because that's where you define relationships and things like that. And it's not going to be in the view tab, show error bars. That doesn't actually exist, that functionality. I just made it up. Question 3. You want to visually compare 2 continuous variables, age and height, of survey respondents in one chart. Which of the following visual types could best represent this data? Is it A, a line chart, B, a stacked bar visual, C, a scatter visual, D, question and answer visual, or E, a matrix visual? So the answer here is C, the scatter visual. Obviously, when you're visualizing 2 continuous variables, so age and height, then probably the best visual to use for that would be the scatter chart. Put your height on the y-axis or your age on the y-axis, and then you can plot different dots for each of your survey respondents. Again, the other visual types not really going to help with that kind of analysis. You could argue that the matrix would potentially show you all of that, but it's going to be a really big chart if you've got lots of respondents. So the answer here is C, the scatter visual. Question 4. By default, the data profiling tool reviews the top n rows of your data set to show you potential data quality issues. So what here is n? So how many rows? Is it A, 10, B, 100, C, 500, D, 1000, or E, 10,000? So the answer here is D, 1000 rows. As you can see here from that visual, by default, the column profiling is based on the top 1000 rows. Obviously, we can change it to include the entire data set as well, but by default, it's 1000 rows. Question 5. Which of the following features of the data profiling tool can help you identify duplicate values in a column that you plan to use as a key to join on? Is it A, column quality details, B, column value distribution, C, column duplicate analysis, D, column key constraints, or E, group by? So the answer here is B, the column value distribution. So as we mentioned, one of the key use cases for the value distribution is to look for duplicate values, because if you've got a key that you plan to join on, you want to be looking for duplicate values in that key, and in a column with no duplicate values is going to look like this, with just a flat line. So every value is going to be distinct here. On the left hand side, this would indicate that there are some duplicate values. There's some values here that have a count of more than the others, right? So this would be a potentially problematic key on which to join on, but this date ID column, all of the values here are unique, at least in the sample of data that you're using for profiling. The column quality details, A, doesn't give us this information. The column duplicate analysis, C, doesn't actually exist. Neither does D, the column key constraints, and E, the group by. Okay, you could potentially use a group by to look for duplicate values, but it's not a feature of the data profiling tool itself. Congratulations, we're nearly there. Only one section of the study guide to go. In the next lesson, we'll be looking at the final section of the study guide. We'll be looking at how to use SQL to analyze data via the Lakehouse SQL endpoint in the data warehouse, and also via the XMLA endpoint as well. So make sure you click here to join us in the last lesson in this series. I'll see you there. Hello and welcome to video 12 in this DP-600 exam preparation course. And we've made it. This is the final video in the study guide. We're going to be looking at querying data by using T-SQL. Now you'll notice that I've added an extra video there because I really wanted to give you one more video just to really help you prepare for the exam. So we'll be going through how to prepare for the exam, some other resources that I think you should take a look at before you take the exam, and some advice for when you're actually sitting the exam as well. But we'll be going through that in the next video. For this video, we're going to be focusing on these 3 sections of the study guide. So we're going to be looking at querying the Lakehouse and the data warehouse using T-SQL. And we're also going to be looking at the visual query editor, which is a feature of both of those 2 SQL endpoints as well. Finally, we'll be mentioning how to connect to and query datasets using the XMLA endpoint. As ever, I've released study notes to help you go a little bit deeper, just to make sure that you're covering off all the right points, and links to other further resources if you want to go a bit deeper on whatever I've mentioned in this section of the study guide. As ever, I've also got 5 sample questions to test your knowledge at the end of this video. So let's just start by looking at the different ways that we can access the T-SQL engine within Fabric. And there's a few different ways to be aware of. So one of them is the Lakehouse T-SQL endpoint. Now, one thing to bear in mind here, as we've already mentioned quite a lot already, is that this is read-only. So all you can really do here is select statements, DDL, that kind of thing. You can't do any sort of inserts, updates, deletes, all that kind of stuff from the T-SQL endpoint in the Lakehouse. Now, the more obvious place to do T-SQL is within the Fabric data warehouse. Here, you're going to have the opportunity to write T-SQL, both DDL, DML, inserts, updates, deletes, select statements, all of that stuff. So the data warehouse is going to give you the ultimate flexibility, really, to write T-SQL scripts within Fabric. Now, on top of the T-SQL query editor, you can actually also create T-SQL-like queries using the visual query editor. And this is quite similar to the Dataflow Gen 2 if you've ever used the visual editor in a Dataflow. So we can do things like merging different tables and filtering tables and adding additional columns, that kind of thing. But we can do it through a no-code visual interface. And we'll be taking a look at that in a bit more detail shortly. So the other option for writing SQL is via the XMLA endpoint. And as we've mentioned previously in this course, to connect to that XMLA endpoint, we need to go into our workspace settings, as you can see on the left here, grab the connection string, go into SSMS in this example, connect via the analysis services server type, pass in your XMLA endpoint in there. That's going to bring through all of our lake houses and our warehouses within that workspace. And then we can write different queries depending on your use case from that XML endpoint. So now that we have a good understanding of where we can write T-SQL, for most of this exam, you need to have a pretty good level of T-SQL, at least an appreciation for what a lot of different T-SQL functions do, and be able to at least read T-SQL quite well. And I don't think there's kind of a definitive list of which T-SQL functions you need to be familiar with, but I definitely recommend being comfortable with the following. So the difference between where and having, group by, summarization, union and union all, different joins and when to use them, common table expressions, things like lead and lag, row number, partitioning, that kind of thing, subqueries, and cross-warehouse queries as well. So rather than just describing all of these things, I think it would be better to jump into Fabric, open up a data warehouse, and show you some of these functions in action. Okay, so here we are in SQL Server Management Studio. And I've connected to one of my gold data warehouses here called DW Gold using the SQL connection string. And you can see that currently we don't actually have any data in this data warehouse. The tables are empty. So the first thing that we're going to do is just to bring some data from some other tables that we've got into this data warehouse. So to do that, I'm just going to be using this CTAS, so create table as select. So it's going to enable us to create a new table in this data warehouse using existing data in another data warehouse, or in this example, it's actually a lake house. So we're connecting to the SQL endpoint here. So this is an example of cross-database querying, because what we're doing here is we're creating a table from another lake house altogether. So we're getting all of the data from this dbo.revenue table in our lakehouse bronze, and we're creating a new table called dbo fact revenue. So then if we refresh these tables, we should now have the first one, which is dbo fact revenue, this one here. And we can do the same for dim date and dim branch. We're going to be using these data sets just to show some of the functions that you need to be familiar with for the exam. We're not going to cover all of them because, to be honest, I'm not sure exactly the full breadth and depth of what is expected for the exam for T-SQL. But we're going to go over some common types of problems that you might see in the exam. So now if we refresh our tables again, so now we've got our DBO fact revenue, our dim dates, and our dim branch. So let's just start by visualizing our data here. So specifically, I'm going to be looking at this fact revenue, and these data sets come from the same data set that we used actually in a different part of this exam preparation course. It's relating to car sales and car dealerships. So you can see in our fact revenue table, we've got a revenue figure and we've got a date ID column and a branch ID column here. And that's what we're going to be using for the rest of this analysis. So what I'm going to be doing is presenting you with a series of problems, and then we're going to walk through how you might solve that in SQL. We'll be starting off quite simple, and then we'll be adding in more and more functionality as we go through. So what if we wanted to calculate the top 5 branches by total revenue? So to do that, we're going to be needing to perform some sort of aggregate. So this is what our fact table looks like currently. We've got branch ID and revenue. And what we want to be doing is calculating the top 5 branches. So what we could do is just select the top 5 here, branch IDs, sum of the revenue. So what we're doing here is doing a simple group by on the branch ID, because we're looking for the top 5 branches, and we're going to order it by the sum of the revenue. So this is the aggregate calculation that we're running on this aggregate here. It's a sum of the revenue, and we're ordering it by the sum of the revenue descending. So we're getting the top 5. Now let's change the problem a little bit, and maybe we want to return only the top 5 branches in Spain, or maybe the top 3 branches. Now Spain is a country name that comes from a different table in our data set. So what we've added in this example is an inner join on dim branch. And we're joining on the branch ID because we have the branch ID in both data sets. We're using an inner join here because we only want to return data for which we have both keys. Again, we're aggregating by the sum of the revenue. This time we've actually brought through a few different columns from that branch dimension table. So let's just run it all and see what we get here. Okay, so this query has returned the top 3, and what we've done is we've filtered this results for only country names that are equal to Spain. Now we've had to add in some new things into this group by selection because we've also got country name and branch name mentioned here. So we've also brought through the branch name so that we can just, we've got more than the branch ID. Maybe you're not familiar with the branch IDs, you want the actual branch names in this example. And we can see that that has brought through the top 3 branches that are in Spain by the total revenue. So that has sorted that problem. But what if we wanted to filter after the aggregate? So for example, give me all of the branches that have a revenue of greater than some amount. So here, we're not going to be doing the where statement because we want to be using having. So when you want to be doing filtering after the aggregate or on that aggregate value, then we're going to be wanting to use having, and that's going to come after our group by statement. So previously the where statement here, because we were kind of pre-filtering on this country name. Now we're looking for the results of an aggregation that are greater than, in this example, 5 million or 50 million. So we've got a very similar setup. We've removed the where statement because now we're not just interested in Spain. We want all the branches, and we're going to use this having some of the revenue greater than 50 million. So here you can see it's returned only 2 branches, which makes sense. What if we change this having statement, we removed one of the zeros? Yeah, so here we're just looking at 5 million. So when we've got 50 million, there's actually 2 branches that have more than 50 million revenue over this time period or over the full data set in that fact table. Now in this example, we've been using the inner join because that's what we wanted for this specific use case. But for the exam, you're going to need to be familiar with left join, right join, inner join, full outer join, all of these different join types and when they are useful for different scenarios. Now, we're not going to be going through all of these here because there's quite a lot to go through, but I definitely recommend, if you're not familiar with these things, learning the differences between these and when you might want to use one or the other. So another thing that you might need to be familiar with for the exam is common table expressions. Now, these are really heavily used in the world of SQL when you're creating views or things like that. So you need to be familiar with how you construct a common table expression, what the keywords are, what the general structure is, and that kind of thing here. In general, the common table expression allows us to define kind of like variables that we can use later on in our script. So here, we've got these 3 lines of a query. We're selecting the top 5 branch IDs and summing the revenue. We're grouping by that branch ID, so it's similar to what we saw before. And so we can actually just select these 3 rows and have a look at what that returns us. And then what we're doing is we're kind of saving that in this variable or this common table expression called top 5 rev. And the syntax here is always going to start with which is the keyword for a common table expression. You're going to give it a name, and then as open brackets, put in your expression within those brackets, and then we can use this top 5 rev later on in our query. Now, one of the other benefits of common table expressions is that we can create more than one of these. So for any subsequent expressions that we declare, firstly, we're going to need a comma there, and then we can call a second one branches. So for subsequent ones, we don't need the with keyword. We only need that on the first one. And so here I've defined branches as select branch ID and branch name from DBO dim branch. So this is what this one looks like. So we're just getting the branch ID and the branch name, and we're storing it as this branches. And then the final kind of section of a CTE is the select statement. So you're always going to need to return something from this common table expression, and we can do that with a select statement. So as we can see here, we're selecting the branch ID, the branch name, and the total revenue, and these are coming from top 5 rev, so that's our keyword for our first expression that we defined up here, and we're joining it with our branches, which is our second one here. We're giving it these aliases, and to run this we have to select all of the different sections and then press execute, and we get this result here. So we've got the top 5 branches by revenue, and then we've joined that on the last section of our CTE back to the branch data set. Now, obviously this could also be written in a different way. You probably don't especially need a CTE to return that result, but I just wanted to show you the structure of a common table expression, because you might get asked about that in the exam, or you might get shown some code that is in this format and you need to understand how it works. Another thing that you might need to be aware of for the exam are the lag and the lead function. So this is a way of creating new columns that reference other columns, but with some specified offset. So probably worthwhile just taking a look at a bit of an example here. So what I've done is I've defined another common table expression here. So in the first part, we're getting the top 5 branches, and then we're dividing this revenue by 1 million just to give us, a bit easier values to comprehend. And we're getting the floor of that division, so it's going to round down to single digits in this case. And we're defining that column as revenue in millions, just to make it easier to understand what's going on with this lag and lead function that we're going to introduce shortly. So this is what our data set looks like. We've got 5 branches and we've got rev, which are all single digit whole numbers now. So we've stored that as rev t, and next we're going to introduce a lag function over this data set. So we've got select branch ID and rev m, which looks like this, and we're going to add on another column into this using this lag function. So what the lag function is going to do, if I just run this, let's just start with an offset of 1 and we rerun this. So the lag function is going to look at the column which you pass in, which is revenue m, and it's going to look at the value of the row number minus the offset. So for row number 1 here, it's going to look at row 0, which doesn't exist. So that will return null. But for row 2, it's going to look for the value in row 1 of the column that we pass into the function. Now, another thing that we've done here is we've ordered it by this rev m. So the order here has changed. It's now in ascending order from 1, 2, 2, 3, 6, like so. And we can change this lag function to anything we want. So here we're doing it with a lag of 2. So the offset parameter here is going to be 2. So it's going to introduce another null because now we're offsetting by 2, and it looks like this. Now, hand in hand with the lag function, we also have the lead function, which looks in the opposite direction really. So rather than looking at the lag, so looking back in time, the lead function is going to look forward in time, or at least forward in your row index. So it's actually going to start on this row here. Now let's just change this back to a offset of 1. So we have, and let's just change this to lead. So when we run the lead function here on the same column, revenue m, with an offset of 1, this is going to be the result here. So now our first value in this lead column is actually going to be the value here. Similarly, this value is going to be here. This value is 3, 6, comes from here. And now we have a null value at the end of our data set because we don't have, a 6th row from which to pull that data from. Now, one thing to bear in mind is that we can't do something like this. So we can't do a lead or a lag with an offset of -1. The offset parameter cannot be a negative value, so bear that in mind. Now, another function to be aware of is the row number and partitioning. So row number, as the name suggests, basically runs through your data set and sequentially numbers your rows. Okay, so let's just run this first section of code just to have a look at what this is doing here. So here we've defined our row number and we've given it this name row num, and we've also passed in a partition value. So what it's going to do is it's going to group all of our dealer IDs. So here you can see in the output here, all of these dealer IDs, so dealer ID DLR001, this first one, all of these values are within that partition, okay? They're all that same dealer ID. And the row number is going to assign a row number based on the order, so the revenue. So these are all ordered in revenue ascending order. And then we're creating our row number 1 to 8 within this partition. Then you'll notice for the next dealer ID, DLR002, now we've got 10 values within this partition, ordered in the same way. And we've got row numbers defined here from 1 through 10. So that's this section within the CTE. What I've done is I've just selected star from parts, which is the name of our CTE. And I've just done a bit of a where statement just to only get 2 of the dealer IDs back. So here you can see this example here. We've got DLR001, which is this one, and we've got DLR0017, which is this one. So make sure you understand row numbering and partitioning and ordering by for the exam, because this is something that could easily come up. Now, the last section I wanted to mention, or the last topic that I wanted to cover, is subqueries. So for all of the other examples within this tutorial or this video so far, we've been using select star from table, right? So if we go back up here, we've got select all of this stuff from DBO fact revenue. Now a subquery basically doesn't have that structure of select star from DBO.table. Instead, we can actually open up a brackets here, and rather than doing a whole table or getting the data from the whole table, we can create a subquery that's going to basically pre-filter or do some sort of T-SQL query, return the results of that subquery back up to the top level here, and we've got to give it this alias of sub. It doesn't have to be sub, but that's just what I've called it here. And we'll see the results there. So what this is doing is first going to calculate this. So whatever is in our brackets, we're going to get the revenue figures just for these 2 dealer IDs, and then we're going to get select star from that result. So again, this is just a bit of a toy example just to show you subqueries in a bit of action, or at least the structure of a subquery, just so that if you come across it in the exam, you know what that is. Okay, so here we are in a data warehouse, and it's the same data warehouse that we were using for the first part of this video, the DW Gold. So we've got our fact revenue table, our dim date and dim branch in here. Now, specifically, I want to show you the visual query editor. So we can access it by clicking on a new visual query, and immediately we're going to get this introduction here. To build a visual query, you need to drag some tables onto our canvas here. So let's just drag on the fact revenue and we'll see what we get. So the visual query engine basically tries to make it as simple as possible to transform your data that is in your data warehouse or also in the Lakehouse T-SQL endpoint as well. So we've got our fact revenue table. So what can we actually do with it here? Well, you can see along the top here, we've got some kind of quick options for choosing specific columns, removing columns, that kind of thing. Filtering, so removing certain rows, sorting rows, transforming, we can do group bys. We can also do merging and appending different data sets together. So if we wanted to drag another one of these onto the canvas as well, then we can kind of combine those using either merge or append. But we're not going to do that in this example. Now, another thing that you can do within the visual query engine is to click on this plus button here, and we get access to a few more commands. So we've got all of the ones that are available in that top menu. Plus, we've also got some transformation. So we can do some text transformations on a specific column. We can do length, finding the first characters, adding columns using, for example, a conditional column or column from examples. So if you're used to using the Dataflow Power Query engine, you might be familiar with creating a new column from examples. And we can also do some adding column from text using these methods here. So say, for example, maybe I want to do a group by on this fact revenue table, and I want to get the median value. I'm just going to change this for the median, and I want it on the revenue column, and I want to group by our branches. So we also have this fuzzy grouping as well. So if this column is not particularly good quality, you might want to add in some fuzzy grouping, which is basically going to look at likeness or similarity between different values in that column. And if it's above a certain threshold, so they're very similar, so maybe there's just one character that's different, it's going to add it into the same group. So that's what fuzzy grouping would be. We don't want to enable that there because we've already managed our data quality. So if we do an OK here, you can see it's add in this step here. So now along the bottom, you can see the result has actually updated. So we've got this group by the branch ID, and we've got our new column, which is the median value within that aggregate, basically. So say I wanted to, I'll just remove this one because we don't want to be doing anything with our dim date. We've got our fat revenue now, and what we can do is either save as table. So this is going to save the results as a new table, or we can save it as a view. So you can see that this is actually grayed out here because you can't save this as a view because the query fact revenue is not supported as a warehouse view since it cannot be fully translated to SQL. And the reason for that is because we've used this median, and median is not actually a function in T-SQL. So what we can instead do is, rather than grouping by and aggregating on that median value, we change this to sum. I expect that, yeah, so now that error message or that warning message has now gone away. We might want to also change this to sum of the revenue, and then we can save it as a SQL view. So maybe we want to do sum of the revenue aggregation, give our view a name. It also gives you the SQL statement for that view, which we can copy to the clipboard if we want, and we just save it as a view, which you can query from a Power BI semantic model, obviously acknowledging the fact that with a view it's going to fall back to direct query mode if you're using direct lake mode to access this data. So that was just a tour of the visual query engine in the data warehouse. I think for the exam, just understand what it's capable of, have a look at the different functionality here, understand what you can do here, because you might get a question or two about the visual query engine. Okay, so let's just round up this video by looking at some practice questions that you could expect for this section of the exam. Question 1. The following SQL scripts creates the results shown below. What is function in this example? So we're doing select branch ID, column 1, and then your function, which you have to work out what that function is from sales, and we're returning that table below. So take a look at the answers on the right hand side, have a little think about what that function would be to produce the results in the table at the bottom of the page. Pause the video here, have a think, and then I'll reveal the answer to you shortly. So the answer here is A. We want to be using a lag function because we can see that what we're trying to do is make a transformation from column 1 to column 2. And we can see the pattern there that on row 3 in column 2, there's obviously an offset going on there. And we can see that the offset is 2 because row 3 in column 2 maps to row 1 in column 1. And we know there's going to be a lag function because column 3 is actually 2 rows behind what's on column 1. And you can see that replicates below with rows 4 and 5 as well. And another clue here is that we've got 2 null values at the top. So if you've got null values at the top, it's going to be a lag function because it doesn't have a value for that row 1 in column 2 and row 2 in column 2. So that one's always going to be null. So we know that it's got to be a lag function, and we know that the offset is 2. So it can't be B, which is a lead function. The lead function is going to look ahead of time rather than looking back in time. And the bottom 2 there have an offset of -2. So the offset in a lag and a lead is always positive. So those 2 would not be correct either. Question 2. You have the following query analyzing sales data for various products. Your goal is to analyze the sales data by product name and year, but only for the products that have a yearly sales amount of more than $50,000. How would you complete this query? So take a look at the different options there, have a think about how you would come to that conclusion that this question is asking for, and I'll reveal the answer to you shortly. So the answer here that we were looking for is B. So the question here is asking you to analyze sales data by product name and by year. So that is the first clue here. In our group by, we need to be grouping by the product name and the year, not the product key and the date key, because that wouldn't be the right aggregation for what the question is asking here. Now, the second part of the question is we're asking for products that have a yearly sales amount of more than 50,000. So the yearly sales amount of more than 50,000, that's going to come from our sum of the sales amount. And the sum of the sales amount is going to be calculated during that aggregation. So we need to be using having here. What we're trying to do here is filter out the result of the aggregate. We're not filtering out before the aggregate, because that would just filter out individual rows in this table. We want to be looking at the result of an aggregate function where the sum of the sales amount, not just individual sales amounts, the sum of the sales amount is more than $50,000. So the answer here is B. We need the group by, product name and year, and then having. We need to use the having statement to only return the product names with the yearly sales of more than 50,000. Question 3. You're trying to inspect a join between two tables to spot referential integrity violations. Which of the following T-SQL join types would be easiest to identify keys on both sides of the join that do not have a match on the other side of the join? Is it A, left join, B, right join, C, inner join, D, full outer join, E, cross join? So the answer here is going to be the full outer join. So again, there's two parts to this question, really. Firstly, we need to understand what a referential integrity violation is. So referential integrity is when you're joining two tables together. Obviously, you're going to be joining on a specific key. Now, a referential integrity violation would occur when one of the keys in the left-hand table is not in the right-hand data set, and vice versa as well. So to be able to identify that using a SQL join, we're going to be needing to use the full outer join, because the full outer join is going to bring back, firstly, the instances where those keys do match, and then secondly, all of the other results that don't match from both tables. So when we get this back, we're going to bring back some null values where there isn't an appropriate join or isn't an appropriate match on that join for the table on the left, and equally the same on the table on the right. So that's going to help us identify referential integrity violations by investigating where there are null values in that output. The left join and the right join, they're not going to help us here because we need to identify violations on both sides of that join. The inner join is only going to return the matching keys from both sides. And the cross join is just going to return us all the different combinations of the keys that exist in these tables. So that's not going to help us really identify referential integrity violations. Question 4. You have two warehouses, warehouse 1 and warehouse 2. You want to create a SQL view in warehouse 2 that combines data from both warehouses. Your solution should minimize development effort. Which solution do you recommend? Is it A, use a data pipeline copy activity to copy the table in warehouse 1 to warehouse 2? B, create a shortcut from warehouse 1 to warehouse 2 to perform the query? C, use cross-database querying between warehouse 1 and warehouse 2? Or D, use a Dataflow Gen 2 to read the table in warehouse 1 and set warehouse 2 as the destination? So the answer here is C. Use cross-database querying between warehouse 1 and warehouse 2. Now, within a warehouse, we can query any other warehouse within the same workspace. So this would be the most economical or require the least amount of effort because we can just query directly the data, the table, warehouse 1 from warehouse 2. B would be incorrect. Create a shortcut, because we can't actually shortcut from a warehouse 1 to warehouse 2. Functionality doesn't exist at the moment. And the data pipeline copy activity and the Dataflow Gen 2 wouldn't minimize the development effort. So that would technically meet the requirements, apart from the requirement that says your solution should minimize development effort. And this is something that you might see on quite a few questions within the exam. So when you see that, it's a bit of a flag that you should always look for the most efficient way of doing things, or normally there's a method that requires little to no effort against some that require more development effort. So the answer here is C, using cross-database querying. Question 5. You're using the T-SQL query editor and your goal is to add a new column to your dataset called salary bins. And this column is going to bin a continuous salary variable into 3 different bins: less than 30,000, between 30,000 and 60,000, and more than 60,000. Which functionality should you use to add this new column? A, add additional column. B, add column from examples from all columns. C, add column from examples from selection. D, duplicate the column. E, add column from text. So the answer here is A, add a conditional column. So when we're in the T-SQL Visual Query Editor, there's a few different options there to help us add columns. And for this specific use case, creating a new column, which is going to bin the values in a specific column, we're going to be wanting to use the conditional column, because that's where we can add in the logic for less than or equal to, and more than. And we can add more than one conditions on that column, which would help us achieve our goal of creating these bins in this salary bins column. Now add columns from examples. So these two are functionality within the T-SQL visual editor, but it's going to be very difficult to implement that logic from a columns from examples. It's not really a good use case for that type of adding column functionality. And deduplicating the column, well, that's not going to do much. That's just going to duplicate the column. And similarly, adding a column from text, that's also not going to achieve what we're looking for. So the answer here is A, adding a conditional column. We did it. Congratulations. We made it to the end of the study guide. This is video 12 out of 12, and we've covered an awful lot of ground over the last 6 weeks. So well done for sticking with it. It's a very tough exam. We've covered a lot of different things. This exam covers a very wide range of topic, from T-SQL, PySpark, DAX, all of the different planning and all of that sort of thing. So to get this far is a really good job. Now, as a bonus, I'll be recording one more video in this series, basically to help you prepare to take the exam. So things you need to know before the exam, when you're booking your exam, and whilst you're in the exam, to try and help you get as good a score as possible. So thank you very much for joining us in this series. I'll see you in the next video, which will be the final video. I look forward to seeing you all there. Hey everyone, you thought the series was over, but I've just got one more bonus video in this DP-600 exam preparation course. I really wanted to bring you some top tips for the exam. So we're not going to be covering any of the technical content, but I just have some words of advice or some tips that might help you when you're actually doing the exam itself. So this is the bonus round of our course plan. If you're just joining us here in this video, well, I recommend you go back through all of the last 12 videos, because that's where we cover most of the content. And I wanted to talk to you about booking your exam, preparing for the exam, some advice for during the exam, and then also what you should do after the exam as well. So when you're booking the exam, if you've used the AI Skills Challenge voucher, then make sure you schedule your exam before the expiration date. And that means you have to schedule the exam to be conducted before that expiration date. Now, I think that was the 24th of June, 2024, but double check that in your own emails that you have that date there. Now, if you don't have that AI Skills voucher that was given away maybe 2 months ago now, then you can get a 50% off voucher for the exam by completing the Cloud Skills Challenge. I'll leave a link to that in the description. So if you want 50% off the DP-600 exam and you still haven't booked your exam yet, or you still haven't got a voucher for it, you can use that there. And I've said this before, but I always recommend, if possible, to take the exam in person. Now, you might have heard there's a lot of horror stories for people that take it online, have an online proctoring experience, and they're very, very busy, and there's always problems with technology, and you have to clear your desk and clear your room, and there's all these kind of hurdles that if you can avoid by going to an in-person test center, I would very much recommend doing that. Appreciate not everyone lives near a test center, but if you do, or you can commute to one just for the exam, I would definitely recommend that. It reduces a lot of stress. You just walk in, take the exam, and walk out. So preparing for the exam. Well, obviously you can go back through these videos and look in the school community as well. I've got lots of notes in there. The reason I kind of created those was to help people who are, just about to take the exam. They can go through the key points and just make sure they remember everything as they go through each of the different sections in that school community. And if you're still not sure about anything in any section of the exam, you can dig into the further learning resources that I've linked in every section there. Now, one of the key resources that I would definitely use when you're preparing is the official practice assessment for the DP-600 exam. And again, I'll leave a link to that in the description. Now, you can go through this multiple times. I think it's a 50-question assessment, but you can refresh the page and you get fresh questions when you refresh. Now, I don't know exactly how many different questions there are in that exam set, but there's definitely more than 50. So go through that practice assessment numerous times to get a really good idea of the types of questions that you're going to be asked and to highlight any gaps in your knowledge. Another really good resource is the Microsoft Learn Together series that's kind of been running side by side with this series. I think we started around the same time. We're I think they finished maybe a week or two ago. Now, this is a really good series delivered by Microsoft MVPs. So there's lots and lots of content that you can go through there to dig in a bit deeper about any of the aspects in the DP-600 study guide. Again, I'll leave a link to that in the description. As well as the technical content from Microsoft MVPs, they've also got a few lectures or a few videos that describe to you what the exam entails. So if you've never taken a Microsoft exam before, I would definitely recommend watching some of those videos. I think they're at the end of that series where they walk through types of questions you might get, how to prepare for it, how much time you have, all of that kind of stuff, just so that you can enter that exam as prepared as possible. Now, as well as that, there's lots of other great content from other people in the community. Definitely recommend Data Mozart. Nicola's blog there, and also YouTube channel as well now. The Data Guy newsletter on LinkedIn, something managed by Abu Bakr. He basically collated a lot of learning resources for each section of the study guide. Definitely recommend that. Similarly, there's a post on serverless SQL by Andy Cutler, which is basically a guide to the exam as well. And in there, he highlights a lot of resources for the exam as well. So during the exam, I would say don't spend too long on one question. If you get stuck, then you can flag it for review and you can come back to it at the end if you have time. Now, a lot of people are saying that there's not much time in this exam. You have 100 minutes to actually do the exam, and there's normally around 55 to 60 questions. And some of the questions are very wordy, so it might take you 30 seconds or even a minute just to try and understand what they're asking you. So if you get stuck and you don't know the answer, don't waste too long on one question, just flag it for review and come back to it at the end. Now, you will receive at least one case study question where you'll be given a lot of context about a business and you'll be asked a series of questions afterwards. Now, I definitely recommend that you use a pen and paper to draw the case study architecture as you're reading that question, because normally these case studies, they're very complex and they'll describe a scenario to you. For example, company has capacity 1, and in capacity 1 there's workspace 1 and workspace 2, and in workspace 1 there's lakehouse 1 and lakehouse. When you're reading this, you don't really take any of it in. So I definitely recommend drawing it as you're reading it. This can really help you when you go forward to answering the questions, because you don't have to keep on going back to the case study, the context when you're answering the questions. You can just refer to your diagram. If you don't know an answer, guess. You don't lose marks for an incorrect guess, so you might as well. And bear in mind that the questions were created many months ago, so I don't think they've updated the questions since it was first came out. So bear that in mind. So a lot of the more recent features, they are not going to be the correct answer because they weren't in general availability when the questions were created. So bear that in mind. Now, a lot of the questions, I would argue, are ambiguous, or at least the answers. So what you have to bear in mind, or try and keep asking yourself, is what do I think that the Microsoft examiner is expecting to see here? So don't try and be too clever. Always think about what are Microsoft trying to teach us about Microsoft Fabric? How do they want us to use the platform? And always answer your questions with that in mind. So after the exam, so you'll know if you pass or fail directly after the exam. You get the results straight after. Now, if you fail, I would say don't be too hard on yourself. Honestly, it's a very, very tough exam. It expects you to be familiar with a very wide range of topics, right? For starters, SQL, PySpark, DAX, plus all of the planning stuff and all of the lakehouses, data pipelines, data flows. All of this stuff is a very wide-ranging exam that you need to be at least familiar with. So if you do fail, don't be too hard on yourself at all. And if you pass, then, well, congratulations, you can be very, very proud of your achievement. So that is all I have. Thank you so much for joining me in this series, and the best of luck for all of you that are taking the exam in the future. Thank you so much for joining me in this series. I'm going to be taking a short break now, and I'll be back on the channel with more videos teaching Fabric in the future. Thank you.